check. Hello, 1, 2, 2. Hello, 1. Test. Hello. Check. కొత్తగా చేయమన్నా. Check. 1, 2, 2. Hey. ఓకేనా సౌండ్?
India is the second largest producer and consumer of cement in the world. The demand for cement is increasing day by day and vital for the growth and development of the country. Chettinad Cement, a trusted name in the cement industry. Hailing from the Chettinad Group of companies, Chettinad Cement takes pride in being one of the predominant contributors to our nation's growth and infrastructure development in India for several decades. Chettinad Cement made its modest beginnings in Tamil Nadu in 1962 and has now spread across the country with several production plants. Puliyur, Karikali, Ariyalur in Tamil Nadu, Kallur in Karnataka, Nalgonda in Telangana, Dachepalli in Andhra Pradesh, a grinding unit in Solapur in Maharashtra. We are also planning a grinding unit in Vishakhapatnam and Odisha, besides the expansion of our Kallur plant in Karnataka. Our current overall cement production capacity is 14.7 million tons per annum. India is the second largest producer and consumer of cement in the world. The demand for cement is increasing day by day and vital for the growth and development of the country. Chettinad Cement, a trusted name in the cement industry. Hailing from the Chettinad Group of companies, Chettinad Cement takes pride in being one of the predominant contributors to our nation's growth and infrastructure development in India for several decades. Chettinad Cement made its modest beginnings in Tamil Nadu in 1962 and has now spread across the country with several production plants. Puliyur, Karikali, Ariyalur in Tamil Nadu, Kallur in Karnataka, Nalgonda in Telangana, Dachepalli in Andhra Pradesh, a grinding unit in Solapur in Maharashtra. We are also planning a grinding unit in Vishakhapatnam and Odisha, besides the expansion of our Kallur plant in Karnataka. Our current overall cement production capacity is 14.7 million tons per annum. What India is the second largest producer and consumer of cement in the world. The demand for cement is increasing day by day and vital for the growth and development of the country. Chettinad Cement, a trusted name in the cement industry. Hailing from the Chettinad Group of companies, Chettinad Cement takes pride in being one of the predominant contributors to our nation's growth and infrastructure development in India for several decades. Chettinad Cement made its modest innovation into reality. Into reality. believes in turning innovation into reality.
Good morning, ladies and gentlemen. Andarki Namaskaram and a very warm welcome to day 3 of this international conference, ACECON 2025, hosted by the Hyderabad Center of the Indian Concrete Institute. We begin the day with a corporate presentation from Chettinad Cements. We thank Chettinad Cements for the support and sponsorship for ACECON 2025. May I request the AV Desk to play the corporate video of Chettinad Cements, please.
India is the second largest producer and consumer of cement in the world. The demand for cement is increasing day by day and vital for the growth and development of the country. Chettinad Cement, a trusted name in the cement industry. Hailing from the Chettinad Group of companies, Chettinad Cement takes pride in being one of the predominant contributors to our nation's growth and infrastructure development in India for several decades. Chettinad Cement made its modest beginnings in Tamil Nadu in 1962 and has now spread across the country with several production plants. Puliyur, Karikali, Ariyalur in Tamil Nadu, Kallur in Karnataka, Nalgonda in Telangana, Dachepalli in Andhra Pradesh, a grinding unit in Solapur in Maharashtra, a grinding unit in Visakhapatnam and Odisha, besides the expansion of our Kallur plant in Karnataka. Our current overall cement production capacity Chettinad Cement believes in turning innovation into reality. What you give is what you get. That's the law of nature. The Chettinad Group is committed to its values of protecting the environment through sustainable development, new facilities, and gives great importance to safety. All our plants are equipped with modern technology, coupled with innovative initiatives that ensure energy-efficient and pollution-free cement production. The entire manufacturing undergoes rigorous quality checks to ensure consistent quality from raw materials to final products with BIS compliance and ISO certifications. An expert technical team and experienced marketing team deliver our world-class cement to millions of users across India through a committed logistics service. Chettinad Cement offers a wide array of products for vast applications and specialized purposes. Chettinad OPC 43 grade cement, widely used for military engineering services, central and regional state public works. Chettinad OPC 53 grade cement, ideal for high-grade concrete, nuclear power plants, ready-mix concrete, precast concrete structures, hollow and paver blocks, and infra projects. Chettinad Portland Pozzolana Cement, a premium high-quality pozzolanic cement suitable for mass concrete and durable structures. Chettinad Portland Slag Cement, optimum for marine structures, chloride-exposed areas, ports, harbors and docks. Chettinad Composite Cement, an all-purpose cement for sub and superstructures. Due to its rich silica content, it resists attacks from marine environments and delivers high long-term strength and lowers the heat of hydration. Chettinad sulfate-resisting Portland cement is suitable in all conditions where the concrete is exposed to attack by sulfates and structures close to marine environments. Chettinad Cement's footprint ranges from individual house builders to metro rail projects, NHAI, military engineering services, railways, state and central public works departments, and so on. Chettinad Cement comes out with yet another innovative, greener, smarter, stronger, premium product, ideally suited for concrete. Stronger cement for durable concrete. Chettinad Maxcrete Cement. Chettinad Maxcrete Cement is produced at our state-of-the-art manufacturing units by intergrounding Portland cement clinker with a controlled dosage of quality fly ash and gypsum and packed in high-quality tamper-proof BOPP bags. This versatile product offers a reliable quality with a unique blend of quick setting and high early strength, which leads to a robust construction in fast phase for domestic, commercial and infra projects. The applications include roof slab concrete, hollow blocks, precast structures. Advantages of Maxcrete. Better particle shape and uniform particle size distribution of Maxcrete exhibits extended max workability. The fast-setting nature of Maxcrete contributes higher one-day strength, enabling early formwork removal in concrete, assuring max early strength. Concrete made with Maxcrete exhibits a stronger and denser concrete matrix with better transition zones. It reduces the heat of hydration and resists thermal cracks in mass concretes, resulting in a max concrete matrix. The pore refinement nature of Maxcrete reduces the permeability of concrete, resists ingress of chloride and sulfate attack, which provides max life cover for concrete structures. Besides providing better workability and quick early strength, Maxcrete continues its strength development even after 28 days, ensuring durable concrete with speedier progress of construction schedule and reduces the cost of construction, providing max performance. Chettinad Maxcrete Cement. Stronger cement for durable concrete. At Chettinad Cement, technical service is the experience we deliver to our customers. Chettinad Cement is the first Indian cement company to introduce a first-of-its-kind testing facility for construction customers at their doorstep. a complete one-stop solution on wheels, comprising the testing of various construction materials, live demos at no cost by our team of expert civil engineers to ensure sustainable construction. We deliver a high-quality green cement. Chettinad Cement believes in turning innovation into reality.
Thanks to Chettinad Cement, and we would like to convey our gratitude on behalf of the delegates also for their wonderful sponsorship. Please put your hands together for Chettinad Cement. Thank you, sir. Thank you so much. Now we'll have a very quick 1-minute video of 1CCC by NCCBM.
The 17th edition of the prestigious International Congress on the Chemistry of Cement, ICCC 2027, will be held in New Delhi, India. The 17th ICCC is being organized by the National Council for Cement and Building Materials in collaboration with IIT Delhi and IIT Madras. The theme of ICCC 2027 is Achieving Sustainability and Carbon Neutrality in Cement and Concrete. The Congress will take place at the state-of-the-art Yashobhumi Convention Center in New Delhi. The call for papers is now open. Researchers, academicians, and professionals are invited to submit abstracts. The last date for abstract submission is 31st January 2026. Abstracts can be submitted through the official website iccc2027india.org or through the ICCC 2027 mobile app available on the Google Play Store and the Apple iOS Store. We look forward to welcoming you to New Delhi for the 17th ICCC 2027, a landmark global event shaping the future of cement and concrete.
Thank you. So, ICCC will be at Delhi. Request all of you to please mark your calendars by October. It's a 4-day event so that you can be there. While that event happens in Delhi in October, we have got a flagship event of Indian Concrete Institute in the month of February. And that is a Deminar. May I have the Deminar's PPT also quickly flashed on the screen for the benefit of our delegates and speakers, please? You can please bring up the Deminar PPT, please. Deminar PPT, please. Deminar PPT. Deminar is a 2-day event, a national stature, where it is a very unique event where the concept or the terminology Deminar originates from a seminar and a demonstration. These happen simultaneously alongside one another physically. While the speaker speaks on the stage, simultaneously we will have that being executed in the very same premises next door. So for example, a 3D talk going on in the auditorium, a person can step out, the delegates can step out and also get a touch and feel of how exactly the 3D printing is going on. Likewise, even the concepts of high performance concrete or high performance fiber reinforced concretes, these can be demonstrated, for example, by the construction chemicals industry to ensure the flowability and demonstrate even the equipments, tools, plans, technology, and systems of construction like formwork. This can also be demonstrated, and I request all of you to please visit our website www.indianconcreteinstitute.org to always keep updated. So next slide, please. These are the past glimpses of Deminar. Deminar in 2026 February will be the 12th edition, and it's a very successful event. Next slide, please. So you can see the various doyens of the industry who participate and share their expertise and experience. So you can see the demonstrations happening here, and you can also have the exhibition stall for a static display. Like for example, we had the demonstration on a high performance flooring going on, and this time we will also be providing a link. For example, anywhere across the globe would like to showcase your on-site execution prowess or something going on in a laboratory, or even your manufacturing process, you can do that live, beamed from your plant anywhere in across India or across the world, and we can bring it back to the auditorium. So please get in touch at ICI Bangalore. We have got the address in the brochure. Please get in touch. It is available on the website as well. So these are the past glimpses, and as you can see that this is a demonstration of the form work that was done some time back. So these are the previous views of the seminar. And then this time we have it at the Nimans Convention Center, a world-class facility for expos, and will be available for have. Thank you so very much. This is called Concrete Panorama and Seminar, and the theme, may I remind you, is COMET, which is Construction Material Systems, Equipment and Technology, Trailblazing the Future, 25th and 26th of November at Bangalore. I look forward for all your continued patronage. Thank you so very much. We begin today's conference, and the chair of the conference is Professor N.V. Ramana Rao. Before I request him to come out to the stage, may I quickly introduce you to his latest achievements. He is not new to us, but let me let me highlight certain latest achievements and the profile that he has got. Professor N.V. Ramana Rao is the director of NIT Nagpur, Raipur, and he will be speaking on form-based structural optimization of high-rise buildings. In addition to that, he will also be the session chair of this session. He is the director and professor of the civil engineering at the NIT Raipur and holds degree from Osmania Universities and an MTech from IIT. And his PhD and postdoctoral fellowship are from University of Wales, UK. He has about 33 years of expertise and experience in the civil and structural engineering, and has served in several key academic and administrative roles, including that as the director at NIT Warangal, the rector, registrar and principal at JNTU Hyderabad, and the director of BICAD. He has received numerous honors, including that as an Outstanding Concrete Engineer Award in the year 2012, the State Best Teacher Award in 2011, the Commonwealth Scholarship and Fellowship, and also the Eminent Engineer Award in the year 2018, and the Bharat Ratna Sir M. Vishwesharaya Prize in the year 2020. Dr. Rao has published over 186 research papers. He has authored and edited several books, including guiding over 80 plus MTech theses and 13 PhD scholars. He has also delivered many invited lectures across Bharat and abroad. He serves on numerous national committees such as the AICTE, UPSC, IRC, ISRO, NCP, TSHC, and the JEE Apex Board. His expertise spans structural engineering, optimization, bridge engineering, high-rise structures, concrete technology, repair and rehabilitation, and large-scale academic administrations as well. Ladies and gentlemen, please put your hands together to welcome the session's chair, Professor N.V. Ramana Rao. Please start. Welcome, sir. Sir, this is for forward, this is for backward, and this is a laser.
This is what my presentation.
Your presentation.
No, this type.
Yeah. You will start with your presentation, or you can invite your speakers.
No, this is.
Mr. Hegde, yeah, you can start with it and go on. And when will your presentation be later?
It was there after. No, is it 11?
Done. You start with these two. Start. Thank you.
So I am the session chair of this plenary session. So the first address is by Engineer V.N. Hegde, From Risk to Resilience, Rethinking Infrastructure Codes for a Changing Climate. So Hegde, can you can come and start presenting your...
Are you going to put the presentation? Thank you very much. Somebody is going to put the presentation over here. Yes, thank you. I think, I think if it's a mic. Yes.
Color mic.
So, yeah, this is backwards and laser. Laser is working, right?
Yes, it's working.
Thank you very much. That's it, that's okay. Okay, thank you. So, good morning to all, and first of all, I think I'll have to admit here, I'll have to concede that to be preceded as well as followed up by renowned professors across the world in the plenary sessions, I think it is really unnerving, I should say that, like I try my level best to match up with those renowned professors of this plenary session, and I have chosen a topic which is, I think, topical. In fact, that is risk to resilience. I will be speaking particularly in the context of India, basically. And you all know that India is been talking about the Viksit Bharat 2047 in many of the forums as well as the seminar across the country. And when we are celebrating this Independence Day, after 100 years on 2047, what we want to be remembered as a nation which is dreamt big or built big. I think it's a built big. So the built environment is a very, very important aspect. The infrastructure is the backbone of any development, as all of you are aware of it. And by 2047, if you really want to be a Viksit Bharat, we will have to have the economy of around 30 to 35 trillion economy, as you can see here. And it's not only the economy has to be 30 to 35 trillion dollars, but also it has to be a world-class infrastructure matching with the G7 standards, and it has to be sustainable, carbon neutral, as well as the resilient. That's what I'm going to demonstrate in my presentation going forward. All of us know that the infrastructure's four pillars are physical, digital, social, but most importantly by 2047 it will be founded on the sustainability, basically, if you really look at it in the Indian context. Just have a look at the quantum development which has taken place in India from 1947 to 2025, that's as on date. In any of the infrastructure sector, if you really take it, whether it's roads, highways, railways, power, energy, water, sanitation, up to the bridges and megastructure, it is phenomenal. You just have a look at it. If you just compile it up to 2025, just for example, the roads and highways, which was around 0.4 million kilometer, which was almost unpaved in 1947, and by 2025, you have 6.3 million kilometers, and we have been talking about the expressways. It is a phenomenal growth, actually speaking, though we have been talking in the recent past, some lacuna in the development, but it has been phenomenal growth. That was based on physical, digital, as well as the social development. But what we are going to see, if you are to be a Viksit Bharat in 2047, in coming 22 years, that is 2025 to 2047, it has to be totally based on the sustainability aspirations. If you really look at it in any of this sector, if you really look at it, it has to be smart green corridors, it has to be 100% electrified, high-speed railway network as far as the railways is concerned. Power and energy has to be net zero, 70%, plus renewable energy has to be there, and water and sanitation, universal safe water, 100%, so on. What I mean to say is, the growth which is going to come in the infrastructure for 30 to 35 trillion economy, out of 30 to 35 trillion economy, 70% has to come from the infrastructure again. That's very interesting. All we civil engineers, I think, is in a very, very good situation, in my opinion, if you really look at it. 30 to 35 trillion economy has to come from the built environment, and all has to be without fail, has to be based on the sustainability. It has to be sustainable, it has to be carbon neutral, it has to be resilient. That the foundation for physical growth has to be there, as you can see here. Now this particular slide, I just don't want to spend much time on. All of you are aware, carbon dioxide is increasing and the global mean temperature is increasing, which is leading to the manifestation of the many of the extreme events, especially on the infrastructure, as you can see here. Now this is also one of the slides very well known now. I don't think we'll have to get into the explanation of that. The world carbon footprint because of the built environment is around 42%, and ours, as per my calculation, is around 52% in India. Actually, if you really look at in the Indian scenario. Now, as far as the environmental impact analysis is concerned, and the Indian region has experienced from the pre-industrial era, that is around 1900 to 2018 to 2020, around 0.7 degree to 1.1 degree centigrade up to here 0.7 degree. Now, from there onwards, it's up to now, it's around 1.1 to 1.2. People is talking about even 1.4. I think that figure is quite variable. One of the studies, it's very important study which has been done on the bridges particularly. I assume it is synonymous, it is applicable to the other infrastructure also. From 1977 to 2017 by Dr. Garg et al., it says for the failed bridges, I'm again repeating it, failed bridges, the average life is around 34.5 years for the failed bridges. Almost around 200 bridges during the service, which has been studied, that it has been found out around 34.5 years. And these bridges have failed because of the natural disasters as well as the material degradation. That is mean 90% of the failed bridges in the last 40 years, if the study is done on around 2020, and if you go back, it's around 1980 to 2020, 90 natural disaster as well as the deterioration of the material is accounting for 90% of the failure. That means, I think the effect, the toll on the infrastructure because of the climate change effects, in my opinion, is started from the 1980 itself in India. If you really look at it, if you go by this statistic, basically. Now, all of us are aware, particularly if you really look at the Indian environment, that the Indian region mean temperature is increasing, as I told, from up to 0.7 degree from 1960 to 2018, and onwards it has been increasing. And especially if you really look at it, there are 2-3, like the representative cost concentrated pathways, what they call it as RCPs. And if you take the worst RCP by the end of this century, it is expected to reach around 5 degrees centigrade. And that is why by now to 2020 to 2050 or 2070, we say it's a climate emergency where we'll have to peg down the globe mean temperature to around 1.5 degree to 2 degrees centigrade. Now they are talking about 1.5 degree. Otherwise, I think all the manifestation which you are saying earlier is going to take place. And there are, there are warmest day and the coldest night, 4.7 degree to 5.5 degree. Frequencies of occurrence of the warm days and nights increased by 55%, and 75% is expected by the end of this century. The frequency of summer heat waves is projected to 3 to 4 times by 2040 to 2100 as per the studies in the Indian context. I'm talking here with the Indian context here. Now also if you see sea surface temperature, you look at the trend of the sea surface temperature over here, again because of the increase in the global mean temperature, again up from 1951 to 2011, almost around 0.15 degree centigrade per decade. And going forward, it is expected to increase by 0.13 degrees centigrade by decade. by the RCP 4.5, not by the RCP 8.5. If you are able to peg down, do the carbon neutrality measures which we take, it is expected to raise by around 0.13 degrees centigrade. Otherwise, if it is going unarrested, I think it's going to be 0.35 degrees centigrade. If you really look at it, even the ocean heat content also is notably increasing, as you can see from this slide over here. As far as the precipitation pattern is concerned, all of we are experiencing a very frequent and intense wet falls. As far as the dry falls, it's not necessarily always the precipitation is more in some areas. The precipitation is also less in some areas, as has been shown in this particular slide again. And sea level rise, I think it's again interesting. While Indian sea level is expected to go up by the 300 mm, as you can see here, this is the India, and while global sea level rise is expected to be 180 by the end of this century, that's 2100, and in the last 1874 to 2004, it has raised by the 3.3 millimeter per year, as you can see here, 1993 to 2017. Now, frequency of the extreme floods, like that's also has been studied depending upon the warming scenario, whether it's 1.5 degree as well as the 2 degrees. And it is expected to increase, that the Indus, Ganges, Brahmaputra river basins are projected to be increasing steadily, as you can see here. This is particular slide, bottom particular graph you can see here, and that is going to increase. This particular study of the very severe cyclone storms during the annually, it was reducing, though in the last 1951, actually speaking from here, here at the end, it is slightly increasing, in the recent past. But important to see that the frequency of very severe cyclone storms, that has been, that is particularly post-monsoon, which we have been experienced severe increase in this particular. These are the risks which we are talking about. So, what are the risks and the climate change effects on the infrastructure? I have just to put it on in an infographic model over here. This is which has been encapsulated in the capsule in between over here. The effects of climate change over here: increased carbon dioxide, higher storm intensity, decreased precipitation, temperature increase. There's around all this thing, change in the relative humidity. If you really look at the infographic model, say for example, increased carbon dioxide emission will lead to the material degradation as well as the flooding and SLR. Higher precipitation is a cause for so many, pavement and rail damage, severe storm surges, material degradation, flooding and SLR, higher risk of the settlement, higher risk of liquefaction, higher risk of hydrostatic pressure. If you come up to this permafrost as well as the ice melt, deeper and the fastest score because of the sudden flash flooding. And also, if you really look at the flooding as well as the sea level rise, take the case of change in relative humidity, increased creep and sinkage, and also the faster and higher pre-stressing losses, So if you really look at the infographic model, the risks are mentioned on the infrastructure at the periphery of this, as well as in the capsule here inside, the effects of the climate change which has been encapsulated. The same thing, I try to put it in the form, I try to prepare an infographic model for this also, but I was late in preparing this particular. If you really look at it, what are the risks? Durability risk, serviceability risk, geotechnical risk, increased demand risk, accidental load risk, extreme rural natural event risk, and after that operational risk, which can be classified into. Now, I'll just very quickly run through some of the risks because of the climate change. We have seen that climate change affects the risks because of the climate change. If you really look at it from the Indian context, again, I'm just confining myself to the Indian context over here. higher temperature, increased precipitation, increase in relative humidity, higher carbon concentration, all will be leading to the material deterioration. Corrosion in concrete and steel, damages to plastics, biodegradation of concrete and timber due to the growth of organism, all this will be taking place here because of the climate change. This is the Kali Bridge failure. I think, in my opinion, one of the contributory factor could be the climate change. Like that, the corrosion and so many other things could have happened there. Degradation of the elastomeric bearings also we can foresee in the future, near future. Then substructure similar to that of the superstructure. I think you can have superstructure whether it's of the building or the bridges for that matter. It is all this the same causes, but additionally in the substructure, the lower ocean pH value, ocean acidification will also cause the degradation, as you can see here. This is all corrosion as well as, like this splash zone is changing because of the change in the splash zone will also affect basically the corrosion patterns, etc., as you can see here. Now, heat-induced damage. I think it can lead to the buckling of the decks, as you can see here on the right-hand side, and because of the globe mean temperature itself is increasing, and also the railways, like the railway lines can buckle. That is the possibility of the railway lines can buckle, and it is expected the rut depth in the pavements may be threefold by 2040, 2050, especially in case of the pavement, and reduce the remaining fatigue life of the critical bit details also is possible, according to some of the studies which has been published. And also the increase in precipitation may increase annual road maintenance costs as much as 60 times by 2080, according to one of the studies. That's what is expected, both railways as well as the payment which is expected in my view. So, and also the long-term deformation. All of you are aware, in all over the world, the bridges which has been done according to the cantilever construction, because of the long-term creep, the deflection take place. This is one of the example in India, where within the 40 years, this the record holding bridge, when it was constructed, almost 5-kilometer bridge by the cantilever construction has to be replaced, the superstructure has to be replaced. That is basically because of the long-term creep model which was adopted at that particular point of time, the excessive deflection, because especially in the pre-stressing situation, the long-term creep cannot be avoided. Only you will have to find out we will have to maneuver to, like overcome it. It's not possible to completely avoid it. I think the creep models have changed now because of some of the studies. I think, but again, the relative humidity is changing, the temperature phenomena is changing. I think again we may have to rework on the creep and shrinkage models. I think it may not be, climate adapted code yet. I'll come to that later, as you can see here. Risk of higher score, I think because of the sea level rise also is there, and frequent high intensive precipitation may lead to the sudden increase in the water depth and the velocity of the river, and the scouring can take place, leading to the settlement of the foundations, whether it's the bridges or whether it's even for the buildings. You can see that. These are all Indian conditions. Risk of landslides. It's very interesting, the climate change will negatively impact slope stability and potentially lead to more frequent landslides. I don't have to explain. You have been hearing what's happening in the sub-Himalayan terrain, particularly these days, and it has been happening. It's not only that, even in places like Kerala, and you can see that the landslide is worsening, as you can see here. So that is basically, one of the reasons it has been said that death of some of the vegetation species due to the elevated temperature, which was holding that, the roots were holding the slope to be stable, but I think those sort of vegetation is also dying. That could be one of the reasons it has been said. Change in the wind climates and the faster water flows is all leading to this. Foundation settlement, I said that it's been happening I have been hearing the settlement of the foundation. This is building collapse in Bangalore after heavy inundation, which took place. And also the bridges have been, like the foundations has been, even the foundation, the well foundation which has been plugged and which has been there for a long time is settling, That could be this cannot happen. It's very difficult for that to happen during the service life. If it has to happen, I think there could be a contributory effect of the climate change in my particular opinion. Now, also the risks of rock falls and avalanches, that basically takes place because of the melting of permafrost can induce less stable rock slopes and cause debris and flows. Higher temperature may lead to the snow melt and increase the risk of the avalanches. It has been also observed in India. Because of the change in the water table, groundwater table, the liquefaction also can take place. And the soil liquefaction can take place during the earthquake. That sort of possibility is also there. Water table rising also can lead to this kind of situation. Of course, negative skin friction is possible if the subsidence of the soil, for whatever the reason, is taking place. Clay shrinkage and swelling pattern may change. That is because of the additional evapotranspiration. That is the increase in seasonal contrast in precipitation, and higher temperatures will lead to this. Basically, that can happen. Wave impacts, I think, are being reported, and frequency and height of the extreme waves are increasing. The impact of the earthquake and tsunami, coupled with the sea level rise, has been more intense and disastrous consequences in the recent past, and it can improve, it can increase. These are all some of the studies. I am quoting it from the studies. It's not my, basically the research which is available on the basis of the studies which I have been presenting over here. This is not known yet. I think I am expecting that, even the wind impacts could be there. But that is, the wind impacts could be there because of the frequency of the cyclone. Very severe storms and the cyclone could happen. It may change the wind patterns, and the turbulence is possible, and the flutter is possible. And but it is hypothetically put over here. I think there's no proof for this yet. As you can see, this is going to be changing. The temperature seasonal variation which we have been giving for the structures, even the thermal gradient, I think perhaps in the course we may have to rework, and it may not be no more valid. Whatever the gradients which you are taking for the calculation of the thermal stresses, I think it may not be valid, and also we may have to relook into this the mean temperature, uniform temperature also, as you can see here. What we call it as the maximum minimum shade temperature plus the range of temperature at that particular location may have to be looked into. Inundation, I think all of you are aware. I think all the cities in India is subjected to the inundation. That's maybe because of the sea level rise. I think so many others, but certainly it's because of the climate effects, climate change effects. I see that, and also the hydrostatic pressures on the foundations, especially the abutments, can increase because of the rise in the groundwater table, and also the rise in the water level itself. Some of the barrages which has sluice gates, I think on that the pressure may come. When the pressure is coming more on that, naturally, which is connected to the piers, I think that will be experiencing the higher pressures, as you can see here. Pre-stressing, the creep and shrinkage will have to be reworked. I think because of the change in the creep and shrinkage pattern, pre-stressing losses also may increase, as you can see here. That is because of the low or the higher relative humidity that will cause the problem over here. Vessel collisions, I think there's a classical case of Amigo bridge incident in Sweden. That is because of the incloud liquid water content of marine fogs will cause the poor visibility, and while navigating the vessels, I think this sort of situation could be there. I'm not sure it is the same case in case of the Baltimore bridge. It could be the different reason. I think there is some navigational problem as far as this is concerned. It may not be because of the climate change effects, but in future, because of the poor vision, not only the vessel collisions, also the like the vehicles can, because of the poor visibility or the fogs which has been coming may lead into the lot of train derailment. That is because of the train damage to the pavements and rails can increase the occurrence of the vehicle accident and train derailments as you can see here. You may be thinking that I'm projecting a very scary situation here. Like I'm projecting the very scary situation and the extreme natural floods. I think all of you are aware of it. Inundation, it causes a lot of problems and can reduce the growth of coral reefs, doubling the impact on the floods. That is because of decrease in the ocean pH, increase in the ocean temperature, and increase in the intensity and the frequency of the tropical cyclones. When the growth of the coral reefs is reducing, I think there's again the increased possibility of this kind of the floods which has been taking place. Of course, storms and cyclone. Some of the examples in India: cyclone Muiching Bay of Bengal in Tamil Nadu, cyclone Bulbul in the eastern state of the West Bengal in India. Recently, we have been hearing quite often, and it has been expected, especially in the as per the IPCC 2013. If you really look at it, more than 99% probability that since the 1970s, intense tropical cyclones have increased over the North Atlantic, and it is more likely than that not. More than 50% probability that the further increase will be observed in the future. That may be applicable to Indian oceans too. The study has been done on the Atlantic Ocean. And in addition to the stronger and more frequent storm, the higher surge launching level offered by the sea level rise and the higher waves further exacerbate this particular risk, as you can see here. So this is the California. It has not happened in India. As you can see here, this is again it has been said, at least by the media reports, I understand it's because of the climate change effects. Like there's a drought in the increase in the temperature, and there are some bridges which has been burnt because of the wildfire, and the dry situation, the increase in temperature. These are the situations will aggravate because of the climate change. Of course, it is not in India. Some of these bridges may have to be closed down because of the excessive snow. Yes. Only, I have left with 3 minutes, I think. Yes, I will look into that, sir. Yes, so this is how it can take place. And because of the wind effect, this may be increased, as you can see here. This is also wind advisory on the Confederation Bridge, as well as the wind restriction on the Varnoza narrow bridge. And this sort of wind advisories may increase if the wind speed increases there. That also has to be operational difficulties which has been there. Even the power shortage could be there because of the higher temperature can reduce the electricity production for the thermal power plants. The decrease in precipitation in some places accompanied by the increased evaporation due to the higher temperature, more power outage events due to the increased frequency of extreme events, and that is storms and foundation. All these things can lead to the shortage in power, and that may lead to the operational difficulties in turn. So, this is the risks on the infrastructure because of the climate change effect. We'll have to really manage that. How can we manage augment of the climate change risk can be done? One of the ways of doing it is by really combating is by taking certain actions. That's the warning systems. Basically, you can see here in the sector water resources and coastal management, we can do implement integrated water resource management, establish integrated coastal management strategies, and strengthen hydrological forecasting system, enhance. These are some of the, basically the warning and forecasting system that has to be done. If the warning and forecasting system in all the sectors, I think we can implement those, develop robust early warning system, improve disaster preparedness plans, mainstream multi-hazard risk assessment framework. I think this is very important. Mainstream multi-hazard risk assessment framework as far as the infrastructure is concerned. So, coming to my topic, I've got only one slide. I see there's a strong requirement to change our codes to the climate adapted design codes, basically. And whatever the codes which are there, they are not the climate adapted codes. We have been designing our structures. I think it's necessary for us to really look into that. And the validity of the design code is, in my opinion, no more possible. Especially there is a possibility or the reason, strong requirement to look into the action side, basically to rework on the load factors and also on the material degradation point of view to rework on the material safety factors basically. I think we all know the design for the infrastructure is nothing but, then the resistance action is resisted by our members, by the dimensioning of the member. There is all these actions which I explained so far, I think we need to rework. Or we may have to think whether we have to have a separate limit state itself, we have got a serviceability limit state, ultimate limit state, fatigue limit state. Do we have to have a climate change limit state itself? I think we need to really relook into that. I think there's a lot of work to be done. And that is why I said, I think this seminar is all about professors and students. There's a lot of research work to be done for working out this, to arrive at this load factors as well as the safety factors as concerned, and particularly the effective temperature and temperature gradient, the creep shrinkage effect, studies on the corrosion and fatigue and strength of the materials because of the climate change, UV climate dependent stochastic simulation framework for TC wind and rain hazard, sea level rise effects, climate change effects on the earthquake, change in geotechnical parameters. I see a lot of research opportunities for the civil engineering fraternity. Actually, whatever the discipline of civil engineering they belong to, whether it's environmental, whether it's hydrological, hydrology, hydraulics, structural engineering, everywhere I think there's abundant opportunity for us to do the research. And by doing that, we can have a roadmap to achieve basically the resilient infrastructure by 2040s. I think I'm proposing it in 3 stages. By 2025 to 2030, do the research, build the standards as well as the codes, build the standards as well as the codes, and the pilot projects have it. And by 2030 to 2040, scale resilient infrastructure nationwide. That's what you do. Because of the paucity of the time, I'm not going to get into the explanation of that. And by 2040 to 2047, net zero aligned infrastructure ecosystem will have to achieve. That is what it is all about, Viksit Bharat. Thank you very much. And I think time is up. Our, computer and artificial intelligence telling me. So thanks for the time, for giving me an opportunity to present my view on the climate change effects as well as how the resilient infrastructure can be built. Thank you very much. If any questions, I can take it.
I think we have time for 2 questions.
Yeah.
Please introduce yourself and then you can ask the question.
Thank you for a very good presentation, and you have convincingly provided a very dire future if you don't do anything. And you provided some action item. Listening to your talk, one action item that comes to my mind, there are 2 issues you mentioned: material degradation and increasing creep and shrinkage. All of this occurs primarily what happens at the surface. So can we come up for the existing efficient way of coat, so surface becomes, almost impermeable, so we can prevent material degradation and increasing creep and shrinkage?
Yeah, I think I said that is, if you really look at the managing the climate change effects, that could be one of the ways, I just wanted, if at all, you have to, because of the change in the temperature as well as the relative humidity itself, you agree that creep and shrinkage is going to be changed. I think could be one of the ways of doing it. Could be one of the ways of doing. But we cannot do away with doing the research on the creep and shrinkage models because of the climate change effects. Also, the temperature gradient which has been taking place across the structure. That we need to do, right? That's what I feel. And also the carbon dioxide, which is also causing the material degradation. That's also we'll have to understand how do we combat with that carbon dioxide. Like yesterday, Professor Bhantia was telling, like it will. That's a very good way, sequestering inside the concrete is carbon dioxide will get mineralized. I was thinking that he was talking about the sequestration. When you say sequestration, it is entrapping, but he was converting it. He was talking about the mineralization of that. I think that's one of the, but you can do that what you said, but I think we cannot do away with doing the research to come out with the climate adapted codes at the standards, in my opinion.
Good morning, sir. Shall I have the question?
I think, okay, last question.
Sir, myself, Dr. Narasimha Rao, Chairman, ICA Rajabandhu Center, sir. Sir, I have one quick question. Regarding the recent times, due to the climatic changes, we have abnormal changes in the rainfall intensity and also the flood discharges. Most of the bridges that what we are seeing, the failure bridges, it is due to the score-induced flood discharges. In the event of these climatic conditions, what?
I think there's an echo coming. You keep your mic here.
Sir, in the recent times, we are seeing. Is it clear, sir?
Ask the question exactly. Okay.
What is the reasons for the climatic changes effects on the bridge-induced cores? Scoring effect on the climatic changes. In the recent times, we have seen so many bridge failures due to the score-induced failures. That is mainly attributed due to the climatic changes. What is your strategy on that?
Yeah, you see, the thing is basically the high flood levels, HFL is increasing. Return periods of the flood is changing. It could be the flash flood because of the melting of the glaciers as well as the snow which has been taking place. I think all this thing will lead to the additional scoring basically, right? So, in fact, the hydraulics and the hydrology is affecting most our infrastructure compared to the other material deterioration which has been taking place. Actually, most of the bridges as well as some of the buildings, in my opinion, though the building people may not accept it, I think might be subjugated to the climate change effects.
So, thank you, Professor Engineer V.N. Hegde. Yeah. I think if there are many more questions, you can take it during the tea time. So, we thank you very much for a wonderful talk on risk to resilience. Especially you highlighted how natural calamities can deteriorate structures. You have given several examples due to deterioration due to earthquake, wind, hydrostatic, shrinkage, creep, and many other examples. And you also highlighted how the codes will now have to adapt the resilience, keeping in view the climate factors. So what you call as climate adapted design codes, I think is excellently brought out and is a good food for thought for many of us researchers. So without wasting any further time, I would like to invite distinguished Professor Ravindra Gettu, who will be speaking on textile reinforced concrete challenges and opportunities. We have been talking about many different types of concrete. Professor, you have 30 minutes.
What you give
Thank you very
is
much.
what you get. That
Thank you very much. I'd first of all like to thank my friend Kolluru Subramaniam for inviting me. It's a pleasure to get his hospitality. It's a wonderful thing to be here. So if I can start my slides. Hegde Saab told you of all the things that can go wrong and all the things we should be careful about. I, on the other hand, when I used to watch movies, I used to go to movies which always had a happy ending. Like N.T. Ramarao movies in Andhra. You know that N.T. Ramarao cannot die. At the end, you know that he has to marry the girl that he wanted. Similar MGR in Tamil Nadu, no? Or James Bond in the time of Roger Moore. You know that James Bond as Roger Moore could not die. Whatever happens, They'll put him at 300 degrees centigrade, they'll put a machine guns on top, he will have to win. So my research is generally like that. I want a happy ending. Let it take some time. And sometimes again, like our movies, see, old movies, there used to be a formula. 6 songs, love triangle, villain will try to attack the heroine, and finally everything will happen and the heroine get married. And it's the same formula. So my formula is what Professor Shah did, I think, 40 or 50 years back. I'm going to talk about mostly the same thing. But with new actors, hero, heroine will change. Villain will be the alkalis in the cement. And the heroine is the glass. The hero is the cementitious matrix. So this is the story I'm going to tell you. And for youngsters, this has always been my formula, at least recently. Try to think of where the story will end. Yeah? Can we go to application? At the end, it takes a long time. Our textile reinforced concrete work started 15 years back. And it takes time. Right now, my colleague Pranoy Suraneni was saying that they just brought out a standard for supplementary cementitious materials that took 15 years. So if you're in the concrete business, you're there for long term. It's a marathon. Your research will take 10 to 20 years to reach reality. So you have to be very patient. So our great inspiration is always Surusha, who's been doing this, and we learn from him. So a lot of the work is inspired from what Suru did long back. So textile reinforced concrete. Little bit of marketing for my group. We have a group called Technologies for Low Carbon and Lean Construction. So we do things related to construction materials, implementation, construction management, and building physics. Lot of young people, I'm the oldest there, and really budding researchers who are doing cutting edge work, and this is something that we are very proud of. So textile reinforced concrete is coming up a lot. There are many people here like Liberato Ferrara who's done excellent work. So we were inspired and thinking that is this a material that we can look at where corrosion is very important, where thin, slender elements have to be done. And there is work done in India also. You see the bottom photo, some of the things we have done. So we thought, can we bring in some rationality? Can we bring in some optimization? Can we bring in cost reduction to this material? So why this material? First of all, we all know about ferrocement. Ferrocement was a big thing. Some of you were not born at that time, 60s, 70s. A lot of work was done in ferrocement. But it went out of vogue because of corrosion. The steel had to corrode. Steel had to corrode in thin elements, you could not. So you had to go to thicker elements. Then again, that defeats the purpose. Now we are re-looking at ferrocement. Again, it's like the same movie story. New actors are coming in, but it's the same story we are telling, but with glass or carbon reinforcement. Glass for us because it's cheaper, and I look at e-glass, which is even cheaper. So we are thinking of thin elements. Where can we use thin elements, and how can we get the light weighting to the advantage? And that will bring in other advantages like lesser carbon footprint, so on. And what is very interesting is that we worry about corrosion of steel, therefore we have to have a thicker cover. Here, I'm not so much worried about the cover. Another thing which changes is that in reinforced concrete, you worry about carbonation. Why? Because the pH changes and therefore your steel starts to corrode. Here for glass is the other story. It is better for it to carbonate. Then it brings down the pH. Okay? In regular reinforced concrete, you want to keep the pH up to protect the steel. Here I want to bring the pH down, which is better for the glass. That means I can happily relate carbonate. And if you are one of these people who likes this carbon footprint business, I can also sequester. Like Hegdesa was asking for how much we can sequester. So here I can sequester so you can sell better also. So this is the background of the story, why we want to do it. Now, Professor Shah did this long back, looking at distributed cracking. Now we use digital image correlation. So this is the new technique, that the new toy in our lab, that people use this DIC to look at cracking. Because otherwise you cannot see cracks. And DIC tells us where the cracks are, what is the width of the crack. So we can actually optimize the system very well. So DIC basically has a camera which is looking at the speckle pattern and telling us how the strains and displacements are. I'll show you some images later. So this is on your right, you will see an image of a specimen being pulled. The load displacement curve is here. So what is also interesting is that we know very well, again going back to Suru's work where he showed that concrete strain softens. That is, it has to come down. But here we see we have a different composite which goes up, which can go up, which can harden. So this is the thing that we want. We want the material now to harden. Because it hardens, you have multiple cracking. There is no one single crack and failure. Therefore, you have a lot of ductility, if we can call it, or less brittleness. So this is the reason why we want a material like this. And we want a material that is always increasing the load carrying capacity, and finally it will fail, because finally everything is brittle. Glass is brittle and concrete is brittle, it will have to fail. And what the DIC tells me now is how many cracks, what is the width of the crack, and ensuring that there is this distributed cracking happening. Other aspect is durability. Just I told you that carbonation helps, but alkalis in the cement can attack the glass. So what is usually done is the glass is coated. You don't use glass textiles as such in concrete. They are coated with a polymer. Sometimes they're good, sometimes they're not. So I have now 3 glass textiles here. This is just the textile, not in concrete. I just take the textile and put in alkali solution. Different alkali solutions indicated at the top. Now on the left is alkali resistant glass. And you see that it does not degrade. Now the middle one is another so-called alkali resistant glass in the Indian market. People are selling it, people are buying it. It is so-called because it's not alkali resistant. You can see that it is coming down, it is degrading. So it is being marketed, but it's not. On the right is E-glass, that is cheaper glass. And I want to see if we can go with the E-glass, which I believe is good enough for many applications. So as you see, the strength drops with aging. So this is what we want to compensate. This is what we want to take care of so that your structure is still in place. We know it's degrading, but can we model it and make sure that in spite of that, you can use it. So that way we can avoid all the spurious things that happen in the middle. You're paying a lot of money, but getting some nonsense. So can we do something different? What happens? What happens to the glass? Why this is happening? I said it's coated, but sometimes we see that when you have alkalis, the coating sort of disappears. You have like this pitting, like what you see when rust forms on steel. You have these pits forming, and slowly it gets degraded. The coating goes away, and the alkalis freely attack the glass. So this is what we want to take care of. We want to decrease the effect of the alkalis. We want to protect the glass well. So we know the cause. Now we are trying to work on the composite. We do tests on the glass. So we are proposing this as a highest standard now on how to test the glass. There are different ways. I think we've come up with a nice way of testing, and which gives us the behavior. What we should understand, which is different from ferrocement, is that glass is brittle. Carbon fiber will also be brittle. Final failure will be brittle. Okay? No ductility there. Ductility comes because of this multiple cracking. Okay? Multiple ductility does not come from the reinforcement being ductile. The composite is able to crack and dissipate a lot of energy and have a lot of strain before it fails. So the philosophy is slightly changing. We are also looking at how to test the concrete. Rylem did a lot of work. We are following the Rylem work. Now we think we know how the composite should be tested. Again here, throwback to Northwestern, when lot of work was done on tensile testing, closed loop testing. We had a lot of fun there trying to break things which were softening. And this is a throwback to that time where tensile testing was brought in. So what do I want? I want to put in enough reinforcement so that the stress strain curves change from softening, coming down, to going up. So this is what I want. I know now how to test. I have to take this to design. Okay? I know that putting certain different layers is slowly going to increase, and I can now calculate how much of this hardening response I need, how much load carrying capacity. So it's not a random put in 3 layers. we can design for the number of layers required. Also, the coating matters. We are now working on coatings. We are trying to see how the coating matters, and depending on the amount and type of coating, there is better stress transfer or not. So the textile becomes more efficient if you have a better coating. So now we have to start learning about polymers, we have to start seeing how coatings are done, and we are working with fiber manufacturers, textile manufacturers to do this. So you see that now our star, our James Bond is PVC. We like PVC the best of all the things we've tested. It seems to be good. Very few manufacturers, but it looks like that will be the future. So we are, if somebody comes to me, what type of coating? I will say PVC from our tests that we have done. Now from this we have to go to design. Otherwise people like Hegde sir will say, these academics don't do anything, they just do break something. So we have to go to design. So from the experiments, I can come to models. So I can give Hegde sir a curve like this, like the dashed line, and say, now you can design. I can give you a constitutive relation of concrete under tension, and you can design it. And then we can bring in crack with calculations and so on. So from some tests, I can come up with a dashed line, and I give this to the designer, and they can use this in design. So we are at the point that we can start design. Now there are other things which we have to calculate. One thing is size effect. So again, Northwestern story, you know that if you change the size of an element, the strength can actually come down. Okay? So this sometimes is counterintuitive. Strength can come down when you increase the size of an element. So here I made our student Ramakrishna, who is in the audience, do tests of different thicknesses, and what we see is something interesting. The number of cracks and crack width changes even though the reinforcement ratio is exactly the same. Okay? A thicker specimen has fewer cracks and wider cracks. Same reinforcement ratio. Okay? So that means this is something you have to keep in mind. You cannot test a 10 millimeter specimen and design something for 40 and assume everything is the same. Okay? So there is something called size effect, which we can explain through fracture mechanics, through Weibull theories, and so on. So this is something that we had to learn, we had to find out. The other thing is durability. So similar curves Professor Shah had from long back on AR glass. Now we found that with E-glass, we have to start looking at it. So you see two curves, left and right. Left is a conventional matrix. Right is a matrix that we have modified. Now we are trying to see how to modify the matrix to protect the glass. Okay? And we can bring down the 40% to 25% drop. We think we can bring it down to only 10%. So we are working on changing the matrix, letting it carbonate, and we protect the glass. Okay? What happens? Again, we have to go back and see what happens inside. Now this is inside the composite. We are having these pits forming. So it is like steel. Pits form in the glass, and when you have a pit and you have tension, that pit is where you have failure. Section is decreased, and suddenly it can break in a brittle way. So we want to prevent this from happening, and we want to reach a situation like in your right side, like completely smooth without any pits. So that is our intention on working with the matrix. Now we also want to know how long something will last. Everybody comes in and asks us, how many years will this last? So we have to have some way to test it. So we do accelerated tests. We take the composite, put it at 50 degrees water, and we accelerate and see how it is aging, how the strength is dropping. Now we've also done by putting it out in the field. So we did tests for 4 or 5 years. After that, my PhD student wanted to graduate. I don't know why PhD students like to graduate. But after 4 years, he said they will not do any more tests. So we correlated this 4 years with the accelerated. We found out that 1 day in accelerated conditions is equal to about 100 days in Chennai climate. Very interestingly, Professor Shah found out in 80s, 90s, in I think Chicago conditions, it was like 80 days. So Chennai is a little bit worse than Chicago's rule. So we know then every 1 day that it endures this accelerated is worth 80 days in reality. So if I have about 10-15% drop, that means 20 years my structure is safe. Okay, that's good enough. For most applications that I am thinking of, 10, 20 years is good enough. So that is where we are. What do? We derive these curves. We derive these durability curves, we derive these curves for different matrices, and from this, if I know how long my structure has to last, I go to the x-axis, I say 30 years, then I come back and I use that factor in my design. Okay? So now I can actually design for durability. The client can tell me, I want my TRC panel to last 25 years. I go here and I tell, your durability factor is 0.7. So don't design for more than 70% of your efficiency. Okay? So now we have come to the point that we can do efficient design. Now the other thing was, what happens under creep? Because structures, again Hegde have touched on it, creep and shrinkage. So structures have cracks and also load. What happens to these cracks? Will they continue to open or not? Can we model it? Can we predict? So this was the thesis of Ramakrishna. So he cracked specimens up to 0.2% strain and 0.4% strain. 0.2% strain is the maximum you will see in service. 0.4 is little bit beyond. Okay, so we see these two extreme conditions. We take it and put constant load. Constant load for as long as the PhD student wants to stay. So load will be continuing until they want to graduate. So we crack it, and then this is 0.4% strain. 0.4% strain, most of the specimens collapsed, failed. So we know that if you have so much stress, cracked TRC under load, it will not withstand. So we had failure in few days. Okay? But we were able to model. So we are able to model and predict when these strains will be very high. Good news is, when we go to 0.2%, there is no failure. So that means that if we can restrict the strains under sustained load, strong behavior, even after cracking, I will have very good behavior. And again, we are able to model. So the model can be calibrated, given to the designer, so they can actually see how the cracks are opening with time. So that is where we are. We are very confident that this material can be used in structural aspects. Maybe we should start with non-structural and move up. So as I told you, there has to be a happy ending. So we started doing actual implementation. And we found that a good way to market this or implement this is thin elements. So we started doing tanks. Okay? So this is the pictures of how a circular tank develops. These are the textiles. We space them. In this case, I think there were 3 or 4 layers. And we make sure that the layer spacing is correct. Then we pour the concrete in. We check it out. And then you have a tank like this. Okay, what do you do with this? You also you need some horizontal elements. So we also make a base. So now I have a ring, I have a top and a bottom. One of the things we have implemented, if you come to IIT Madras, you can see the sewage treatment plant. So we made rings that can be put together for rural areas, peri-urban areas. Small sewage treatment plants can be made. This is for about 100 people. It is attached to one of our hostels and it seems to be working fine. So, and also one advantage, if you see on the top left, all these rings are made that when you transport, they can all be transported one inside the other. Otherwise, you need a lot of volume for transportation, cost goes up. So they are all nested. They all go inside one in either, and you make the system like in the middle, put the base plate, put a top plate, and you have these tanks. And this has been functioning for a couple of years now. So this is one application that we have actually showed that water tank, and we did a water tightness test, works very well. Then housing. So there is a company in Rajapalayam who took our technology and started making small houses. Now they are becoming bigger and bigger. You see at the bottom, looks very ugly, right? Who would live something like that? You look at the top one. After finishing, it looks very nice. And now this is a big business for them. They are starting to do this a lot. Then at IIT Madras, what we started doing is we are trying to do all our wall partitions with TRC. And you can see the assembly. 3 people can put it together, screwed on to a metal thing, and when it comes on, it's fine. You won't know what type of wall it was. This is textile reinforced concrete. Actually there you come to IIT Madras and you can see these projects on. So that is where we are. We have done quite a bit. As I told you, 15 years. So you need patience, but you can get there. It can be a happy ending. There is a possibility that glass reinforcement and concrete get along well. We can do a lot of others have worked on it. We have the means to characterize, we have the means to design, and that is what we are working on. And I said, lot of people have done it. I usually give the presentations, I don't do any work. So these are the people who actually do the work. Lot of students have worked, lot of postdocs, lot of collaboration, lot of funding has happened, which keeps things going. Yeah? So with that I'll close, but before that I want to do some marketing for our next event. And as you see, as you know, our concrete hero, Professor Shah, is in his 90th year. And we are celebrating the whole year. We started off with a celebration in Chicago. We are going to continue the celebration in Chennai. So if you could not come to Chicago and you have your reasons, Chennai is closer. So please come to Chennai in January. We are continuing the celebration of Professor Shah's 90th birthday, and we are making reservations for his 100th birthday. Yeah? So please do come. As I told you, lot of things that Professor Shah has done, many of us have been fortunate to be his students. We are extremely grateful, and we take pride in even copying what he has done. I don't have any embarrassment saying that we copy what Suru has done and we recycle them. So, as good as N.T. Rama Rao and MGR, Suru has been for concrete. Thank you very much. You have time for questions, sir?
I think Professor Gaddu finished early, so we have time for more questions. Yeah. Yes. Yeah, please, gentlemen.
I'm Dr. Srinivas. In the practical field, I had used textile, that is jute rolls, many years back for the covering the leakage from the roofs, and also used it for the cattle shed, other things to make it with layers. Now, I've used mesh also, chicken mesh, and also used this textile thing which long back, some 30 years back. But with this, especially for this, what you call as Madras roofing, you have got the problem where the creep takes place and then cracks appear. But somehow this did not work so well with the textile thing which I had used for the gunny bags. I used it thin layer of concrete, I used to put it, say 2 inches like that. Could you explain what could be the cause of this?
Sir, when you want to do waterproofing, generally you want a flexible layer. This is not going to be flexible. It will crack. So when I talk about flexibility here and ductility, it is after cracking. But when you're using for waterproofing, I don't think this is a good idea because it will crack. If you ask me what is good in waterproofing, I will say just put a PVC sheet. A PVC sheet is like a raincoat. You put it on and it will work. Even though you have a Madras terrace where you could have some damage, just go for PVC. I would not recommend this as waterproofing. When you want a very uncrackable layer, do not do it. Do not do it.
Sir, excellent presentation, sir.
Thank you.
Sir, I have one question. Can we expect any stress concentration in the problem?
Can we expect any?
Stress concentration.
See, if
Being
there is a crack, there was a stress concentration.
Being a cracked section, it's a problem
Before the crack, there will be stress concentration. Otherwise, why will it crack? But thing is here, because of the textile is now bridging the crack. The crack is not free to open. The textile is bridging the crack. So even though the crack forms, it has to form. No, it is a brittle matrix. It has to form. Now your textile, like fiber reinforced concrete, it is preventing the crack from opening. And while it is preventing, it is requiring you to put more load. That is why you are having this hardening. Yeah? You're right. There will be stress concentration.
Thank you.
They will. Yes, sir.
Actually, this is not a question, that is a suggestion, in fact, which is not required here, but in spite of that I am giving. So we are in the process of making a standards for TRC in BIS, in CD 54. And perhaps Smita Gopinath is taking care of it. So if you can help her to standardize this, the one is the specification of textile itself.
Yeah.
It should have some properties, so there should be a specification and there should be a test method. Then second level of a standard is the panel, precast panel, which is being used in the facades and all that.
Yeah.
And the third is design parameters when we are designing the different type of structural elements, in situ structural elements particularly, which you have shown. So there should be a design parameter, how to check, how to calculate, and calculations. So if these three levels of this standardization will happen, then perhaps we can popularize this technology very well in India.
Sir, with your blessings, we can do it. But I am very frustrated about BIS, sir.
Sir,
It
in
takes
spite
years.
of that, in spite of that,
Sir, my fiber info standard took 15 years. Now, I don't have so many years in my life left
that is there,
to
but
fight
we
with
are,
BIS.
that is there, but we
If
are
you,
in the
if you
government
guarantee,
system.
I will give it. If you
Definitely,
guarantee
sir.
that it will become an IS standard,
Definitely.
I will do it.
Sir, without that, there is no way we can do it. We are living in India and we will have to live with that.
Sir, I agree completely. But if everybody cooperates, we can get it. You know
Definitely
that our fiber reinforced concrete standard took, Ramachandra sir knows, it took us 15 years. 15 years struggle to get the standard. That is the problem. See, if BIS can be more agile, certainly we can do it. We have enough information, there is enough international information. So if you can, if
Sir,
you can help us, certainly we'll do it.
Sir, I don't know. I am working with BIS and BIS is now agile in these days.
Good.
Only the technocrats like you and all of us, we should be contributing
Certainly.
to the
I agree.
cause of the nation, then it will get popularized, otherwise it will not.
Certainly, sir.
Yes.
Okay, thank you. Yeah, gentlemen, please.
Excellent presentation, Professor Gatu. With your 15 years experience in this research, my basic question, just question that you said this TRC composite, you have still challenges which you have converted to opportunities. My thinking is durability and the reduction of carbon footprint. How this system can help in making structure durable with the less carbon footprint. Thank you.
Sir, a regular reinforced concrete structure, I am not going to use this to make it more durable. This is an alternate. It's a composite, but not with reinforced concrete, not with steel reinforced concrete. This has to be for thin elements. I will not suggest it to make a beam like this. No. This is for thin elements like cladding, you have thin walls, like I showed you some elements. See, right now, all our partitions are thin partitions. We have stopped doing brick walls. So we should do something like this. We should go for drywall construction. And where does sustainability comes in? See, all of us know when you have to change something in your office or in your house, you have to break walls. Here the idea is you have a light frame, you have screwed connections like I showed you in the thing, you go and remove it and you can reuse those things. So that is sustainability, that is carbon footprint. You are not demolishing, throwing it away. You can recycle, you can move things. Your house can become larger, one room can become larger or smaller as you want. And carbon footprint because again you are going thinner. And the other thing is I can sequester CO2. I am not going to, like in regular reinforced concrete, I want prevent carbonation. Here I want more carbonation, right? So these are the things which will help.
Thank you, Professor, for a very excellent presentation. Wonderful. You spoke about textile reinforced concrete, especially the advantages in terms of corrosion resistance, material optimization, and achieving high design freedom, and more important, target laying power. So now, I think the presentations are over. As per the organizers' program, I think there are presentations by sponsors. So we have two sponsors who will be presenting. One, Messrs. Fosrock Chemicals Private Limited. Messrs. Okay, so I think the organizer will take care of. So I thank both the speakers of this plenary session, Engineer V.N. Hegade and Professor Ravindra Gettu, firstly for keeping the time and also giving a wonderful presentation, a lot of thought for discussion. I am sure all of us have got enriched with your presentation. Thank you very much.
Thank you, Professor N.V. Ramana Rao, sir, for chairing this session. Now, may I request our distinguished guests and speakers, Professor Shah, sir. We have to say Professor Guru Shahji because he's a guru to a lot of us. Dr. Kalgal, sir, kindly request you on to the dais. Professor KVL Subramanian, sir, request you to escort Dr. Shah, sir. Thank you. And Mr. Rangarao, sir, the EC member from ICI Hyderabad. May I request that Professor N.V. Ramana Rao now be honored. We convey our deep gratitude and thanks on behalf of the Indian Concrete Institute, ACECON, and also the Indian Concrete Institute, Hyderabad Center. I request the dignitaries, sir, kindly remain on dais. Ramana sir, please be on the dais. Please join us in honoring our other distinguished speakers. May I now request Engineer V.N. Hegde, sir, the bridgeman of India, we should call him, sir. So he bridges, just not bridges, but also many professional organizations. Thanks for being here, sir, and for that excellent sharing of views on this aspect of risk to resilience. Please remain on stage, sir. Now may I request our Professor Ravindra Gettu. Every talk of Professor Ravindra Gettu is derived from ground and it's so very practical, sir. We are greatly indebted for your textile reinforced concrete. Thank you so very much. So please move on to the... Thank you. Ladies and gentlemen, once more, a big applause because we have got all the scholars on this. Thank you so very much, sir. Thank you. Thanks for honoring. And thanks to the speakers and the session chair. Thank you so very much. So, ladies and gentlemen, now we have a corporate presentations by one of the top-notch corporates. Do you have anyone from Fosroc Chemicals in the audience? Anybody from Mapai? Yes. This is a commercial presentation of Mapai. So, can you please bring up the deck of Mapai, please? AV desk. AV desk.
From the ancient wonders of the world to the modern marvels of engineering, construction has always been the foundation of human progress.
Just PPT.
PPT. You want to present the PPT?
Stick to your time. 5 minutes. Just 5 minutes. Sure. Okay. Good afternoon. My name is Amit Kotial. I am the product manager for repairs and rehabilitation for Mapai India. Okay. So, sir, after so much of important sessions on the sustainability and the durability of concrete, so Mapai is the company which who are producing the products related to the for the industries to have a sustainable materials. So Mapai is an 80-year-old company based out of Milan and having a very good experience in the terms of construction chemicals which we provide and which gives you a sustainable growth and other. So about Mapai, Mapai is 4.4 billion euros company, almost more than 12,000 employees. We are doing carbon offsets, and we are producing the products which are which you are getting with the zero carbon footprints. Okay. So coming out on the Mapai India part of it. So Mapai India has started in 2011 and now it's 2025. We have 3 factories in India and 4th factory is coming in Kharagpur. Okay, so what's our expertise in the field of construction? We can help you from waterproofing to repairs and rehabilitation works, from sports flooring, industrial floorings. So this all kind of materials we supply to our industry. Okay, so coming to the theme of sustainability, what Mapai believes in terms of sustainability is the durability of a structure, durability, quality, means it's you have an high quality products for the structures, so you can achieve the durability of the structures. Then the innovation. So Mapai is one of the most innovative companies in the field of construction chemicals. So we have innovated more products products which are sustainable in terms of carbon footprint. So we are giving our customer the products which are with zero carbon footprint. Means we are offsetting first we are doing the technology, we are making the product more sustainable with less carbon, and then whatever the carbon is still left, we are offsetting it and giving it to our customers. Okay. So what the facilities we provide to our customers in terms of product and environmental laws. So we gives you an EPD, environmental product declaration. So whatever the product in the whole product life cycle, whatever be the impact on the impact of the product on the environment, we can give all these things. We have in 2024 and 2023 we have offsetted carbon CO2 about 200 flights around the world. Okay, so this much carbon footprint we have offsetted with our products. Okay, with our innovations, and we are giving you a carbon zero products in India. Okay, so what are our technologies? So our technologies is Mapai Cube system. It's an admixture. It's an admixture in which with the lower cement content you can achieve the same strength. Okay, so this is the new technology worldwide is using, and we have introduced in India also. Second one is Recon line. So Recon line in admixtures is basically it's reusing the concrete. Okay, so you will see you demonstrated concrete, you have an aggregate, you have cement into it. So they are reusing the concrete which is demolished and then making it to aggregate, and you can use that aggregate into the in place of new aggregate, you can use this aggregates for the producing of the concrete. So this is our Recon line. So we have products for making concrete sustainable as well as other things also. So we have different coatings. Somebody speakers are telling about the coatings which is required for the carbonation and chloride resistance. So we have different kind of coatings. We have cathodic protection systems, and we have different kind of mortars, repair mortars, which gives you a sustainable systems. Carbon fiber system, textile. We have already last presentation. We have all kind of this. Then we have
building future also and preserving the past. So we have all the range for the preserving the past, which is the heritage structures. So we have breathable lime concrete, lime-based material, lime-based waterproofing for these structures. Okay, so some example of heritage worldwide we have done. These are the canals, these are the bridges, heritage bridges, Old City, Leaning Tower of Pisa, Venice canals. These are all UNESCO heritage buildings which we have done for repairs and rehabilitation works. Okay, Hagia Sophia Mosque, Turkey, Ibiza Wall, then Singapore, then in India, the Mangi Bridge in Delhi, which is in Lal Killa. Okay, Viceregal Lodge, Lal Killa, and other Salim Chishti Dargah, Safdarjung. So we have done various kind of heritage repairs also. So we have from the modern building to heritage building, we produce all kind of material with a sustainable technology. Okay, so we have an VR tour of our all products, so we can always go to Mapai website and take it. Okay, thank you from the Mapai side.
We would like to convey our thanks to Mapai for supporting us in this particular event. May I request Mr. Manoj Kavalkar and sir, kindly come, Mr. Maulur, so that we can convey our thanks on this occasion to Mapai. Please move on to the center stage. Let's applaud their support to ACECON 2025. Thank you so much. Now can I request Mr. Vishwanath, AGM of NVL and Construction, to please come out to the stage. May I request that the presentation of NVNL kindly be staged, please. The presentation of NVLN, please. Okay, you want to go later. Do we have, sir, just wait for some time. Do we have Mr. Dr. Hanuman, the R&D head of Simply Forge? Dr. Hanuman? Okay, please come. This is Simply Forge. Do you have the deck ready? Simply Forge, please. Please come. Not this one. We have a presentation.
Okay, good morning all. So I'll be presenting on 3D concrete printing. So I'd like to start the presentation with the introduction of the core team members of the Simply Forge Creations Private Limited. So under management and logistics team, we have Mr. Harikrishna sir, who is our founder and he is our MD as well. He is having more than 15 years of the experience in the industry. And also we have young and dynamic Dhruv Gandhi, who is CEO of the company. He is serving as the management team. And then comes the material specialist. I am serving as the material specialist in the company. And then as a robotic expert, we have Mr. Wasim, who is sitting in the audience with us. And he is the founder and the CTO of our company. And also as a structural designer, we have Dr. Rangarao sir, who is having more than 20 years of the experience in structural design part. So he is serving as the head of the structural design part. And then we have, for field operations, we have Mr. Faizan Chaudhary, who takes care of all the field operations. And then I support him by QC. And as an institute partner, we have Professor KVL Subramaniam from IIT Hyderabad, who gives us all the technical support. Now with this, I'd like to skip all these portions. We all been discussing about 3D concrete printing. I would like to skip these portions. And even this one, we know what is 3D concrete printing. We have been keep on listening from yesterday. And we know that when we talk about 3D concrete printing, the material is very important for us. So as a part of the development of material, we have developed our own indigenous material, which we named it as the Simplicrete. It is developed purely by indigenous materials. We did not use any imported raw materials in this. And also this is customizable. Suppose wherever I go to the site, we use the locally available sand and cement or any other admixtures to make the 3D printable motor at sites. So across India we do that. And the mix, whatever we make sure that the compressive strength follows as per the structural requirement. Generally, the requirements what we follow is around 40 to 60 MPa, and the maximum mixing time what we follow is 5 minutes. And then with this, I'd like to talk few projects which we have already executed. Initially, we have executed the world's first place of worship, which we executed in Siddipet, which is almost around 100 kilometers from the Hyderabad city. So this entire structure is done using in situ mixer, including the 3 garbhagudis, which is lotus shape you can see on the right bottom corner, and the modak shape on the top of it, and then all the gopras are 3D printed. Yeah. So the equivalent height of this building comes to around G+2. Construction. If I convert in a commercial house, it comes as a G+2. And then we have printed India's first 3D printed bridge for IIT Hyderabad. This we did in collaboration with Professor KVL Subramaniam. And this bridge has been installed at IIT Hyderabad, and the dimensions are 5 meters length and 1 meter width. And this is the place where we have installed the bridge. And then we have done one more signature project, which is under Project Prabal for Indian Army. We did the on-site printing at Ladakh. So this has done at 11,000 feet altitude at halo conditions, high altitude, low oxygen conditions. And this entire project, we took the robot to the site. We used all the indigenous material and we developed the mix there itself with the help of Professor KVL Subramaniam sir. And then we were able to print at the location. And I'm proud to say that till now, no one else could do that. Across the world, we are the only one who can do the printing at that high altitude conditions. And after that, these are a few security, few organic shaped security posts which we have done for the Indian Army. And then we have done the first hospital building for Indian Army, which is equivalent to 1750 square feet. Again, here we use the local materials. We don't carry any material with us except robo. And this is the accommodation which we have done again for Jhansi. And this is one of the signature projects. This is made of concrete actually. It's not of some polymer or some fiber. So this also we have done for Indian Army, for White Tiger Regiment. The height of the tiger facade, you can see beautifully. It is around 5.4 meters. The one who is standing in the tiger facade entrance, he is our CEO. His height is roughly around 6 feet. So now you can imagine how height it is. And this is acting as a sport complex entrance for White Tiger Regiment in Jhansi. And then we have came up with concrete containers concepts, just like the steel containers. We have the portable containers, which we can take it and erect it wherever we want it. And then we have all the other facade elements. We have done all the barbecue pits, all these things, and then all the wall customized boundary facades like teardrop condition, shape, all these things, and spiral pillars, spiral ways. All these things we could do under diamond cut facades where we can tremendously disperse the load easily. And these are the different facades which I would like to show. And I'd like to thank you all for the please. I kindly request Mr. Wasimji to join me.
May I request Mr. Jagannath Rao to please come onto the stage to do the honors on behalf of the Indian Concrete Institute Hyderabad Center. And may I request Mr. Rangarao also to join to convey our thanks to the esteemed sponsors, Measures Simply Forge. Thank you, Dr. Hanuman and your team for supporting us. Let's give them a big round of applause. Because without the sponsors, it is just not possible to hold such a grand event. Thank you so very much, and we look forward to your continued patronage across various centers of ICI in India. Thank you. Now may I request the AGM of NVLN Constructions Private Limited, Mr. Vishwanath, to please come over and make his business presentation. Thank you. This is forward, this is backward.
Yeah, good morning, everyone. Thank you for giving the opportunity to demonstrate in the. Yeah, good morning, everyone. Thank you for giving opportunity to be a part in ACECON 2025. We, as the NVLN Constructions Private Limited, we are the service-based construction company in repair and rehabilitation. Today, we are presenting one of our successful project in NHI, first India's PQC repair. So, please demonstrate. This is the one of the NHI project. 135 kilometers of stretch, completely PQC stretch. One of the commercial project we brought into the maintenance. Thank you. Thank you all.
May I request Mr. Jagannath Rao to please come over. Mr. Gangaram also, sir, please join to convey our thanks and gratitude to NVLN Construction for your support for ACECON 2025. Thank you so much, NVLN Construction. Ladies and gentlemen, please give them a big hand. Thank you. Do we have anybody from Fosrock, please? Anybody from Nuvoco Vistas? Any representative from Natural Semco? Okay, thank you. What we'll do now is we will take a quick 15-minute tea break, and after this tea break, there will be a split session which will happen, one in this hall, Kohinoor, the other one is on the ground floor called Evoke, and the third one is in the E floor, which you have to take the lift, and that is called Synergy. So these split sessions will be for a duration between 1.5 to 2 hours. After those sessions, we will have lunch, and we will come back here for the plenary session. Okay, so after the lunch, there will be one major session, which will be the plenary session here, and after tea break in the second half, we will again have the split sessions. So just to summarize, we will break for tea now, and after tea, we will again assemble in the split sessions. Thank you so very much. Okay, just a second, please. We would like to convey our thanks to Chettinad Cements also, who has supported us. May I request the representative of Chettinad Cement to please come over to the stage. Rao Garu, please come. On behalf of ICI, please convey our thanks to the team from Chettinad Cements.
presentation on వాళ్ళని PPT section చెప్తారా?
Thank you, ladies and gentlemen. Let's give a big hand to Chettinad Cement for all their support. And as we break for tea, may I request the speakers of the next session, Engineer Uberto Rico, we have your PPT presentation. We have Mr. Dhawan who will be speaking. We have Mr. Venkatasamy, Mr. Vedu Purana, Mr. Gangaram, Mr. Hemangashwarvai, and Mr. Subramaniam KVL, his colleagues, Mr. Sivaran Naik, Prakash, and Shesha Ratnam. I request all of you to please present your deck, your PPTs, your presentation to the AV desk, and please clearly call out your name so that seamlessly we can stage it as and when your slot comes up. Thank you. We will see you in 15 minutes time from now.
to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training program, webinars, and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest materials, technologies and practices. ICI's program Deminar is a unique event combining demonstration and seminar. Here products are demonstrated outside and they are live streamed into the seminar hall. Thus the participants can observe the demonstration while it is being explained by the speaker. ICI events, among other things, are focused on sustainability through the use of innovative materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users and society at large. On 7 September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. Working in close coordination with central and state government bodies like CPWD, PWDs, CBRI, CRRI, SERC, IITs, municipal corporations and more. ICI helps these bodies to adopt latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS focused towards advocating standardization in construction practices. ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of more than 10 Asian countries. ICI has signed MOUs with many other peer concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through its students' chapters. There are more than 300 students' chapters all over the country and the numbers are constantly increasing. Each chapter is focused on enabling industry-academia interaction aimed at bridging the gap between basic theoretical knowledge and professional practice. This imparting of requisite knowledge to budding engineers enhances their outlook and employability. ICI identifies, recognizes and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To demystify concrete, the Technical Board of ICI brings out valuable technical documents on topics of importance for the benefit of practicing technocrats through its technical committees consisting of subject experts from different disciplines. ICI conducts need-based training programs at its technology centers as well as customer sites for the benefit of practicing engineers and students. ICI Journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. it stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable, and best in the world. Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals
I think we can
and
stop the
organizations
corporate
involved with
video of
concrete.
ICI, please.
As a non-profit organization,
Kindly stop the
ICI
corporate video of ICI. Thank you so very much. So that was about Indian Concrete Institute. Those of the delegates who have not yet become members, I appeal to you on behalf of ICI to please become members of the Indian Concrete Institute. It is just a one-time membership fee. The membership can be done right away, just within 3 minutes on our website, which is indianconcreteinstitute.org. That is without a space, indianconcreteinstitute.org. I request all of you who are not members of ICI to please become members. You become life members, you will receive your ID cards within 15 days from the day you register. And you are a member for life. You get to attend various programs of ICI at a very subsidized prices, and you also get an invite for free lecture and industry visits organized by the various centers of ICI. ICI has got over 50 centers in India, and therefore you can gain immense advantage by becoming the members of the Indian Concrete Institute. Thank you. Those of you who are staying at this hotel and are being hosted by ICI Hyderabad Center, I request you to please check out of the hotel by 12 noon today. Please check out of the hotel by 12 noon. You can get your luggage and keep it here at the back of the stage and collect it tonight or today evening when you plan to return back on your travel. Thank you so very much. Welcome back. After the tea break, we will start the first split session of the day. And for that, we have the session chair, Dr. C.V. Shivaram Prasad. I request Dr. C.V. Shivaram Prasad to take over and conduct the session. Welcome to you, Dr. C.V. Shivaram Prasad.
Good morning to one and all. Myself, Dr. C.V. Shivaram Prasad. Thank you so much for giving this opportunity. And I have to say thanks to all the ICA team, which is a very wonderful event connecting in Hyderabad as ACECON. And thanks to all the sponsors for connecting and supporting this event. Now we have a technical session by Umberto Rico, APAC Regional Product Manager, that is Mapai Italia, and his advancements in concrete remedial and protection. He is extending service life through sustainable practices. And Umberto Rico holds a Bachelor of Architecture with a thesis title Lagos Bidonville on Smart City and a master degree in engineering from Politecnico di Milano, where the thesis focused on real-scale seismic assessment test of steel concentrically braced frames under the supervision of Professor Carlo Andrea. And he has 7 years of experience in structural strengthening design using the innovative technologies such as FRP, FRCM, CRM, as well as HPC, with a strong expertise in seismic retrofitting and hands-on job site experience delivering the cost-effective, tailored solution. And he has also spent 4 years in industry design and development for leading Italian furniture companies, as participating in a major fairs including Maison and Object in Paris as well as Singapore, and collaborating with an international network for the designers. And additionally, he has 2 years of experience in the global architectural and construction industry, and he is managing a lot of projects from concept to implementation in multidisciplinary streams. He is having the skills like multidisciplinary approach in architectural, structural engineering and strategies, strong analytical and creative problem solving, and project and construction management, technical commercialization of the capabilities, client-focused solution development, highly motivated, proactive, organized, and adaptive with a strong communication and leadership qualities. Thank you so much, sir. Please come on to your dais.
All right. Thank you, everybody. It's a pleasure for me to be here today. So, straight from Vietnam for half an hour together. MAPA is an international brand. So, up to now, we are the second one in the top material suppliers in the world. And the topic of the day will be like sharing a bit of knowledge and a bit of our research and development in what we call sustainability. I've seen that sustainability is one of the main topics that you were discussing during your presentation, and I would like to present you what we are doing in terms of sustainability, because sustainability is not only reducing the impact on the environment. Most of the time, sustainability is durability, so it's increasing the lifespan of the structures. So this will allow us to reduce the wastage and, of course, less impact in the world at the end. My role is regional product manager of Asia Pacific. And today we are dealing with sustainability. In our point of view, sustainability means three main topics. The first one is the quality. So quality is for providing durability of the material, durability of the solution, durability of the intervention. So we should take care when we design, we should take care in the choice of the right material when we realize also the remedial. The main topic of today is remedial, it's not new construction, but of course we do have also a solution for new concrete structures, if you want to deepen about. Second one is reducing the environmental impact. So we have to consider that the construction industry is responsible for over 25% of the global impact in terms of pollution and CO2 emission. We are over 25%. 1/3 of the CO2 produced in the world is due to construction. Okay, it's a big value. So that's why it's very important to reduce the environmental impact. The third one is the CO2 offset, because up to now it's impossible to develop a product that is completely sustainable. So we can reduce the impact up to a certain level, but in order to maintain performances and maintain durability and maintain mechanical properties, it's impossible to, of course, reduce the CO2 at all. So a bit of the CO2 has to be offset somehow. The fourth one is the environmental quality. So the product that we use, nowadays concrete is a chemical product, okay, because all of the time there is admixtures, all of the time it's not only cement inside. So this means that these pollutants, these chemicals should be able to not release any compound that can affect your health. So it means that we are responsible of building an environment even inside our houses, and not only infrastructures, mainly for houses, in which the emission of what is called VOC, volatile organic compound, can be as less as possible. So this is another aspect of sustainability. VOC is a pollutant. So before going straight to the topic of sustainability, I want just to present you what is our standard approach when we deal with concrete remedial. When we deal with concrete remedial, we used to refer to a guideline that is the EN 1504, is an European guideline that has been published more than 20 years ago. It's not a law, but it's an handbook. So you could refer to this kind of standard to take ideas, to take principle, to understand and improve yourself in how to approach to the design and to concrete remedial and strengthening. It's divided into many sections, and I think that it's a very useful mean for all of us that we are also consultant rather than material supplier in our case. When we deal about sustainability and durability, this is an average value that we get from the market. So you can see that most of the time, 50% of the times, the damage that we have on site is linked to the wrong choice of the material. So if we're dealing with an environment that is full of chemicals like sulfate, we have to understand which kind of cementitious product to utilize. So that should be based and produced with a sulfate-resistant cement. Because otherwise, after very few years, 2 or 3 years, the cement will react with sulfate, will cause ettringite will expand, and you will have damage to the concrete. Inadequate cover design is one of the other parameters affected, because most of the time we don't take care about the durability. So the presence of, we have to protect the steel rebars against chlorides, against pollutant, against acidic, if we are in a chemical environment. Another one of the topic is the wrong analysis of degradation. So when we look at structures, we have to understand why we have damages, what caused damages. So this is very crucial when we deal with the design. Whether it is a new construction or concrete remedial, I mean, this is very effective. So that's why when we deal with concrete remedial and we want to deal with durability, we used to provide a solution that is composed by a system. It's not a product. It's not the mortar that I have to use for realizing the concrete remedial. It's a system composed of material in which we can find at the first time a solution that is able to protect the steel against corrosion. So basically you can use paint directly applied on the steel, or you can use a cathodic protection system. That is another very, very interesting and useful technology that you can utilize for blocking the corrosion, and you can even monitor it over time. The second one, of course, it's a mortar, the concrete repair, the repair mortar or the grout that we are choosing during the design should be compatible with the environment. It should be compatible with the structures that I have to repair. So it's very important to understand what the TDS or what the material is what it can represent. And then we have coatings. So in coatings, I mean, here you have two examples, an elastomeric material and an elastomeric paint. So basically it's an elastomeric material for blocking the carbon dioxide and chlorides. And the last one is the elastocolor. It's an anti-carbonation paint. I would say that protecting the concrete is important, yes, of course, because you are creating a physical barrier against the access of pollutants or any other compound from the environment. So in this case, we are dealing with durability. Durability is one of the topics within sustainability. Okay. So, summarizing, you can utilize paint for protecting directly the steel. So why paint directly on the steel? Because the concrete can crack over time. Even if you're able to keep the pH over 11.5, and so avoiding corrosion due to carbonation, in reality you can have cracks. Cracks in terms even of micro cracks. Micro cracks for pollutants are highways, okay, for entering. So this is one of the technologies that you can utilize. Another one is the utilization of the cathodic protection. So in our range we have internal anodes, so it's made of zinc, basically, that are connected directly to the steel rebars, and they absorb corrosion from the steel rebar. So we are not avoiding corrosion, but we are moving the corrosion from the steel to the zinc. So in this case, the zinc will be consumed and corroded instead of the steel. Is it useful? Is it working? Of course. We can design up to 30 or 50 years, okay, of protection, and we can guarantee that for more than 30 years you will have no corrosion into the steel, even if you're dealing with a marine environment. We do have systems that can be installed inside the concrete for new or repair, and we have systems that are kind of, they're called ZLA, zinc laminated anode, that are glued on the outer surface of the concrete. So in one case is we utilize the internal one when we need also to do the concrete remedial. In the other case, we can utilize the external applied anodes only when your customer wants to increase durability. So the concrete is healthy, there is no damage, but we want to increase durability. We do have also a system, mortar to comply with this kind of system with low electrical resistivity value, because this is an electrical circuit. We have to allow the transfer of ions between steel and anode to allow it works. Mortars, chapter number 2. So chapter number 1 is steel, second one is mortar. In terms of mortar, we have we can utilize the EN 1504 because the EN 1504 classifies the type of mortar that we should use and choose when we do the concrete remedial according to what? To mechanical parameters and durability parameters. This is again very important information. We are not only choosing the compressive strength at 28 days. We have to understand if the material is able to and capable to maintain its bonding, even if it's exposed to several types of conditions, like freeze-thaw cycle, like marine environment, like high heat. Okay, you were discussing about climate change this morning. This is very important that we can provide for durability. And durability is one way for increasing sustainability. We have other systems that are high-performance concrete. So basically, it's a cementitious material that works like steel. They're able to work in tension. Why this could be considered sustainable? Because we are not using steel in this case. The material can be utilized for a lacing element without steel rebars. With no stirrups, no main rebars. So you can't have corrosion if you use, of course, fibers that are galvanized or stainless steel. Chapter number 3, how we can implement sustainability and durability by providing a protection system. So basically we do have coating. So what we do is painting or elastomeric membrane that we applied on the external surface that have, first of all, an aesthetic purpose. So the concrete, most of the time, even if we deal with infrastructure, is not so beautiful. So it appears, after the removal of the formworks, it can appear with very, very ugly, I would say. So one of the purposes is make it beautiful, first of all. Then, about the technical point of view, this kind of elastomeric system, it's a very cost-effective solution. It's a cementitious base and elastic, are applied on concrete surfaces, on existing or new concrete, for, first of all, providing for crack bridging ability. So even if your structure is subjected to deformation and microcracks can form, this material is elastic and able to seal the crack, so blocking the access to pollutant. Second of all, you can see there is equation. I don't want to go too much in deep because it's, the time is not on our side. Basically, we can provide you a guarantee that 2 millimeter of our coating system is equivalent to 54 millimeter of concrete cover in terms of protection against corrosion. And we can do the same for chlorides. 2 millimeter of this elastomeric membrane is able to block chlorides as 30 millimeter of equivalent concrete cover, with only 2 millimeter applied on the external surface, and still cementitious based. It's not chemical, it's cementitious. This is a sample we took after 17 years. So after we repair the concrete and we applied this membrane on the outer surface, you can see that neither 1 millimeter of the concrete was carbonated. So if the concrete reacts with phenolphthalein and becomes purple, means it's healthy. So it means that the pH is over 12. And so this means that the concrete was not carbonated after 17 years. We have other systems for protection. So instead of using coating that change the appearance of concrete, you can even utilize some other systems that are impregnating. I mean, we are dealing with compounds that make the concrete hydrophobic or make the concrete able to prevent corrosion, because this material can contain active compound that bond, reach the steel, migrate into the concrete, reach the steel, bond onto the steel surfaces and block the possibility of corrosion into the steel. This is, I would say, a more cheap solution with respect to the coating. It's less possible to be controlled because it depends on the concrete porosity, and we don't know if the porosity of the concrete is the same everywhere. But this is the effect on the concrete, so it makes it dry. It is able to keep it dry without affecting the appearance. So the main mechanism is making the surface hydrophobic and changing the frictional angle between the droplet of water and the concrete. So you can see that the water is, you have ponding water, but it's not being absorbed by the concrete. Keeping the concrete dry, it's very important when we deal with durability. This is another example in, I'm sorry, should work, okay. These are other systems. In this case, we are dealing with systems that are sprayed, they migrate into the concrete, and they are also active. They're not only hydrophobic, make the surface hydrophobic, so keep it dry, but they're able to be active. They reach the steel up to 10 centimeters of depth, and they bond onto the steel surface. This is an active compound that can block really the corrosion process, so increasing durability. Increasing durability means maintenance at periods that are longer. So it means less wastage, less cost for your customer. Okay, once we fix about durability, so because we strongly believe that the first way of making a solution sustainable is making the intervention, is making the design, is making the structure durable. Okay, this is the best way to make it sustainable. Second way, of course, it's reducing the environmental impact. How we do? What we do is normally optimizing the formulation. I can skip this one. So by what I mean optimizing formulation, basically in the last 12 years, because we started 12 years ago with the sustainability topic in our range of materials, so what we did is trying to substitute the OPC, so the Portland cement, with alternative cement. And now all of our products have less than 5% of OPC, so it's almost nothing. So it means that the impact in terms of CO2 production, emission, not production, is very, very low. And this was done by the chemistry, this was done by years of R&D, this was done by years of investment in this field. And this is the trend that all the world is looking at. You can see that this is one material, it's one of our tile adhesive. You can see that we were able to reduce the CO2 footprint by 80%. It's a great achievement. Why it's important to reduce the OPC? Okay, the OPC, these are some numbers, average numbers from the industry, construction industry in the world. Okay, so the production, we are dealing with 9 to 14 billions of cubic meter of concrete per year. Okay, we are dealing with, that means 21 to 32 billions of tons of concrete. That means over 3 billion tons of cement. And if we look at, growing demand, of course, because the world of the construction is growing everywhere. India, I think it's one of the most growing economy right now. And if we look about the embodied energy and about the embodied CO2 emission of the type of cement, we can see very easily that the OPC is the most responsible, okay, in terms of CO2 emission. It's very simple to make the calculation. If you multiply 3.85 billion tons of cement by the OPC, 1 kilo means that every year we are emitting in the atmosphere, okay, 3.85 billion tons of CO2, only because of OPC. So why it's important to reduce the OPC? Because if we utilize alternative cement, like slag, like fly ash, you can see that the embodied energy for producing those kind of compound is much less. We pass from 5.5 megajoule per kilo to 0.3 or 0.1 in case of fly ash. It's a big reduction. If we look about the CO2 per kilo of cement, the reduction is quite bigger. So we are passing from 1 kilo, over 1 kilo of OPC produced, to 0.0017. It's almost zero. Is this sustainable? I think yes. We think yes. Of course, you have to be able to handle even the performance side, because reducing the OPC means impacting on mechanical performance, mainly the early strength. So in this case, you have to be capable of understanding how to integrate that lac into the materials. So in Europe, this yes, a European standard that is introduced this year, a new type of cement, SAM type number 6. It's composite cement made of 35% of clinker, 31 to 59% of slag, and we can mix up to 20% additional material like silica or fly ash or so on. The trend is avoiding the use of OPC, okay? The first one that we'll be able to do will win the race, I would say, because this is the race. Okay, just for giving you an idea of the concrete that we produce and the cement that we use in terms of sustainability, we have dealt with cement up to now, but if we take into account even the consumption of other material like sand and gravel, okay, the sand and gravel that we utilize every year, okay, it's enough for producing concrete, okay, that is needed for the realization of a wall, okay, globally passing through the equator, long 40,000 kilometers, 10 meter high, 30 meter width. So we have to think about, and this is happening every year. So this means that over, 100 years we can cover the whole world with concrete walls. The last topic that I want to discuss with you, it's about the recycling, the use of recycling compound into the composition. So these are some systems that we developed and we've implemented in the last years, in which you can see in one of the material we are using up to 45% of recycled material in the composition of the product. This is sustainable, yes, because we are in the field of recycling. Then we did implementation of the bags, use of recycled plastic bags, hydrosoluble bags for paper. If you see, and last but not the least, now we can skip it because we don't have much time. Yes, we are giving, the CO2 offset is done not only in terms of buying carbon credit. It's done by investing in social projects. So what we do is giving part of our potential investment into social projects, construction of dams for renewable energy production, protection of forests, and so on. This is, what we believe it's sustainability. Thank you very much for your time again. And so,
Hi, sir. Okay, yes. Yeah, thank you so much, sir, for a wonderful presentation in ACECON. Now, any questions from the participants? Yeah, hand over the mic.
You were telling 5% of OPC only you are using, and then remaining entire thing slag and then fly ash you are using. What is that formula which you are making it so that it will attain the full strength?
Okay, this is a good question that I can't reply. There is a bit of confidentiality behind, behind the response.
Okay.
But let's say that, I don't know if we can consider ourselves lucky or not, but since I'm coming from Italy, and Romans invented the concrete, I would say. So we are using some kind of pozzolanic reacting compound from 2000 years. And we are using still now in our formulation. So that's why we were able to reduce the OPC and compensating with alternative cement that we have in our hometown and homeland, I would say.
Not with chemicals?
Not with chemicals, so no. It's natural or recycled material like slag and fly ash. Or silica fume, sometimes we also use silica fumes. It's widely used. Yes. Yes, please.
Yeah, yes, sir. Yes. That one, sir.
See, here in India, climate is changing. Say, in Rajasthan, temperature goes to 45 degree plus with no humidity, and your European things are different. How that climate there can improve the situation here in our country? Just this one.
Okay, I hope that I get to the point. It's because of the climate change. You mean durability of the materials on site?
We are interested in durability.
Yes.
And the reduction of carbon thing. These are the two things that's why then only we can make things sustainable. So carbon, reduction of carbon footprint and then durability part. In our climate, what are the extra parameters you would recommend?
So when you refer to your climate, it means Indian climate? Okay. So I would say that, we are present worldwide and we used to develop products that are suitable for specific market and for specific climate. We are applying our material from the South Pole. Last year we did an application in the South Pole, okay, from the arid area in the middle of the desert, in which the temperature reaches 50 degrees and in which we have a very low humidity rate. So in your climate, let's say that, in terms of treating the concrete and curing, it's one of the best climate because it's hot and humid. So curing is the best. The worst condition is that when we have hot and low humidity. So in that case, we have risk of durability, and sometimes we have to utilize admixtures to cover and to be able to resist and be durable. In terms of climate change, when I was young in Italy, the maximum temperature during summer was 32, 33 degrees. 2 years ago, we reached 48. Okay, so just for giving you an idea that the climate change is worldwide, because I mean, with my colleagues here, many times we have fun, together. They say, hey, but in India you can't imagine how hot it is. And when I tell them that in Italy we had 48 degrees, they don't believe it. 48 is, the desert. And in Italy, up to 15 years ago, this was not happening.
Yeah, yes, Rico, nice.
Okay.
I think they got the answer. Yeah, thank you so much. It's a good presentation for enlightening our participants. Thanks a lot. Thanks so much.
Thank you very much.
Yeah.
Thank you.
Yeah, now the sessions we will start by the first person, Dhawan SK. The title is Performance and Durability of Reinforced Concrete, a review of corrosion challenges and structural implications. Please come on to it, sir.
As Professor Dhawan comes on to the dais, may I request the speakers of the other session, Professor Khan, Professor Lakshmi Saujanya, and Professor Gokul. I request all the three of you to please move to the Evoke Hall, which is in the ground floor, because your sessions are scheduled there. We are looking for you. Professor Khan, Professor Lakshmi Saujanya, and Professor Gokul. Request you to please move now to the Evoke Hall. Thank you.
3 minutes, let people ask me. Because I'll be sharing my own experience. 12 minutes.
12 minutes.
So I can, this side. Let it be here. Now is it clear? I can go.
Yes.
I know. This I know.
Yes, sir. You can proceed, sir.
Friends, we have been talking for the last 2 days about concrete, and then many people have talked about the performance-based concrete. So in the performance-based concrete, the people have talked about the type of material that we need, ingredients, then workmanship, supervision, proper tests. So there are no shortcuts. We have to do the right job, right planning stage, construction stage, and post-construction stage. Then only we can make the concrete durable. Now my topic today is performance and durability of reinforced concrete. Corrosion is a big challenge and its structural implications. Then I will try to, give some solution how we can prevent corrosion. As we all know, reinforced concrete is widely used in modern infrastructure due to its mechanical performance, versatility, and cost effectiveness due to steel tensile strength complementing concrete compression, but its longevity relies on the preventive steel corrosion from chloride, carbon dioxide, as I said, proper mix design, the proper ingredients, adequate water cement ratio, adequate concrete cover, good compaction and curing. These are the basic things that we need. Then reinforced concrete, as we all know, is economical, versatile and successful material, as it could be molded to a variety of shapes and finishes. In most cases, it is durable and strong, performing well throughout its service life. Reinforced concrete is composite material, as I earlier said, combining concrete, which is good in compressive strength, with steel, which has a more tensile capacity. Its popularity stems from advantages like cost effectiveness, adaptability, and availability of raw materials. Reinforced concrete is a composite material, as I earlier said, has occupied a special place in the modern construction in different types of structures due to its flexibility in form and superiority in performance. Durable concrete, as I said, performs satisfactorily in the working environment due to its anticipated exposure conditions during service. It has low permeability, adequate cement content, compaction, and adequate curing. This is the thing for a good concrete. However, its durability could be challenged, as we all know, by corrosion embedded in steel, particularly under aggressive environment exposure. Durability could be affected by various mechanisms, such as corrosion of reinforcement due to ingress of moisture. This moisture is very dangerous thing. Oxygen, carbon dioxide, chlorides, and many other deleterious materials. Chemical deterioration from aggressive environment, physical degradation due to freeze, thaw cycle, thermal stress or abrasion, then alkali aggregate reaction that would result in expansion of concrete and that would produce cracking. Now, performance and durability, as I said, this would depend on many factors, such as concrete quality, proper cover depth, taking the exposure conditions, workmanship, compaction, curing, and then use of admixtures, supplementary cementitious materials. As we know that engineered concrete consists of cement, fine aggregate, coarse aggregates, mineral admixtures, chemical admixtures, and water. The ingredient, quality of ingredient becomes the key factors in making the good concrete. Here I try to explain that the aggressive effect of chloride, we all know the pH value of the fresh concrete is over 13, which is alkaline. But with the chloride ingress, the pH value gets reduced, and which results to the debonding effect between the concrete and steel. And in the process, Fe with the help of plus O, we will get to Fe3O4, becomes a rust, and the volume gets increased to 8 to 10%. This excessive volume would exert pressure on the concrete. Concrete is weak in tension, so cracks would develop. So corrosion is like a cancer in the damaging the structure. So here I try to say that degradation versus time, the initiation period and propagation period, that's how scientist Tutti in 1982 said that this period to the acceptable damage level, we can at that time he worked out the service life of that particular element. Now, Tutti's model of corrosion, I have already explained, initiation period, that is time for carbon dioxide or chloride to reach the rebar critical level, no visible damage. Then further propagation period, once the passive film is lost, corrosion accelerates, rust, then the volume increase, expansion causing cracks, with further swelling and collapse, that means the end of service life of that element or the structure. Now the natural defense mechanism, I would try to say that the passive layer, concrete naturally protects embedded steel by forming a thin passive film on the rebar. Then it is alkaline, as I said, concrete first stage with pH value more than 13.5, and it maintains the passive film. And then because of this, our chloride ingress, the pH value gets reduced, the passive film gets depassivated, the corrosion starts, and finally, if we don't take care, the structure would damage and go to the collapse stage. Chloride-induced corrosion, I have already explained to you that the main thing is that pH value gets reduced with the, steel plus oxygen becomes the rust, which has the larger volume. It exerts pressure, cracks would develop, and further it can go to the collapse stage. Now, carbonation stage, here the calcium hydroxide and carbon dioxide, it becomes the calcium carbonate and water. Here also, the pH value gets reduced and the similar action of damage would occur. Now, this is the schematic diagram. I've tried to show how the carbon dioxide ingress. So, ultimately, the pH value will go down. The bonding between the steel and concrete will get reduced and the cracks would start developing. Now, corrosion reinforcement, I have tried to explain causes and mechanism. This I have already told you. Effect of corrosion on structural performance. Here, the reduction in cross-sectional area of rebar will reduce the load capacity. Cracking and spalling would weaken the concrete confinement. Bond strength deterioration between concrete and steel impairs composite action. Then increase deflection and potential for brittle failure in beams and slabs and other structural elements. Now, prevention and mitigation strategies. Here I have tried to explain in brief design and construction best practices available in our codes. There is no shortcuts. Then adequate concrete cover, low permeability concrete, quality workmanship. Then material innovation, as I said, mineral admixtures. We can use supplementary cementation material like fly ash or GGBS or silica fume. And then corrosion resistant rebars. And then we are using corrosion inhibitors also. I'll take 3-4 minutes. Advanced protection system, cathodic protection and surface treatment, maintenance and monitoring. The drainage and waterproofing is very important. Regular and proper inspection. Design and materials, I have already said. Then advanced protection, this we need to put all these corrosion inhibitors, epoxy coated bars, cathodic protection, which I have already explained. Then the key takeaways. Corrosion is inevitable but manageable through robust design. We have the codal provision, IS 456 again revised, IS 112, that gives we can make the concrete durable. Material optimization, proactive monitoring, that is very important. Now, the structural implications of corrosion, safety, it would reduce the load capacity, and then cracks, spalling, and then it can lead to the sudden collapse. Economy, high repair costs because of damage, then life cycle approach, proper design, right construction, proper monitoring, proper maintenance, that would make the concrete durable and the structure will have the proper and longer life. And then we have got the standard codes. These are the literature which is already available. that you can refer in my proceedings. And
Yes, sir.
thank you, gentlemen.
Yes, sir. Thank you so much, Dhawan, sir. It's a nice presentation. You are
I had
inspiration
given-
to so many people in this. Also, he is presenting very well.
I had given the chance. Any question? Because
Any questions from the
concrete has
participants?
been my actual field. I have used the concrete. 50 years back, there is no corrosion. So as I said, the right material, proper mix design, proper placing, proper compaction, proper curing, proper shuttering, there is no shortcut. If we do all this, the concrete, proper cover, then probably we can eliminate this corrosion.
Yeah, yes,
Corrosion
sir.
is a
Any
very
questions from the participants?
Please.
Please. From the participants, any questions?
Why are you silent?
So that
Come-
we
come
will move
forward.
to another session. Yeah.
My professor, you ask anything.
Thank you so much, sir.
Okay, thank
for
you so
giving-
much.
Yes,
Thank you.
thank you.
Thank you so much.
Yeah, next session, development of mixture design and workability assessment methods for pumpable heavy weight concrete with fly ash and slag. That's Santanam M and Kumar A, Venkat Swami and Venkat Chalapati. Yes, sir. You can proceed.
Very good afternoon to all of you. I am Venkatachalapati from Kalpakam. I am working in a nuclear project. I have to thank my guide, Professor Manu Santanam and Dr. Anish Kumar. They are my PhD guides. And I thank Professor KVL Subramaniam sir and Mr. Dr. Kandara sir and other committee members for accommodating and giving the opportunity to present a practical work. It has a sustainability solution and research component, and many things are there in this work. In fact, this work also nominated in the special concrete category of the IC award. That was in nomination yesterday. This work, in this project, I am last 10 years working as a quality assurance in charge. Now, in this front slide, what we are seeing is one of the 8,000 cubic meter cover slab, 1.2 meter thick, having 400 kg to 500 kg of per meter cube density steel. It is a cover slab, shielding a high level radiation shielding slab, and this has to be concreted by pumping. In fact, the project when they started, there is not having that plan of doing the kind of pumping, but after starting the project, there was a requirement. So in fact, I was started that problem as in a research problem also. Then after finding the solution, then we have implemented that solution as usual in the project. So what we are seeing is the placement of the left side figure is the placement of the concrete as usual in a normal weight concrete, around 29 cubic meter per hour. So the entire slab is of that, each pore is compartmentalized into 900 cubic meter size, and the middle figure is the interesting one, is a conventional slump test. That what we are seeing, the slump is a true slump, cohesive slump, and this is very important for this mixed design and workability criteria. In this presentation, I will just show how the workability is important for a pumpable mix, and that how it will work for a heavyweight concrete. So this is the outline of my presentation. So basically two components. One is mix design in my work and how the workability is assessed for this heavy concrete. So what we are seeing in the introduction is a heavy concrete requires lesser space. It relatively needs 58 to around 60% of the volume for the same weight, or it gives in 1 meter cube of heavy concrete gives around almost 60-70%, almost twice, I mean up to 4 ton per meter cube of density. So that much density is required for making the required nuclear shielding. So this concrete is used in some other applications in the infra area also that I will show in the next slides. So these are the counterweight bridge. It is used the heavyweight concrete, that portion which is on slanting, and underground anchor blocks, they required heavy weight and lesser volume, so that is used. And the right hand side is that nuclear cells and medical laboratories, they required this kind of heavy concrete. And this such a voluminous work has to be pumped and completed in time, because nowadays we wanted to complete the project in time. So these standards, if you go to the standards, there is drop pipe method suggested in the ACE standard is mentioned as a considering the placement difficulties. But however, we want to develop this kind of advanced methods, materials to expedite the project. So the pumping placement is a necessary and it is preferred. So this is another application where heavyweight concrete is used in London. That is a floating track slab, where this is the heavyweight concrete portion where we are seeing this rails are supported because of the dynamic characteristics of the slab, stiffness and mass, and the damping of that sound dampening purpose. This heavyweight concrete slab is used. This is another application. So coming to the next, the mixed design part. Again here, just for information is, the top figure is what we are seeing is the water cement ratio curve. So if you see the heavyweight mixes used by the various researchers, it is an extension of the normal weight concrete. So we wanted to be a lesser water cement ratio because water adding to the mix is reducing the density. So and other challenge is segregation. The heavyweight aggregate is almost that 4.8 gram per cc. So it will easily prone to segregate and it will choke the pipeline. So we don't want water, liquid medium in the mix. So people are preferring a low water cement ratio. So that is the reason the bottom figure, most of the researchers are getting a density around this 3.5 below, and some of them are getting 5 gram per cc of density, but they have used some special cuttings and other heavyweight materials. So this is the literature information available. So all researchers, they have referred as a slump as a basic parameter for the workability. So slump is more, density also slightly going down because of that workability thing. So we cannot increase the water component in the mix. Sometimes we will even by that labors using that addition of water for ease pumping. No? So it becomes here reverse. If anybody using water slightly excess or any mix having aggregate is having a slightly excess water, then pipeline will be choked. So we never use excess water in the heavyweight mix. So these are the, I am just giving a first itself the what is the mix proportion that we have used. So the project used M50 grade, that is called H50. Here 20% fly ash has been added and the paste volume is 33%, and then this is the mix used in the project site. In my research work, first I have compared 4 grades of concretes without fly ash, and then one I have taken for replacement up from 15, 25, 35%. That these work details of this work is I published in this ASCE Material Journal 2023. So more details are there. Here I wanted to give the results of the project site, how this heavyweight concrete proportion is worked for pumping placement, as well as how the yield stress has been estimated. So this is for a demonstration purpose I have selected. Then same mix I replace with slag. What is happening with 20% replacement? Exactly everything is kept. That aggregate is same source, water cement ratio is same, and admixer I have varied as per the workability requirement. So then I have checked how the yield stress varying. So these are the specific gravity, how you are seeing that left hand side, how it is higher than the normal. So 4.8 to 4.6, that is the range. this already. So the mixed design sequence I wanted to quickly complete. Here water cement ratio we will be selecting from the literature. So we will be knowing that so paste volume based on the previous normal weight concrete, what is the cement requirement for a particular grade that we know. So we can arrive the approximately water content and cement content. So the main portion is here. Please give me 2 minutes. Here that as we have seen other speakers, just it is done a combination of aggregates which gives the more packing density in the aggregate. So we will boost the density of the concrete, and then so we know this is the ideal curve which is giving a more density in the concrete. Then this is the paste volume. This is already in the literature. How compatible admixture we have to select. So that way we can optimize the dosage and making the stability in the mix. And then what we are seeing in the normal concrete is the rheological properties that is used based on the only rheometers. So rheometer will give the yield stress and the viscosity, but we don't have that kind of facility for heavy concrete. What has been done is, so what we are seeing the previous slide is that when concrete flows in a pipeline, there is a shear deformation is taking place. So finer material is coming to the top layer, that layer. So to simulate that, to mimic the pipe flow, what I have done is, I took a buoyancy balance setup. So nothing has been newly purchased or used costly things. That this is the standard bucket where we are using the density of the measurement of the concrete. Here that inner cylinder selected such a way that it gives an equal pressure on either side. So it is concrete is filled and then it is transferred to that platform. If you lower the platform, this maximum weight, whatever, when it is lowering, I will show it in the picture form. This is the flow chart that you can see it. Here this 20% fly ash mix, how this cohesively slump is showing for up to 1 hour. So we are seeing that yield stress is varying from 420 to 727 increasing after 1 hour. So here that video you are seeing here now, this is a mix that is placed in this side. So what we are seeing the other one is just showing that once that platform is lowered, we are seeing that weight is increasing. So weight will increase and then it will come down to the cylinder weight. So that means the maximum weight that is showing the shear force that is resisted by the concrete exerting on the cylinder surface. So the weight, if you are reducing the cylinder weight, and the remaining maximum force gives the shear stress over the exerted by the mix over the inner cylinder.
So come to conclusion.
So then it is plotted, and then this is the finish that we got after the mix, the completion, the finish beneath the surface, this is just a finish we got. So the durability in the sense, the mix is compared with the literature. So 125 years service.
Yes, sir. Yes, almost done. So come to conclusion, sir.
I conclude this mix. I thank the organizers for the opportunity. I will discuss with you for your more details. I am having that calibration, other details more in this.
Yes, sir. Thank you so much for your presentation, sir. Any questions from the participants? Yes. Yeah, please hand over the mic to him.
Sir, you are dealing with the quality assurance of bark and ACECON, it seems.
Yeah.
And there will be a lot of radiations maybe there in that nuclear power plants.
Yeah.
And how that, any protective measures you are taking in your design mix specifically, or any other parameters you are considering there?
Actually, this is the
in
purpose
design of
this,
those nuclear structures.
No, actually, civil structure is it is designed for the protecting the shielding. It is suppose one inner cell is having some radiation source. This wall has to be designed for the thickness of the required radiation. So shielding actually. So no, outside this wall, the shielding radiation should be within the limit. So like that, design philosophy is there. So it is the reactor physics. Science actually they will be taking care. Only they will be giving how much thickness of the wall that we have to construct for a particular location. It is 1.2 meter thickness. What we are using is heavy wall. It's 1.2 meter. If you are going for normal concrete same, then you require 2 meter. So it's a very massive thing. So we reduce the space with this heavy white concrete. Any other question?
Thank you so much, sir.
Thank you.
And next, any other questions from the participants? Yeah, thanks a lot. The next participant, Himagnaneshwari. and Srinivas Rao K. The title is Experimental Study on Self-Healing Concrete with the Effect of Sporosonsea pasteurii of the bacteria to improve the strength and durability of the concrete.
Good morning, one and all. I am Himangeshwari, research scholar from Andhra University College of Engineering, Visakhapatnam. First of all, I would like to thank you for the organizing committee, ACECON. It's a great privilege and for giving this wonderful opportunity to present my work. So, my work is on experimental study on self-healing concrete with the effect of Sporosacina bacteria to improve the strength and durability of concrete. So, and my research guide, K. Srinivas Rao Garu sir from Andhra University, he's a professor. So first of all, the self-healing concrete, which heals the concrete by itself to improve the strength, and it is a very promising solution when water and air moisture enters into the concrete, the outer layer of the concrete receives more economical and the life of the structure increases. So self-healing concrete, the problem is which heals the concrete by itself and the calcite produces and the metabolism formation occurs. So here the methods, so two methods are there in self-healing concrete. One is autogeneous and autonomous self-healing concrete. In autonomous self-healing concrete, natural mineral admixtures in autonomous self-healing concrete, biologically based, chemical based admixtures. In admixtures, two types of forms, mineral admixtures and expansive agents were used for autonomous self-healing. So the challenge and innovation of this self-healing concrete. So the problem is on mainly it have micro cracks. So the micro cracks can be filled by using the bacteria. So I use the bacteria as Sporosacina bacteria. So it is as a Bacillus family. So many bacteria which heals the cracks and fill the. So the problem is macro cracks. Due to the cracks are formed due to various conditions like environmental conditions and mechanical conditions like creep shrinkage and leading to reinforcement corrosion and reduced structural environment. So the solution is bioconcrete. So I introduced biological agents which are embedded into the concrete mix to fill the cracks. So I'm integrating the bacteria as Sporosacina bacteria and it produces. I also used calcium lactate which is the food for the Sporosacina bacteria and it integrates and the overall concrete mix can be prepared. And this sustainable approaches extends the life of the structure. So here the healing agent is Sporosacina bacteria. So it is a rod-shaped urolactical bacteria known for its calcite formation. So the cultivation I used grown in nutrient broth, sterilized and incubated at 30 degrees centigrade. So the mechanism is it metabolizes calcium lactate and precipitating calcium carbonate that seals the micro cracks. So this is enhancing for self-healing agent and the overall structural properties of concrete. So here the key advantages of bioconcrete. So one is extended lifespan. It increases, prolong the service life of concrete structures. And the environmental benefits are to reduce for repairs and maintenance for promoting sustainable and future development. So the cost effectiveness decreases long-term maintenance and repair costs. The huge amount of structure related to micro cracks and it improves the durability properties also. It enhances to chloride iron penetration and boosting overall resilience. So mainly the use of Sporosacina bacteria not only increases the mechanical properties but also offers enhanced against environmental degradation. So here the main focus on that is MICP, means microbial induced calcium carbonate precipitation. So first of all, I introduce the bacteria introduced, that is Porosesnia bacteria is embedded in the concrete mix and the cracks are formed. So the moisture and oxygen enter through these micro cracks. So and then metabolic reaction comes in contact. So if the bacteria metabolizes the calcium carbonate and the calcium precipitation rises. So if the calcite fills the and seal the cracks, and automatically it increases the mechanical properties and durability issues also. So here MICP mainly focuses on that generates carbonate compounds and it offers the mechanical and durability issues. So when a crack appears, oxygen and air enters into the real picture, means the bacteria, it analyzes the structure and fills the calcium and produces calcium carbonate, CaCO3. So these metabolic process calcite produces, which fills the voids and cracks. So here's the experimental procedure for bacterial concrete development. So first, I took the material collection as OPC 53 grade concrete and taken the coarse aggregate and portable bacteria with sufficient amount of Sporosesnia bacteria. And then I cultivate the bacteria with sterilizers at 30 degrees centigrade and verifies UV spectrometer. So I designed a mixed preparation for M30 grade concrete and I use the concentrations like by 5%, 10% and 15% of bacteria. So I casted the cubes for testing compressive strength, tensile strength and flexural strength according to the codes. So I comparative the analysis between conventional concrete of M30 grade concrete and Sporosesnia bacteria which is embedded in the concrete mix. So and the results are optimization. The maximum result attained at 10% of Sporosesnia bacteria. So I tested the mechanical properties like compressive strength machine by using IS 516, second one 2000, section 1 to 2021. And it tested the conventional and bacterial concrete by using split tensile strength and also flexural strength with 2-point loading and 3-point loading cases. So here the results of compressive strength at 0%, that is, just a minute. So conventional concrete at 0% and 5% of bacterial concrete 10% and 15%. So I promising the solutions of the exact mechanical strength must be improved at 10% of bacteria. And here's the flexural strength achievement for control concrete, that is 3.82, and for 10% of bacterial concrete mix it is 4.23. So the overall performance of concrete increases up to 20%. And the flexural strength compared to conventional concrete, that is for M30, and optimal mix, that is 10% of bacterial solution, the flexural strength automatically increases. So here my key research findings. So the optimal concentration at 10% would be increased, and the strength enhancement 26% for compressive strength, 11% tensile improvement, and 33% flexural strength improvement. And durability, I not tested the durability test, only up to the mark the concentration is on my mechanical properties only. I still to continue this work. So the autonomous recovery, that is self-healing repairs, and 30 to 40% of the original strength can be achieved. So here the future scope of my bacterial concrete. So main the source Sporosesnia bacteria, which is invariable biological agent which can be used to increase the mechanical properties. So, and the research implications and the next steps I have to go for MICP technology by using regular cost experimentation and environmental effects. And next step, what is the field application used for the future development and sustainable concrete development? Thank you. Thank you for giving this wonderful opportunity. Thank you.
Yes, yeah, good presentation. Anyone having questions from the participants? Any questions from the participants? Yes, yeah, please hand over the mic.
What is the cost increase per meter cube of concrete by using this?
Sir?
The cost for cubic meter.
For bacterial concrete, sir?
Yes.
Sir, cost, I don't have ideas.
Yeah. So, Bacillus pasteurii, what is the liter cost? So that they can find easily.
I cultivate the bacteria in incubation center.
Okay. Generally outside it is available around 500 rupees, sir. Bacillus pasteurii as well as Bacillus subtilis, and there are some other bacteria, sir.
I didn't buy. I'm still working on that, sir. Just I recently 1 year completed, sir. Just
we should see that.
Yes, sir. Yes, sir. Sure, sir. Sure, sir.
When we are doing in the new fresh concrete, we can introduce this bacterial. But if it is an existing structure with lot of cracks, can we make use of this bacteria? Is there any scope for that or no?
Sir, I'm focusing on main repairs and maintenance. If the existing structure, I'm applying this technique, but it in future.
No, actually, sir, whatever your question, for that in Henk Jonkers from Delft University, they started research on that. They are introducing the self-healing concrete for the rehabilitation to the structures. So now they are creating on a foam, so that if we inject to that foam, it will be definitely heal the inside cracks also. Still research is going on in India, maybe soon it will come.
Okay, thank you.
Yeah, there is some patent issues are there regarding this. Yeah, thank you so much. Yeah,
thanks. Thank you.
Yeah, the next participant title is Performance Evaluation of 3D Reinforced Concrete Sandwich Panels Incorporating EPS Core by our technical chair of this ACECON, KVL Subramaniam sir. Please come on to your desk.
My student who couldn't be here because he had to be with his family. Quickly, I'll get started. I do want to acknowledge my other student, Sivaram Nayak, whose work I'm presenting, and Sohant Maganti, who basically worked on the initial problem. And the outline is as follows. I'll give you a brief introduction of what we're talking about with this 3D reinforced EPS core sandwich panel. The motivation, background, role of shear, which is very important. I want to touch upon it a little bit. And how we can improve the performance through detailing and improving or enhancing the material ductility. And finally, our findings. So this is what we talk about when we say it's a sandwich panel. Sandwich panel is basically 2 layers of concrete. If I can just find the pointer. Sorry. It's basically 2 layers of concrete which are separated by an EPS core. What you achieve by this is you have 2 thin layers of concrete about 40 millimeters each, and you're able to produce slabs which give you almost equivalent, at least they claim that they give you equivalent performance as what you get with a solid slab. So this is basically in a class of what we are developing as material efficient systems. You're able to develop slabs or beams where you take away material where it's not required. So what happens in an EPS sandwich core panel? The core is essentially, the core that you see is EPS, so it's lightweight. You have 2 shells of concrete, and it claims to give you the same performance as that of a regular slab at a lower weight. Now, you can use these in slab panels, wall panels, etc. You can use these integrated panels for construction house, and the advantages it gives you is very good thermal properties and even acoustic properties. So, now, what is the advantage with this EPS, with this sandwich core panel system is typically in a beam, the web really doesn't contribute much to the stiffness of the member, or for that matter, the capacity. So if you take away this material, replace it with something lightweight, and put material where it belongs, you basically get something that looks like an I-beam. Now, if you extend this concept to a slab, what you would get is you can remove the entire core, put something lightweight, and then produce a slab where you only have two widths of concrete, two layers of concrete that are basically the two structural members separated by this EPS core. Now, so what happens when you do the EPS core is you run into this tricky situation where you can get, typically what we're used to seeing is this composite action where you get this strain diagram which is linear. But then if you actually put a flexible core in between, the two structural widths that you have can bend independently and you get full non-composite action. What you get in this EPS core panel is something that is partially composite. So you don't get the same structural stiffness or the strength as that of a regular concrete slab element. So knowing this, and the reason, one of the biggest problem is that the EPS core that you have actually, because it is flexible, it deforms in shear, and that leads to additional deformation, additional deflections in the beam. So now, and so this situation evolves. If you look at a concrete, at a beam that is made of sandwich core panel, you have two concrete widths. This is the EPS core, and it is loaded with the UDL. If I was to look at two different locations, suppose I look at the location where I have, I'm sorry, we have two different types of loading. If I look at the UDL loading, at the center span, I have high bending moment but very low shear force. But if you look at the concentrated force, what you would find is that you have a high bending moment with high shear. Now, normally what happens is if you match the moment in the two cases, you would get almost similar deflections or almost similar stresses. But because here the shear stress is high, the point load will actually give you much higher deflections. It deforms a lot and it basically gives you much higher stresses in the material. And this particular beam actually fails at a much lower concentrated force than if you were to subject it to a UDL. So these are the tricky things that we encounter when we move into this EPS sandwich core panel. Now, so we started our tests with the sandwich core panel. We just bought a commercially available one, loaded it in this point force, because remember, this is the loading configuration in which it is critical, because here, right under the load point, I have very high bending moment and very high shear. So when you load it in this configuration, this is what we get. This is a slab that's being sold in the market. Now, you see that, the load actually builds up to a peak value, there's a big drop, and after that, the load never recovers. So this is a very dangerous situation for me. That is, if I have a slab and I put a point force on it, with a commercially available sandwich core panel, it will crack, and after that, it never recovers its load capacity. And the post-peak load resistance actually is much smaller, and even the stiffness is actually much lower. So this is not something that is desirable in a structural product. So we started going about trying to improve the two aspects. One is the post-cracking load response and the ductility in the system. We wanted the system to deform much more before it fails. And that was done by means of detailing and by basically introducing, producing shear transfer between the two concrete layers by introducing shear keys and improving the material ductility in the system. So basically we introduced this improvement in ductility where we introduced the shear keys, which are made of concrete. It's about 25 millimeters in diameter, about 100 millimeters in length, which are inserted through the EPS core, and these basically connect the two concrete widths. For enhancing the material ductility, we used hooked end steel fibers. And you can see that when I do a flexural test with the hooked end steel fiber, the blue line here is what you get for regular concrete. When I add just 25 kgs per cubic meter of steel fibers, this is the response I get. And when I increase it to 45 kgs, I start getting a nice ductile response from the material. So now what happens when I do both of these improvements? We put shear keys and put these fibers in there. What you see is that this is the control response. If you remember, it cracked here, the load dropped, and it never picked up. But you see, this is the load response that we're able to get. There's a significant improvement in the post-peak load carrying capacity and also the ductility. So we've taken an old system, which was not ductile, which didn't have post-cracking resistance, and we've made it very ductile, and we've significantly enhanced its post-cracking load carrying capacity. So now it is a structural system that's worthy of being used in any situation. And when we actually compared the load capacity of these strengthened shear slabs, which had material ductility with fibers and shear keys, they were comparable with what we would get with a conventional concrete slab. And the minimum thickness of the concrete slab that we use in the field is 125 millimeters. What we are able to do here is with 80 millimeters of concrete, we are able to achieve this. So these material efficient systems give you the same performance as what you get with the regular concrete system with much lower use of concrete. So finally, to conclude, when we tested the commercially available systems, we found that they were surprisingly lacking in post-cracking load carrying resistance and in ductility, and we were able to enhance both these features by simple enhancements in detailing and by material ductility. And basically with shear keys and steel fibers, we're able to bump up the response to a point where it matches a conventional slab which uses a lot more concrete. So with that, my time just got up. I thank you for your attention. I would be able to take any questions.
Yeah. Thank you so much, sir, for your wonderful presentation. Now it's time for questions. Sir, Kalyan Ram, sir.
Oh, Kalyan Ram, okay.
Yeah.
Professor, excellent presentation. My simple question is, how much saving of material you would be able to make by putting the same type of load? Second is, by dynamic load, supposing we want to use this as a deck in the bridge, so what type of damage, fatigue losses and other damages we can prevent by adopting this technique? Thank you.
Two wonderful questions. So first thing is, how much material did we save? Here is the deal. If I was to design, suppose a 7-meter slab, I'm just giving you exact numbers here. 7-meter slab, typically you would have to take at least minimum about 175 millimeters of concrete, right? That's a typical standard, and it's governed by serviceability requirement, right? Now, I can give you the same slab with 80 millimeters of concrete, 2 layers of 40 millimeters that are separated out, and give you the same performance as what you get with 75 millimeters of concrete. So now you do the math. I'm basically saving almost 100 millimeters of concrete spread over an area of 7 meters by whatever width that you have. That is your material savings, right? So I'm using less material without compromising performance. The second thing is coming to fatigue. The fibers that we have tremendously enhance the fatigue performance of the slab. So now even if a crack forms, the fibers hold the crack together, so the crack really doesn't open. So I'm able to improve the serviceability performance and the ultimate load also, capacity, right? So I'm addressing both points.
Yes, sir. I think next, Kalyan Ram.
Sir, actually, you are using fibers as a reinforcement. You have a EPS core at the internal part. Can we also use a mesh at the top of the core and the bottom of your EPS sheet as a reinforcement?
No, mesh is always there.
It's always there.
Yes.
So, and it's a steel mesh.
Yes, yes, yes.
Okay, and the diameter, sir, like 4 or... can it be a
2.5 millimeters or 3 millimeters. That is the diameter of the mesh. 50 mm by 50 mm opening.
Okay, sir. Thanks.
Okay. Next, last.
Coming from a designer,
Sir, you have given a nice picture, but you have shown some inclined bars and all that for shear arrangement, whether that are there or only or shear studs like thing you are using.
No, So what we get is this prefabricated 3D reinforced EPS core, 2 meshes, and I perhaps glossed over that. Which are 50 millimeters with 50 millimeter opening with made of 2.5 millimeters or 3 millimeter wire, and these meshes are held in place by these diagonal struts which are just tack welded and they hold essentially the 2 meshes in position. Now the diagonal wires also hold the EPS core in position, otherwise the EPS core will simply move up and down. So and because they're tack welded, they're not necessarily providing any shear resistance. They're there just to hold the 2 meshes in position and to hold the EPS core, lock it in position. What we introduced, yes.
Yes, sir, thank you. Last question.
Sir, I just want to check whether these EPF panels, what we are talking about, is this the structural members or just for the partition members?
No, I showed you for real slab. It's a load-bearing slab.
Yes, sir. In that case, what are the properties to be taken into consideration for the design parameters, like Young's modulus and creep shrinkage? We have to define the parameters in the ETAPS while designing, right?
I didn't get the intent of the question. What do you mean parameters for
Sir,
design?
for designing the structure, how many stories can the structure can be designed using these EPF panels? I just want to check.
Okay. Yeah, okay. Typically when we suppose I use it as a slab panel, right? Now,
Yes,
whether it is a 10-story or the first story, the slab remains the same.
Yes, sir.
All it is designed is for gravity loads. How does it matter how many stories you have?
Sir, but to design a structure in the ETAPS, we need to define the element properties, like what is the shrinkage, Young's modulus. It has to be given.
But those are material properties, right? Those are not structural properties.
So what we need to consider for this concrete, these EPF panels, I'm asking.
Whatever is the property of concrete.
The same.
So let's not confuse the material properties with the structural performance, right? You're talking about material properties, creep,
Yes.
shrinkage, modulus, these are all. So whatever concrete you want, you make M60, you get the corresponding strength and stiffness. If you make M30, you get the corresponding strength and stiffness.
Okay,
So that's a material property you're talking about,
Yes.
right? Yeah.
Yeah, thank you.
Thank you, sir.
So thank you so much,
Okay,
sir, for
thank
our
you.
wonderful presentation.
Oh,
Yeah, next. Yeah, last presentation for this session by Prakash K.E. Please come on to the dais. The title is Study on Strength Properties of Geopolymer Concrete with a Partial Replacement of Coarse Aggregate by Ceramic Tiles.
Respected chairperson and participants and delegates, at the outset I thank the organizers for giving me an opportunity to present the paper on study on strength properties of a geopolymer concrete with partial replacement of coarse aggregate by ceramic tiles. Introduction. The problem is environmental challenge. Global warming is a major concern. Ordinary Portland cement production accounts, as you know, that 7% of the global CO2 emission. Cement is a resource, but it consumes a lot of energy for the production. And as you know, that one now the problem is industrial waste disposal, which consumes the valuable land. The need is geopolymer concrete, an eco-friendly alternative to OPC, utilizes industrial byproducts, fly ash, GGBS, rice ash. Sustainability, partial replacement of natural coarse aggregate with ceramic tile waste. The objectives of this study: to produce geopolymer concrete by fully replacing cement with pozzolanic materials, fly ash, GGBS, rice ash, and to study the effect of partial replacing coarse aggregate with ceramic tile wastes, and to determine the optimal percentage of tile replacement for maximum strength, and to analyze the compressive, tensile, and flexural strength at 7, 14, and 28 days. Materials characterization, binders. Fly ash obtained from the thermal power plant, gray color, rich in alumina silicate. GGBS, byproduct of iron slag, white color, dried and ground to fine powder. Rice ash, byproduct of rice processing. The key feature: contains 91% silicon dioxide, excellent pozzolanic behavior, and reduces setting time. Materials, aggregates and activators. Fine aggregate, that is natural river sand. Coarse aggregate, 20 mm down sandstone. Replacement material, ceramic tile waste, partial replacement of coarse aggregate. Alkaline activators, sodium hydroxide and sodium silicate. Chemical constituents: rice ash, highest silica content, 91% of SiO2. Fly ash, 61.19% SiO2, 31.25% Al2O3. GGBS, high calcium content, 43.5% CaO. These chemical composition allow for effective geopolymerization without the use of cement. Methodology and mixed design. Binder ratio 80% fly ash, 11% GGBS and 9% rice ash. Coarse aggregate replacement variables, so from 0 to 75%. Preparation, alkaline solution prepared 1 day in advance, dry mixing 3 minutes, wet mixing 8 minutes, and specimen cast cubes 150 into 150 into 150 millimeter, cylinders and beams. Experimental process, preparation, as I already told, alkaline solution prepared 24 hours in advance, mixing process, dry mix of aggregates, binders and tile waste 3 minutes, wet mix with alkaline solution 8 minutes. Curing and testing, specimens compacted properly and tested for 7, 14 and 28 days. Results. Compressive strength. Test conducted at 7, 14 and 28 days. Observation. Strength increases with the addition of tile aggregates up to 25%. After 25% replacement, compressive strength begins decline. The reason is the excellent bonding between tile aggregate and the geopolymer paste is up to 25%. Higher percentages makes the mix brittle, reducing the strength. So we can see the graph. So in that graph, at 25%, we have the maximum strength. For 20 days, 7 days, 14 days and 28 days. Next, results, flexural and tensile strength. Tensile strength follows the same trend as compression, peak performance at 25% replacement. Flexural strength, highest strength recorded at 25%, 7 days and 14 days and 28 days strength were similar and with progressive rise at 28 days. Curing, geopolymerization reaction pace improves significantly after 14 days. So now we can see the graph. So for 7 days, 14 days and 28 days in all, so around 25% the strength is more. Discussion. Role of rice ash reduced the setting time, made it harden faster. The addition of rice ash was observed to reduce the setting time of the concrete. Role of tile aggregate. The study indicates sufficient dissolution of materials leads to better bonding at 25% threshold. So excess amount, that is more than 25%, exceeding 25% tile waste interferes with geopolymer gel formation, creating a negative impact on strength. GPC mixing containing FA, GGBS, RHA provides sustainable strength. Conclusion, optimal mix, incorporation of ceramic tile aggregates up to 25% shows positive effect on strength properties. Sustainability, industrial byproduct, fly ash, GGBS, rice husk, tile waste can be successfully utilized, reducing landfill requirements. Eco-friendly, the process eliminates Portland cement, reducing the carbon footprint. Application, this geopolymer concrete is suitable for the infrastructural works. These are the references.
Sir, please hand over the mic.
Surface texture of the tile.
No, that is below 20 mm size splitted tiles.
Okay. But is it a smooth surface or rough surface?
No, no.
How do you get the bond?
Rough surface only.
Rough surface only. Okay.
Yes, yeah, thanks. Next, Raus. KVL Raus.
My question is similar to the Dr. Kantada's question. Whenever you are using the tile as a coarse aggregate material, one side we have the glazing surface, other side we have the rough surface like refractory surface. In such a case, once we are designing for a high strength concrete, there is a failure with respect to the interface bond shear. with the cement paste, there is a definitely a failure with the your interface bond with the aggregate, coarse aggregate with the cement paste. That point is to be addressed. Have you noticed any such findings in your research work?
No, I have not noticed.
That is one of the crucial factors.
Yeah, yeah.
Otherwise, your strength during the fracturing of the interface will take place at low strength concrete also.
Okay, I will note down that one. Next I will check.
Yeah, next, how's your name, ma'am?
Good morning, sir. I'm Dr. Vani from Maitam. It's a basic question. Newly, I am doing this research in geopolymer concrete. For convectional concrete, the end product is CHS gel that gives strength. Now, what is the end product of geopolymer concrete that gives strength?
What is the?
End product.
End product.
End
product.
That gives strength for geopolymer concrete. In conventional concrete, it is CHS gel and etringate that gives strength. For geopolymer concrete,
I have told. That
Yeah.
bonding is good, no?
Sir, please, Kandarao sir, sir will explain.
Aluminosilicate three-dimensional network, madam.
Aluminosilicate
3-dimensional formation. That's what gives the strength actually.
Yeah.
Exactly. Calcium silico-aluminate.
Yeah. So, any questions from the participants? Yeah. Thank you so much, sir, for one.
Thank you very much.
Yeah. Now I think all the papers completed. Now I request Girish sir come on to the dais.
Thank you, Dr. C.V. Shivaram Prasad Garu, for sharing this session, and to all the people who presented their papers and spoke here. On behalf of Indian Concrete Institute, Hyderabad Center, may I request Kantarao Garu to please come and do the honors on to Dr. C.V. Shivaram Prasad Garu. We would like to convey our thanks to also the keynote speaker, Engineer Umberto Rico. Engineer Umberto Rico, are you here in this hall, please? Probably he has stepped out. Thank you. So the next session that we have is after the lunch. Lunch will be for 30 minutes. It is being served in the same place that it was yesterday afternoon. The next session will be a plenary session where all the audience are required to assemble in this hall, and we have got 3 excellent talks, in fact 4 talks. The plenary session will be chaired by Dr. Architect Engineer S.P. Anchuri Garu, and it will begin with an address by Dr. Manmohan Kalagal. He will speak on the topic of decarbonizing concrete construction, a collective responsibility. The second plenary address will be by Professor Abhijit Mukherjee on circular economy of construction, learning from nature. And the third talk will be on by our Professor Mahesh Tandonji on resilience of bridge construction in climate change scenario. As we do that, we will split again after the plenary session into individual sessions in the respective halls. We'll break for lunch now. I request all of you to join us for the lunch, and we'll assemble back within 30 minutes from now. Thank you.
పోడియం మొత్తం పడాలి మేడం. ఓకే.
Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. As a non-profit organization, ICI is dedicated to the cause of disseminating knowledge and addressing constant research needs in the field of concrete, as well as to promote concrete technology and quality in construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training program, webinars, and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest materials, technologies and practices. ICI's program Deminar is a unique event combining demonstration and seminar. Here products are demonstrated outside and they are live streamed into the seminar hall. Thus the participants can observe the demonstration while it is being explained by the speaker. ICI events, among other things, are focused on sustainability through the use of innovative materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users and society at large. On 7 September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. Working in close coordination with central and state government bodies like CPWD, PWDs, CBRI, CRRI, SERC, IITs, municipal corporations and more. ICI helps these bodies to adopt latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS focused towards advocating standardization in construction practices. ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of more than 10 Asian countries. ICI has signed MOUs with many other peer concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through its students' chapters. There are more than 300 students' chapters all over the country and the numbers are constantly increasing. Each chapter is focused on enabling industry-academia interaction aimed at bridging the gap between basic theoretical knowledge and professional practice. This imparting of requisite knowledge to budding engineers enhances their outlook and employability. ICI identifies, recognizes and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To demystify concrete, the Technical Board of ICI brings out valuable technical documents on topics of importance for the benefit of practicing technocrats through its technical committees consisting of subject experts from different disciplines. ICI conducts need-based training programs at its technology centers as well as customer sites for the benefit of practicing engineers and students. ICI Journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable, and best in the world. Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. As a non-profit organization, ICI is dedicated to the cause of disseminating knowledge and addressing constant research needs in the field of concrete, as well as to promote concrete technology and quality in construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training program, webinars, and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest materials, technologies, and practices. ICI's program, Deminar, is a unique event combining demonstration and seminar. Here products are demonstrated outside and they are live streamed into the seminar hall. Thus, the participants can observe the demonstration while it is being explained by the speaker. ICI events, among other things, are focused on sustainability through the use of innovative materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users, and society at large. On 7 September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. Working in close coordination with central and state government bodies like CPWD, PWDs, CBRI, CRRI, SERC, IITs, municipal corporations, and more. ICI helps these bodies to adopt latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS focused towards advocating standardization in construction practices. ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of more than 10 Asian countries. ICI has signed MOUs with many other peer concrete institutes around the world for exchange of technical documents and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through its students' chapters. There are more than 300 students' chapters all over the country and the numbers are constantly increasing. Each chapter is focused on enabling industry-academia interaction aimed at bridging the gap between basic theoretical knowledge and professional practice. This imparting of requisite knowledge to budding engineers enhances their outlook and ICI identifies, recognizes and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To demystify concrete, the Technical Board of ICI brings out valuable technical documents on topics of importance for the benefit of practicing technocrats through its technical committees consisting of subject experts from different disciplines. ICI conducts need-based training programs at its technology centers as well as customer sites for the benefit of practicing engineers and students. ICI Journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable, and best in the world. Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. As a non-profit organization, ICI is dedicated to the cause of disseminating knowledge and addressing constant research needs in the field of concrete, as well as to promote concrete technology and quality in construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training program, webinars, and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest. Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. As a non-profit organization, ICI is dedicated to the cause of disseminating knowledge and addressing constant research needs in the field of concrete, as well as to promote concrete technology and quality in construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training program, webinars, and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest materials, technologies, and practices. ICI's program, Deminar, is a unique event combining demonstration and seminar. Here products are demonstrated outside and they are live streamed into the seminar hall. Thus, the participants can observe the demonstration while it is being explained by the speaker. ICI events, among other things, are focused on sustainability through the use of innovative materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users, and society at large. On 7th September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. Working in close coordination with central and state government bodies like CPWD, PWDs, CBRI, CRRI, SERC, IITs, municipal corporations, and more. ICI helps these bodies to adopt latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS focused towards advocating standardization in construction practices. ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of more than 10 Asian countries. ICI has signed MOUs with many other peer concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through its students' chapters. There are more than 300 students' chapters all over the country, and the numbers are constantly increasing. Each chapter is focused on enabling industry-academia interaction aimed at bridging the gap between basic theoretical knowledge and professional practice. This imparting of requisite knowledge to budding engineers enhances their outlook and employability. ICI identifies, recognizes and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To demystify concrete, the Technical Board of ICI brings out valuable technical documents on topics of importance for the benefit of practicing technocrats through its technical committees consisting of subject experts from different disciplines. ICI conducts need-based training programs at its technology centers as well as customer sites for the benefit of practicing engineers and students. ICI Journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable, and best in the world. Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. As a non-profit organization, ICI is dedicated to the cause of disseminating knowledge and addressing constant research needs in the field of concrete, as well as to promote concrete technology and quality in construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training program, webinars, and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest materials, technologies, and practices. ICI's program, Deminar, is a unique event combining demonstration and seminar. Here products are demonstrated outside and they are live streamed into the seminar hall. Thus, the participants can observe the demonstration while it is being explained by the speaker. ICI events, among other things, are focused on materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users, and society at large. On 7 September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. working in close coordination with central and state government bodies like CPWD, PWDs, CBRI, CRRI, SERC, IITs, municipal corporations and more. ICI helps these bodies to adopt latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS focused towards advocating standardization in construction practices. ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of more than 10 Asian countries. ICI has signed MOUs with many other peer concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through its students' chapters. There are more than 300 students' chapters all over the country, and the numbers are constantly increasing. Each chapter is focused on enabling industry-academia interaction aimed at bridging the gap between theoretical knowledge and professional practice. This imparting of requisite knowledge to budding engineers enhances their outlook and employability. ICI identifies, recognizes and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To demystify concrete, the Technical Board of ICI brings out valuable technical documents on topics of importance for the benefit of practicing technocrats through its technical committees consisting of subject experts from different disciplines. ICI conducts need-based training programs at its technology centers as well as customer sites for the benefit of practicing engineers and students. ICI Journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable, and best in the world. Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete.
Good afternoon and welcome back to the post-lunch session. As we begin, may I request the advertisers and the sponsors, MYK Arman Private Limited, Red Warp Chemicals Private Limited, Dhirendra Group of Companies, and Vishwa Samudra Engineering Private Limited. All of you, I request you to please load your deck or PPT presentation or your corporate video onto the AV desk so that we are ready. We will play these commercials after the two speakers of this particular plenary session. With this, now we begin, and we have a very distinguished professional who is going to lead this session as the session chair, and he is Dr. Architect Engineer S.P. Anchuri. He is a distinguished architect, structural engineer, and artist with a very rare multidisciplinary experience, a triple graduate and a triple postgraduate. He holds degrees in civil engineering, architecture, structural engineering, business administration, and concrete construction management, along with a PhD in structural engineering from JNTUH. His current research focuses on integrating architecture and structure for optimized high-rise design. He is the chief consultant at Anchuri & Anchuri, a firm with over 25 years of experience and expertise across Hyderabad, Amravati, and Vizag, and have delivered over 2,500 integrated architecture and structure projects, especially large housing developments. Dr. Anchuri has served as technical consultant to the Tata Projects, technical advisor to ASCI and the ECBC, and ex-technical advisor to the RMCMA India. He holds a leadership roles across many organizations, and importantly at that, he is a chairman as well for certain organizations, and he is a member and a very core committee member at that for associations such as Focus, EC member, IEA Telangana State, and Vice President South. Also as a member of IS Tract E. He has delivered 100 plus webinars, presented 100 plus technical papers, and organized numerous, including national and international events, with 650 plus TV episodes on architecture and housing. He is also the first ACBC third-party assessor in Andhra Pradesh and Telangana, consulting on over 100 plus major projects. Ladies and gentlemen, please give a big hand to the session chair, Dr. Architect Engineer SP Anchuri. Over to you, sir.
Thank you, Mr. Girish. In fact, this is the final plenary session, and distinguished guests, respected speakers, delegates, and invitees, namaste. It's a great privilege to welcome you all to this final plenary session at Kohinoor Hall. The theme of the session goes beyond conventional boundaries of civil engineering, because for me, transdisciplinary approach is very important, which integrates the structural engineers, material scientists, environmental scientists, architecture, urban planners, policy makers, economic forum people, and social responsibility, and etc. And we are privileged to have two eminent thoughtful leaders of the industry with us. First is Dr. Manmohan Kalgal, who will be talking on the decarbonizing the concrete construction, a collective responsibility, and Professor Abhijit Mukherjee on circular economy of construction, learning from nature. I invite all of you to actively participate. And before I invite Dr. Manmohan Kalgal, who is my guru also, in fact, in terms of event and organizing good conference, so I think, Chela. Dr. Manmohan Kalgal, the technical advisor of Ultratech Limited, was the president of Indian Concrete Institute from 2015 to 2017, and the vice president of Asian Concrete Federation from 2017 to 2018. Dr. Kalgal was the joint president of Ultratech Cement Limited. He headed the building products division until 2010, responsible for R&D and the launch of new building products, as well as the erection of production facilities. He served as General Manager Technical and Business Development at BVR India Limited. Dr. Kalgal obtained PhD from IISc Bangalore in 1993, but he is presently the President of Structural Engineers World Congress India, and the list goes on. So I will invite you to have your talk, and the time is 30 minutes. Thank you.
Good afternoon. In fact, I was telling somebody that we should have had a facility to give the talk in the dining area, because most of our friends are there. And those, of course, who have finished their lunch and are here would probably want to relax. So, Professor KVL was telling me that I should give a scintillating lecture. Not at this time of the day. So this is a very what can I say, lecture which is not going to tax you. So you can take a decision as to what you will do in this session. Well, okay. So the name says it all. Decarbonization of concrete construction and a joint responsibility. So you know what I'm going to focus on. Now, all of us by now at least would have known what is decarbonization all about, and the goal of trying to make this world carbon free or carbon dioxide free or carbon dioxide equivalent free has been tried for quite some time now, and people have very robust, ambitious plans to do this in every field. It's not the construction field, but since we are connected to construction and we are connected to concrete construction, so I thought we will dwell some time on discussing what are the things that we can do. So major focus started in 2015 when people started officializing the commitments, and they have put this treaty in place. This was in 2015. Now we have come 10 years from there, and several of the goals that were set in are also getting slightly refined, seeing the reality. And one of this is to limit the global warming to well below 2 degrees, preferably 1.5 degrees. Now we are realizing that looks like it's not easy to achieve this particular target, so we are slightly shifting the goalpost here. And it's also known very well that the human caused emissions of carbon dioxide will have to fall drastically by 2030. 2030 is just 5 years from now. And Morning Hegde has given a very elaborate scenario as to what is likely to happen if we are not taking things seriously. So several agencies are trying to quantify this efforts of reduction or decarbonization, and one of that is the Global Carbon Project headed by the University of Exeter. Many are there, but I have just taken one to get some data or some statistics. So the fossil fuel carbon dioxide emissions are already hitting a very high value in 2025. That's what the report says. Some statistics: global emission trends of 1.1% is already there, which is a record of 38 billion tons this year. And the global fossil emissions in 2025 are rising in all sectors and all major fuels, with coal up 0.8%, oil up by 1%, and natural gas up by 1.3%. Despite years of climate action, at least 10 years we have spent on serious efforts, global emissions have not begun to decline yet. That is the sad news. So again, some more statistics that the total global carbon dioxide emissions with fossil fuels and land use is around 42 billion tons, similar to 2024. That means year on year we should have reduced, but it is remaining flat. And the carbon budget and climate risk, it says that, as I told, 1.5 degrees centigrade, what we were planning to have, is almost exhausted, with only about 170 billion tons of carbon dioxide remaining for 2025 levels. So even staying below 1.5 degrees centigrade, as I said, is no longer realistic, and it's already weakening the land and ocean carbon sinks, reducing their ability to absorb carbon dioxide. So how are we in India? the India's emission trends indicate that our emissions are expected to increase from 3.19 billion tons in 24 to 3.22 billion tons in 25. Instead of reducing, it's increasing because our efforts are not good enough. And there are other issues as well. So India's per capita emissions stand at 2.2 tons. Of course, we have a huge population, so the denominator is very comfortable, but that's not a realistic or comforting thought. So because of our population, we are the second lowest among the largest economies, but coal remains a primary source of carbon dioxide. That is because we haven't fully utilized the other alternatives in terms of fuel is concerned. So India is the third largest emitter of carbon dioxide at 3.2 billion tons, led by US, which is 4.9, and China, which is 12 billion tons. So the numbers are huge in comparison to us, but that's no comfort because China, big country, but a lot of developmental works they took up. Naturally, developmental works are connected to carbon dioxide emissions, and that's why they are emitting so much. We are now entering that phase of taking up vigorous construction, and no wonder the values are rising instead of falling, because activities in construction field or any other field have all gone up. So we are moving towards China's, if you can call it, achievement because of our developments. So India's annual emission growth averaged 6.4% between 5 and 14, but has dropped to 3.6 during 14 to 24, reflecting some improvements in carbon intensity and utilization of renewable things. So building materials is a big field, and this is likely to dominate the climate change as people are envisaging. And the greenhouse gases from the sector is at least 37% of the global emissions. This is again from a United Nations Environmental Program report in 2023. Most of the progress in the sector has been made on reducing the operational energy or operational carbon emission of a building, and the emissions created from heating and cooling, which is operational carbon, is the focus, or it has been the focus for quite some time. But what we are concerned is also the embodied carbon, which from the day one till today people have been suggesting various ways of reducing this so-called embodied carbon in the construction scenario. And the major polluters are the ones who are also getting impacted by this, that is cement, steel and aluminium. They have lagged far behind in these efforts. So this is a typical carbon life cycle of a building, starting from raw material extraction to manufacture of building materials, to transportation to construction site, utilization of construction of the building, operational use of building, refurbishment and reuse, all these stages, demolition at the end of life, and recycling and disposal of the materials. Some of them can be reused. So at every stage there is a contribution to the pollution or the carbon dioxide equivalent emission. So we have to look at all those steps. So the three urgent pathways that people are looking at this point of time are shift and improve, that is, avoid the extraction and production of raw materials. We are going to talk about circular economy. The next speaker is going to elaborate on this. This requires the building with less materials through better data-driven design while reusing buildings and recycled materials wherever possible. So that's how we avoid the extraction and production of virgin raw materials. The shift is towards
the regenerative material practices wherever possible by using ethically produced low carbon earth and bio-based building materials. Some papers were presented on this field as well in this conference. So, sustainability of sourced bricks, timber, bamboo, agricultural, forest detritus, all of this whenever possible, they need to be exploited. And then the third one is improving. That is improving the methods to radically decarbonize the conventional materials like concrete, steel and aluminum. I am talking about concrete for a while on this. So, the use of non-renewable, carbon-intensive, extractive materials should be only when necessary. Otherwise, we should improvise, improve technology of the material to make sure that the impact is much lesser. Now, the awareness in the use of low carbon materials in construction, if we look at the scenario, the awareness seems to be increasing, but it is still very uneven. It is in some pockets and it's in an early or moderate stage. India being a big geography, huge lot of people, the awareness dissemination is not easy. So the demand for green building materials has been rising. It is expected to grow at about 10 to 12% annually, possibly reaching about 70 to 80 billion US dollars by 2030. This again is taken from the published data. So the conventional materials like cement and steel are still ruling the roost. They are still dominating because the supply chain for that is fairly well established. Other alternative materials are not available. The supply chain is yet to improve. And familiarity. People are familiar with concrete, steel, cement. So they have confidence in that material and hence the conventional materials, they are still having their time. Now, this awareness is to have been, or it should have been aided by regulation and standardization, which is woefully low or lacking in some places. And most of it is around the embodied carbon at this point of time. Operational energy is fairly well regulated, your ECBC and other things which are implemented fairly strictly in large projects. So the adoption remains concentrated in certain segments, as I said, in infrastructure, high-end real estate, green building certified projects, etc. But what's happening to the small and informal housing? The huge number of construction sites which are there in India, everywhere construction is happening. And more than 60% of the cement and concrete goes there, or maybe even more. So what are we doing for this sector? The awareness is less, the uptake is less, so there is a huge area which we have not touched. All these exotic materials that we talk of is not for the common, what we call as Indian or individual house building sector, IHB sector. Unless we touch that sector and make an impact, it's not going to be a happy scenario in future. So the slowdown in the adoption is due to, again, as I said, supply chain constraints, varying quality of alternative materials. We are talking of alternative materials, but where is the wherewithal to check that, experiment and see whether that is suitable and so on at the far corners of the country and for individual house building sector. But that's not happening. We are talking of AAC blocks, fly ash bricks, recycled aggregates, but where is recycled aggregate available to you if you want to use it? So the common man finds supply chain is a big constraint. So the need for skilled labor which understands this new method is also not there. It's quite a lot of habitual construction. People have been seeing maybe wrong things and learning the same thing. So where is the education or awareness building for the grassroots level construction worker? That's what I am just trying to look at. So what does this trend mean to us? Large and growing number of certified projects suggests that there is increase in awareness. IGBC will give you very comfortable figures, but this is only among the developers, corporates and institutions and probably government. So there is some increase, there is some possibility, but then this is not the volume is elsewhere. So the low carbon materials plus sustainable construction practices to become mainstream, we need to look at the lever, which is the uptake of the alternate materials in the sector which is of importance to us. So more projects will have to now move, scale up and move to beyond metros, tier 2, tier 3 cities. So that is something on which we need to concentrate and make all these technologies user friendly and also create facilities for evaluating these materials before use and teach the workers as to how to use these things. So there is a need for better data collection and transparency to evaluate embodied carbon savings, because we don't know how to evaluate, track adoption in residential and informal housing, and assess green building certifications or home certificates. Of course, many of these Griha and IGBC have now started looking into this area, and many of the cement companies and steel companies are enabling this, that even a house builder, a small house also can get some kind of a certificate that they have used at least the basic principles of green building concepts or decarbonizing efforts. So this is an opportunity, and what needs to happen is to turn the sustainable construction as a mainstream effort. So the requirements are stronger regulations around embodied carbon and building materials, wider dissemination of knowledge among contractors, architects and developers, especially those who are doing housing projects for lower and middle income. There is a feeling that green is costlier, not necessarily. There are ways and means to counter this particular argument. Strengthening supply chains is most important, which is to be taken up on war footing, so that you get quality, affordability and the scale that we are looking at, because our commitment towards decarbonization can be met only when we tackle this sector. Incentives, some incentives have started to organize sector, but it should come for, it should be available now for even a house builder. Reduced interest rates and subsidies when you use the low carbon materials in your house construction. A few slides on concrete, because I have said concrete construction, and also because concrete is the major or most used ubiquitous material that we have in construction sector. Estimated concrete production in India is about 2,000 million metric tons annually. Cement players contribute about 20% of the total concrete, because they are also manufacturing concrete in their ready-mix plants. % of the cement produced is used for concrete production in India. So this again, some data, how India is now looking at tremendously increasing utilization of concrete. So for those who are producing concrete, that is a good news. But the effects of this is again from a study by BCG, Boston Consulting Group, and CMA, says that from 2025 to 30, 30 to 47 or 50, and 50 to 2070, there are different scenarios which will bring in the utilization of concrete. So initially now in the area, 2025 to 30, we will be focusing more on infrastructure, housing, and industrial expansion, which is driving the concrete demand. Then in 2030 onwards, it's expected to be the acceleration of infrastructure build-out, driving Viksit Bharat ambitions, which Hegdeji talked about in the morning. And lastly, when we are reaching our goal or the time limit, the focus will be on revitalizing the existing assets and improving efficiency, durability, and circularity and carbon performance. So there are a lot of things that will happen in these periods. So we need to keep track of the increase in concrete demand and the areas in which it is going to happen, and take appropriate measures to counter the effect of this on carbon dioxide emission. So the consumption or the consumption pattern is something like this. Currently, about 30% is going to infrastructure, about 60% is going to housing sector, and about 16% is going to industrial sector, which will change by 2070 slightly. It will be now infrastructure 40-45%, 42% and 9% there. So the share of cement is, you can see the impact of that. When you are producing, using more cement, then you are asking for more trouble as far as carbon dioxide is concerned. So some more statistics, I am not going to go into all of this, but people have now estimated for India the cement capacity utilization, which is now only 60-65%, it will go up to 75%, and the cement share as well as cement in use in concrete. Cement in use in concrete is more or less the same, but the projected concrete production is also alarming at this particular stage. So cement industry being an organized industry, quite a lot of efforts are there to decarbonize the cement, which is considered to be the devil, by energy efficiency, by using alternative fuels, by clinker factor reduction, and by carbon management. All of these have been dealt with many speakers right from day one. So it's for you to see that there are these four major areas on which the cement industry is focusing, and it's been quite successful. Of course, the research on making cement and ways and means of optimizing the cement utilization is going to aid the corporates who are trying to do this. As Dr. Ramchandra was mentioning in his talk, they are now asking questions on a yearly basis. The government is now asking for, what have you done in this area? What is your target? What is your timeline? All of that is being now monitored, and hence there is a good hope that cement industry will further bring down. At one point of time, people used to say 1 ton of cement produced is 1 ton of carbon dioxide. That has come down drastically to an average of about 0.7 tons per ton of cement produced. But by going in for all of these alternatives, that is by reducing clinker, if you are producing only OPC, those figures are there. But suppose 50% of the cement you replace by slag, to that extent the carbon dioxide footprint also reduces. So these four are the primary areas on which cement industry and the knowledgeable people are working. So it's not just a technical challenge in the realm of researchers. It requires developers, designers, contractors, suppliers, professional associations, regulators and clients, all of them to act together. It's no point in having good research material, but you need the client's approval to use this alternate material, and to convince him, we need the designers and the professional associations to educate them, regulators to bring in certain restrictions on people using high carbon intensity materials, and the contractors and developers should understand that there is a commitment from their side, as well as there is a requirement for, or there is a commercial sense in using these materials. So making and using concrete, the last 2-3 slides. Use of appropriate construction chemicals judiciously is also very important. These facilities are available, but people don't know how to use this or why to use this, how not to use this, etc. Concrete made well, transported carefully, cast properly and cured sufficiently would last very long, making concrete the most sustainable material. Each word is important. Concrete made well, transported carefully, cast properly, cured sufficiently would make it last longer, and longevity is one of the tenets of sustainability, and hence the focus will have to be on making good concrete. The absence of large-scale mechanization is a bane in our country, but of late, since skilled labor is not available, a lot of people are shifting to mechanization to ease or to speed up the construction. So that is something which will help you to bring in some kind of standardization. So there is a need for extensive training of masons and construction workers, which I already mentioned. Many of the companies are also doing. Many organizations or associations like Instruct, ICI, they are also into this particular training of people who are hardcore construction workers. So every cubic meter of concrete that we pour is a climate decision. So the question is, it's not, that question was there earlier, so it is no longer can concrete be decarbonized, but the answer is, or the question should be now remodeled as how fast and how collaboratively we can make that concrete decarbonized. Thank you very much.
Professor, you have given an excellent talk, the need of decarbonization. Knowing all this, I stay in Delhi or in other urban areas, this air quality index, I mean, it is never going down less than 4, I mean, it is always going up 400. And then it results in the health is the biggest health hazard. We are all engineers and talking about durability, sustainability, and so what is the solution to that? As professor and as a consultant, you would recommend to the government?
Sir, it's not just air quality index, everything else is also getting worse. No, I fully agree. The first and foremost is the awareness and the responsibility that needs to come to everybody who is involved in construction. It's not only the engineer or architect, or not a researcher, or not probably a designer, but the grassroots people. That's what I'm focusing on. People should realize housekeeping is important. Wastage is something which people are, 20% of building materials are getting wasted in the country. Look at the several lakhs of crores of rupees which is being invested in construction, and 20% of that is a huge money. So the government also should bring in certain regulations, certain certifying systems, and make sure that people understand their responsibility. The only way to reduce construction waste or construction pollution is what I was talking about. One is from the material side, which should be available to him to replace the presently used materials with alternatives. We are talking of very exotic alternatives, but are they available in your village? They are not available. Right. So what's the point in talking? And 20%, 30% only is going to organized and infrastructure sector. Who is talking of the housing sector? That is what I was looking at. So it is a difficult proposition, sir. Only education, awareness is the key, according to me.
Thank you.
Yes,
Yeah.
Professor. You can give the question and answer.
Well, no. Because I really want to pick on you since you have the cement industry, or at least claim to represent them, right? So there's all this talk about cement industry being the villain in the piece. But why is it that we are not talking of at the concrete scale? There's no concrete without cement, but somehow this seems to be painted as a cement problem.
No. I'm not saying that cement company alone is responsible, concrete is responsible, but
Yes.
how do we make and use concrete was a slide only from that point of view.
Right. Now-
Because that is more important, because they are organized, they are definitely putting in their efforts.
Right.
But what are we trying to do for making the concrete more efficient?
Right.
Or concreting. Concrete is sometimes good, but concreting is bad. So we have to focus on the right methods. Again here, the organized companies, organized sector companies are doing a lot of education and awareness building as far as how a common man should use concrete. The most important thing like water cement ratio, people are not aware. And the mason standing on the shuttering decides what should be the water that should be added. After all this chemistry and whatever, at the ground level, that's what is happening. So training of masons, training of construction workers, awareness building among clients. The owner should see when the roofing is going on, the whole family comes and stands there because that's a chat banana bahut important hai. But what are they doing? They are just standing there. Everything else is happening in a very haphazard manner. They are just watching it. So instead of that, before they come, if they are made aware as to what to look out for. Many a times I have seen retired officials, retired people going to their site. Every day they take their tiffin box, go there, and the whole day they are there, but they don't know what to observe. So this education we have to give it to the clients or to the house builder. In fact, many cement companies, including Ultratech, have started this effort in a very big way to create awareness among the house owners or the clients or the customers as to what to demand for. So that is what I feel is necessary.
Just one quick question. When everything is said and done, we are not going to net zero unless we go to carbon capture, utilization and sequestration. Do you really think there is future in that? Do you think it's practical? At some point we'll have an engineered solution in that direction?
Frankly, no. Because the amount of carbon dioxide that we want to sequester is so huge, and the wherewithal we don't have so much. And we have now two ways, whether you make the concrete to absorb more carbon dioxide, but that again is how much more. And when the carbonation starts, there are other issues which will come in. So as was told in the morning also, there is a positive side and the negative side of that particular carbon dioxide. So if you use, like what Professor Gettu said, a material which asks for carbon dioxide, but that how much? You can't do structural things there, it's only some facades and things like that. So the carbon capture theoretically is fine, unless we sequester or you create huge tanks and store it there, not possible. I mean, I am not very hopeful of CCUS.
Sir, wonderful presentation, sir. Sir, you mentioned that adequate efforts have not been put in to reduce the carbon footprint. I fully agree with that. But still, with the growing population and industrialization, considerable efforts have been put so that the increase, though it is not reducing, increase is 0.3% or even less. Otherwise, it would have been 10% or 15% like that, I believe.
Yeah, I agree. I mean, what is China today is because of very rapid urbanization and huge amount of construction. But our future is, as I showed, there is a huge demand for concrete that's going to come in, which means we are going to become polluter number 1 or 2 or whatever, I don't know. So that we have to prevent. So before that happens, morning Hegde also talked of that, We should not get scared of the risks that are there, but we should take steps very quickly. This has to be a collaborative effort. Everyone has to pitch in. It's not that the government should do it, leave it to government to bring the rules, and then blame the government, saying that they have brought very strict rules, these are not implementable. No, there is that fight going on, some of you are aware, about ease of doing business. In the name of ease of doing business, they are removing chapters from National Building Code. Chapter 0, 1, 2 is being knocked off. I mean, there's a proposal. And a chapter on fire safety is being knocked off. So we all should immediately get up and say, no, this is required for, it was made for customer safety and also for the brighter future. So it has to be a collaborative effort. The associations have to fight. The clients have to be made aware that, look here, yes, not leaving much setback may be okay, but the rest of the things, competence of the engineer was defined in NBC. If you remove that chapter, people will do whatever they want. Then all quacks will start doing the work. We are reversing 30 years of effort of making National Building Code. So it's very important that you don't expect someone else to do the job. All of us should do it. Starting from customer, starting to demand. Now, Ramchandra would know, when this white topping was being talked of, people were very negative about it. That, okay, this concrete is very costly. It's not allowing water to percolate, as if percolation of water is good for pavement. No. But now, people have understood the advantage of white topping and concrete roads to the extent that the MLAs are promising that if you elect me, I'll get this road concretized. So this demand should come. So similarly, quality should come as a demand from the customer. So he's being taken for a ride, he doesn't know. He's spending huge money, all his life savings. But what's happening is, little improvement in water cement ratio would have brought his concrete from M20 to M30. He doesn't know that. That's the focus of all this. Joint responsibility is what I'm talking of. Thank you.
That was Dr. Manmohan Kalgal, clearly highlighting the decarbonizing of concrete is not an option but collective responsibility of designers, builders, material producers, policymakers, and academicians, and entire cross-section of the civic society. Thanks a lot. Now, the final speaker, plenary speaker of ACECON 2025, and I would like to introduce him before he takes over. He is Professor Abhijit Mukherjee from Curtin University, Australia, and he will be talking on circular economy of construction, the learning from nature. Professor Mukherjee is a professor of Curtin University, Australia. He was the Institute Dean of Research and Development at Indian Institute of Technology, Gandhinagar. Professor Mukherjee served as the director of Thapar Institute of Engineering and Technology from 2006 to 2012. Mr. Mukherjee is a civil engineer, researcher, and educator. His research is on sustainable engineering practices. He approaches sustainable practices from three directions: development of new sustainable materials, monitoring the health of existing infrastructure, and extending the life of infrastructure through rehabilitation and retrofitting. Professor Mukherjee was awarded the Environmental Sciences in Australia Leader Award in 2023. He is a fellow of Indian National Academy of Engineering, INAE, and National Academy of Sciences, India, NASI. I welcome you to the dais, and next 30 minutes is yours. Thank you.
Am I audible? Hello? Can you hear me? Oh, great. Thank you, Chair. Thank you. Thank you. Well, the Chair wished to have a dialogue on beyond concrete, a new concrete. So, you're going to have that, a lot of dream out there. So I'll be talking about the possible circular economy, not really circular economy. Let me start with something positive, and some sales speech. This is Perth for you, from where I come. I'm always looking for students, so those who are out there, I'm trying to attract you with all these pictures. It's a pocket-sized downtown, but you have some wonderful, wonderful, surprises that come up. This is what I cannot not show from Perth, because this is a stadium where India plays Australia, and most of the time wins, right? So that's a wonderful new stadium. You can see the bridge, built like two swans, because that's Western Australia's black swan. And finally, this is the most popular sport in Australia. It's not cricket, it's Aussie rules football. So if you tell them that there's a ball there, they jump like that and hit each other all the time. I like that sport very much, so I must confess that I'm one of those perpetrators. I'm so happy we talked about bridges bring development. Look at this picture. The first generation was crossing the stream. The next generation built a little, put a little plank, and the next generation is building that bridge. And that's the development for you over a few, 10 years, right? And each one actually adds to comfort and opportunities for people. So let us not keep saying, to us that we only create problems. We actually create a lot of opportunities for the people who really need to have those opportunities, because we connect the remotest parts of the world. So in the net zero world, what do we expect? This is actually the sustainable development goals. And if you look at poverty, how do you eradicate poverty? Infrastructure, building connections, right? Or zero hunger. How do all these things happen? Don't we need, schools, universities, and hospitals to have to achieve this? So we need to build. Let's have that very clearly known. There are other things happening, like in renewable energy. Right now, renewable energy in the world is greater than 30%. Australia is a little ahead. We have a lot of sun there, and people have money to put rooftop solar. India is not far behind, doing very well. This is a good and a bad news, I would say, for civil engineers. The good news is overall, emission is coming down, but the bad news is you will run out of fly ash. Because power plants are, in Australia we can't build anymore. We are just closing down all coal-based power plants. So at least in WA we have very little fly ash left. So we need alternatives, and we'll talk about it a bit. So what's happening? If we look at emissions from other sources, these are going down. That is, emissions from, say, automobiles. Every time I go to China, I see a few more percentage higher, EVs, the electric vehicles. Also, power generation is becoming really renewable. A few states of Australia have already announced that they will have 3 hours of free power every day at a particular time, because the generation is so much that you really don't need that much power. And my hope is once the AI bubble bursts, you have so much power, because you don't need that power anymore, power will be free. So there are always positive things to know when all these things happen. So in effect, what would happen, and now I come to the bad news, so emission from building as a percentage will keep going up, because others are going down, other emissions are going down faster than emission from buildings. So as a percentage, we'll go up, and therefore we have bigger responsibilities to look at what we should do to control emissions from construction. If we look at the projection, it's not very good, right? This big red patch, you don't have to guess it. It's China consuming cement. Okay, the purple patch here is India. So India will continue to consume more and more cement according to this projection at least until 2050. But when India would reduce, other developing countries, Africa will pick up. So cement production is going to be there for few more decades, no doubt about it. And when you are there, how do you go to net zero? The target is 2050, right? Now they're telling not 2050 but 2070. So that's the challenge that we have. How do we make concrete? Now I'll just stretch the imagination about concrete. What is concrete? So I keep saying that. Suppose I take a glass of water, and then I say that I'll chant a few mantras, and this glass of water will turn into rock. You would say, oh, well, that would be magic. So concrete is magic, right? It flows like water, and within an hour, it behaves like a rock, right? So this is a wonderful material, and it's not easy to come up with alternatives for that material. And I come across that challenge all the time in my research. Okay. This is something that once again stretches the idea of concrete, and I think this is important to understand that overall perspective of concrete, because then I think we would be closer to the solution. And here we are looking at, say volcanic eruptions. What is it? Flows like water and then solidifies like rock. So according to our liberalized definition of concrete, that's the first concrete which was there since 4.5 billion years. Okay, this is a little more unfamiliar. This is actually from Western Australia. These are living rocks. They're growing rocks. They're growing because of bacterial action. This is the calcium salt from the seawater, the ocean water, in fact, gets entrapped by the bacteria due to its photosynthesis and creates calcium carbonate. So the rocks are growing. Okay, and so that's concrete. It was there in the water, the calcium, and now it's there in solid. And that has been happening from, say, 2.7 billion years. So 3000 BCE, if we jump there, that is anthropogenic concrete. If we say this is natural concrete, if we look at pyramids, okay, they have activated powders, right, for solidification. Professor Davidovich, of course, claims that entire pyramid is made of geopolymer concrete. That's a claim. And more recently, and this, of course, this is from 200 MPa. You come between 10 and 200 MPa. So the biological system has this advantage. You can make it very porous, or you can constantly solidify it. And therefore, while volcanic concrete would have a strength of, say, about 200 megapascal, the bacterial concrete would have a strength between 10 and 200 megapascal. These ones are pretty solid. These are pretty old and very solid. And these are, of course, UHPC. We talked about UHPC. So from 200, we have come down, and finally we are reaching more or less that limit. So from rock to rock, right? That's where we are. So we have progressed quite a lot. So if we look at, say, cement industry, and this is a paradigm that I use to describe how nature works. So hang on to this. So you decompose calcium carbonate, and this we do in a kiln at this kind of temperature, And this generates most of the CO2, right? You break down calcium carbonate into calcium oxide and carbon dioxide, release the carbon dioxide. That's the biggest problem that we face in cement industry, right? And then you transport, and then you construct. So you had rock, which is pulverized and put in here, and then activated, transported, and you get the rock back at construction site. Okay, we call it the DTC paradigm: decomposition, transportation, and construction. I'll try to show you how nature does the same thing a few slides later. The kind of problems that we have, especially for alternative concrete, like I said, our fly ash production is going down. Blast furnace slag production is heavily concentrated. Australia doesn't produce any steel, so no blast furnace slag, no iron either. Metakaolin, just not enough quantity. So we look at mine tailings because we keep mining. Okay? The trouble is how to use mine tailings. So that's one alternative concrete that I'll talk about. So we have this double whammy, net zero mining and net zero construction, and can we just meet the two together? That's one of the ideas that we are working on. My group is working on. I'll tell you, this is the only slide about mining. I will not talk about mining later. So this is what you call in situ mining. Okay, this is sustainable mining. What you do is you inject a solvent into the ore body. This is suppose the ore body, and then you suck it up from here. So you really do not take the ore out. Okay, you don't open up. It's very difficult to open up in Australia, because if you have to open up, then you have to give back the mine site exactly in the same condition that you started. So you have to bring back the same kind of plants, same kinds of animals, everything back. So it's really difficult, and therefore this is ISR is now very, very seriously considered, and some have been already implemented, especially for uranium mining. So where do we stand here? Why is it important for us? You can see that you need to use very corrosive chemicals, right? These are solvents that would solve ore bodies, solve rocks, dissolve rocks. Okay, and I need to have a barrier around it. Otherwise, if the solvent leaks into the groundwater, there will be a disaster, right? So we were tasked with developing the barrier material. So the barrier material is from the same mining material. So mining materials have a lot of silica, a lot of calcium, right? So in a sense, you have the recipe for a concrete there. And how do you derive the concrete out of it? That's our challenge. So I'll not get into a lot of details. I'll just tell that this is alkali activated system where we are using the mine tailings. These are mine tailings, and these are blast furnace slags. We put them together to get this kind of samples. So this team was very happy when they built this. They never believed that mine tailings can be converted into such beautiful little cylinders that we tested. So that's my lab. So this is another important problem there, because what you are doing is you are excavating mining material out, and then you are pulverizing it, taking the metal out, and then you have that powder, right? And you're pumping that powder back after activating it into the ground for barrier. So it's very important to understand the pumpability. So these are the kind of samples that we prepared, and I'll show you some of the tests. So this is one of the most important ones, because I said that this material would actually see very highly concentrated acid, very highly concentrated alkali, and brine, because those are the solvents that are used in the mine. So we test them and then figure out how that would affect the strength. So you can see that the strength is about 80 to 90 MPa. This is, this is highly pulverized silica and calcium carbonate in this system. And also, if you look at this is after the treatment with CO2 and acids. So we could see that the leaching doesn't go beyond about 5 millimeters within the cylinder. So we are pretty happy to develop this barrier material. So this is one application of use of alternative concrete. So we are making concrete within the mine site itself using the mine material. The only imported material here are two. One is blast furnace slag, the other is the alkali. I'll just go in, I have 14 minutes, okay. Biologization of concrete, because that's something that I really love to do. Like I showed in the inaugural slide that bacteria can make concrete. Bacteria can make practically anything. These are little factories. To survive, they are capable of doing a lot of different things, including eating uranium. All that kind of stuff can be done. So this is kind of easy to do, to break down or to recombine calcium oxide and carbon dioxide. When I said easy, it doesn't mean we know everything about this, no. But we can study some of these natural systems. These are all from Western Australia. The corals, these are calcium carbonate, beautifully formed calcium carbonate, and these are actually houses of people, right? Marine animals live there. These are, once again, caves. It's called Augusta Cave, which is in Western Australia. It's calcium carbonate deposited, right? It is actually cement. Okay, this one we have already discussed. Pardon me. So this is called stromatolites. And finally, these are beach rocks. So this is something very interesting. We have studied this in great detail because these rocks are forming on the sea beach within 10 years, say. Okay, and these are invariably close to mine sites. So there's something, the chemistry of it was interesting, and we studied this about 10 years back. And what we see is a big interaction between the two polymeric chains. The living polymers are all carbon-based, so entire life, everything, every cell and DNA and everything is carbon-based. And the silicate and a silica-based system is what we see as concrete, right? And between the two, there is, in the periodic table, there is just one difference, right? Carbon is just above silicon, right? A lot of biologists think that we could have a silicon-based life. Maybe when we have AI and finally, electronic life, then it is silica-based. So here, I would bring back the same DTC paradigm. What is happening in that beach rock site? It's a site called Lucky Bay. So there are these mines, and in the mines, we could see the dissolution happening. The bacteria, when they stop, they start eating the rock. So they produce an acid, which is around their cell membrane, and that acid, gradually dissolves the rock. Okay, and then that dissolved rock flows through from mine site to the beach. In the beach, what happens is you have a lot of food in the form of seaweeds. So there is a different set of bacteria that recombine. So that I showed you the breakdown of calcium carbonate and then recombination. So this is what is happening. This we studied about 10 years back. And this was our starting point of thinking that we can have that entire DTC paradigm is DTC. So what is happening here, decomposition is happening, transportation happening, cementation is happening, right? So naturally, you have all the ingredients of cement making, transportation, and concrete making. This is why it is happening. Here, what we are showing is how cement is formed by the bacteria. If you look at here carefully, you will see bacterial cells. So this is a grain of sand. And on that grain of sand, there are these dimples, little crevices. And the bacteria go and settle there because they can secure that area. And from there, calcium carbonate crystals develop, like this one, like this one. So you can see a lot of different calcium carbonates getting, growing from those bacteria. And then these are mesocrystals. So crystals form over crystals, form over crystals, and that's how these bridges form. So here there was one sand particle that has fallen off, right? So you have what you call this is the bridging, the bacterial bridging. So that is bacterial cementation. So it is something like the way you hold, say, a bowling ball with your fingers. So the bacteria grow and hold it like this, and that's how two grains get connected, and therefore you have cementation. We use that quite effectively in healing concrete. So just imagine the bacteria settling on the crack surface, and they would form these crystals, and because these crystals are formed, you finally get sealing of the crack. This is another application. This is actually from Brahmaputra River. Here you can see that there is not only those crystals, but you have this polymeric material. Okay, you can see this polymeric band. So this is a different kind of bridging. It's a band bridging. So the crystal bridging is stiff but brittle, while band bridging is more flexible, but it can stretch a lot. So the combination is a composite that works very well. So you can actually tailor the product according to what you need, what kind of properties you need. We have used it for erosion control of Brahmaputra River, and IIT Guwahati is working in that area with us. This is crack filling. I'll not go into the detail. I don't have a whole lot of time, so I'll just go to a quick video. Can you just play the video, please? I didn't know the computer, Yeah. Okay, when they're playing, I'll just describe this. So what's happening here is there are two fluids. One is called the bacterial fluid, and the other is called the healing fluid. Yeah. So this is the fluid diffusing into the crack, okay, when the bacterial fluid is there. And if you look at it carefully here, slowly bacterial growth would develop. Can you see here the bacteria getting deposited on the surface of the crack, like I showed in that schematic. And here you will see that calcium carbonate is getting deposited, and slowly the whole crack would get filled up with calcium carbonate. A good thing about it, this was something that we didn't imagine, but it happened. Have you seen that it is not only densifying the crack, it is densifying the concrete around the crack. And that's what makes us very happy. That means it is not a flimsy repair. It's much better than that. The advantage of this is that the material is like water, so it can really penetrate inside very fine cracks. Most of the crack filling materials cannot penetrate much. This one just penetrates inside the crack. I'll go to the next. Yeah. So here we are using, this is once again a few years old result. So this is how the crack gets completely filled. Okay. And here it is showing that when we are filling the crack, we are also trying to find out whether the crack is really getting filled. So we send ultrasonic waves through it. I in fact have two labs there. One is bioactive materials lab that does all the bacterial work, and the structural assessment lab that does all the assessment work. And so we can actually monitor and find out whether the crack is really getting repaired. Also, you can see the condition of steel bars inside. So whether the whole idea of crack filling is to protect the steel, right? So whether the steel is getting protected or not. So here is the entire history. So this was the crack. This was actually a real crack being tracked. Okay. So I think somebody talked about DIC earlier. This is basically DIC, but in a really fine scale. You can see how the area first gets densified. This is really porous concrete, and then the crack is getting repaired. Okay, and you can see that this is very, very slowly controlled system so that we can measure everything. So we went through about 12 cycles, and in 12 cycles the whole crack got totally repaired. So based on that, we have this repair product. This is both sensing and actuation inside the concrete. So it repairs, and it also tells whether the repair has happened or not. Based on that, we have two products. These are licensed to other industries. I have no stake in that industry, so this is not my company. We have given the license to another company. So they have this repair product and also a sealing product. That's a spray product. It has been used in swimming pools quite a lot because people are very fussy about what they are putting in their swimming pools. So we use biocement. Whenever you require something that needs to be biologically benign, biocement is a very good idea. I'll not describe this. Okay. This is one of the projects that we are doing right now. This is at the implementation stage. It is with a mining company called BHP. They are the largest iron miners in Australia, and they have this problem. Some of the neighboring suburbs reported that they have this deposition of red dust. If you look at the dust level, it is 2.5 micron at 50 ppm. So it's really very controlled because Australians are very, very fussy about their air quality. So here we are testing that material with biocement. Why biocement? Because they cannot put cement on that ground. So what we had to do is we had to collect the sample, the dust sample from there, and then we analyzed it chemically and biologically. And then after treatment of our biocement, we had to show them that there is no substantive change either in the chemical or the biological composition of the soil. And therefore we used biocement here. We test in the wind tunnel all the time. These are some of the samples. So I'll quickly show you some of the results. So this is a mass loss due to wind blowing at 50 kilometers per hour, 75 kilometers per hour, and 90 kilometers per hour. So this is without, it's just water, using water on the soil. You get this profile, and you can't see here because these are very small numbers after treatment, after biotreatment. So even at 90 kilometers per hour, the soil holds very well. What happens basically is, like I said, this is the cementing that's happening, and because the sand grains get cemented, their takeoff velocity goes up because now the grain is effectively larger, and they also interlock better. And therefore, it really, we are very happy to see these results. Actually, we didn't expect such great improvement, but we are very happy to see these results. These are finally the ppm results. So how much we keep measuring ppm. This is highly inflated because we are measuring right from the mouth of the wind tunnel. And once again, we see a huge drop in the ppm at different wind speeds. And I will take the last 1 minute to describe this because this is something we are working on right now, and Professor Shah is also involved in this work, and I need to know what he feels about it. So the idea here is, can I make limestone from, cement from limestone itself, right? So here we have, we have limestone powder here, and we are treating it with ethanol and a bacterium. Now, this bacteria, it's basically the process that makes vinegar, okay? So it acidifies ethanol, And when that acid is, poured on limestone, it starts dissolving. Okay? So what happens is now the calcium ions come out. Okay? And because it has come out, we have basically this reaction, the top reaction. If we look at this graph, you can see that these green triangles are calcium. So initially it was 0, it keeps going up. I'll not describe other graphs. So we have basically recovered all the calcium out of calcium carbonate. But this side is what we did not really look for, and we were once again very pleasantly surprised with this. So on this side, what is happening is that when ethanol is completely consumed, you still have carbon here, right? So bacteria have started using this carbon. And because they have started using this carbon, they are breaking down the calcium acetate and producing calcium carbonate once again, because in the process carbon dioxide is getting generated. So we call it biosintering because this is sintering working at atmospheric temperature, not at a high temperature, because calcium is getting dissolved, it is being ionized and then resolidified, remineralized. Just imagine this happening in cement. Suppose I have demolished a building and I put that C&D waste and treat it, so it will recover the calcium out of the cement and silicon out of the cement, silica out of the cement separately, okay? And you can recombine them back to form new cement. So you are making cement, you are actually recycling cement, okay? I'm not saying that I have done this, I've not yet done this. I've done the calcium carbonate one, the limestone one. And this is our next project that we are trying to propose for funding with Professor Shah. This is how the calcium carbonate crystals looked initially. This is, you can see what bacteria are doing. They just it is like knife, because they keep going deeper and deeper into the crystal. And this is back. Can you see the porosity? Because this is fresh crystal. Like I showed you, calcium carbonate can have compressive strength from 10 MPa to 200 MPa. So as these pores get filled up more and more, the strength keeps going up. So you can actually tailor the strength. Okay, that's another big advantage. Wait, let's forget it. This is too much. So I'll finish with this. This idea that there is a lot to reimagine in concrete, and let's do that collectively. Thank you very much. Thank you. Sure. Mike. Either.
Excellent presentation, Professor. See, here you have been in India. Now you are in Australia. The climate here is changing from place to place. Calcutta is different, Jodhpur is different, Delhi composite climate. And your process of whatever you have told, I mean, how far you will feel that we can do in this country?
Okay.
Make the concrete durable and then use the
Actually, India is better. India is better in many ways because India had hot and humid climate. It is actually culture temperature for bacteria. Bacteria grow very well between say 30 and 40 C and 100% humidity. That's ideal condition for bacterial growth. So as such, I'm not very concerned. This work we did in India for a long time before I moved to Australia. Not a long time, but we started this work in India. Okay, initial work. What I'm showing now in this is all last 5 years old. So I don't really think that it's a problem because globally the bacterial dissolution and reprecipitation happens all the time. Wherever you see, say, limestone or sandstone, it has happened. Right.
Right.
Did I answer your question? I'm not sure.
Yes, thank you.
There, back.
Hello, Professor. Very nice presentation.
Thank you.
Introduce yourself. Introduce yourself.
This is Ramakrishna from IIT Madras, who
Hi,
has
Rama.
recently completed PhD. I am a bit curious about the cracking part. So when we have the cracks in concrete, we lose the stiffness of the material. So I am interested in knowing whether this bacterial healing of cracks help us regain the stiffness of the materials, or it just fills the cracks.
I couldn't get a partial filling of crack?
No, bacterial healing of the cracks will help us regain the stiffness of the materials, or it just fills the cracks.
Okay. We don't, thank you. It's a very important question. We don't really look at the increase in stiffness. We rather look at whether the path of deleterious material, like say, chloride or sulfate, is prevented. Because that's more important. When concrete is cracked, then what happens is say if chloride goes in, that would corrode the reinforcement, and that would create the whole cycle of spalling and all that. So it's not really, we don't think it's very important to find out increased stiffness, because the stiffness loss is minimal, right? It's more important to densify the material so that the path of deleterious material is prevented. Yeah? Sorry?
Elastic range, he said.
In concrete, the cracks are in tension, right? Imagine a reinforced concrete beam. So when it is bending, the cracks would be in the tension zone, right? So in that zone, when the crack is happening, if the crack remains open, then chloride can go in or moisture can go in. But if it is sealed, then the path is prevented, right? That's why, if you have noticed, we also tested the corrosion rate in the bar at the time of healing. That's the important parameter. Sorry, you had a question, sir.
Actually, the cracks may be in the elastic range. So once cracks are healed, it is like regaining again. So it can go the extent that.
Oh yeah. So even if we wanted to measure stiffness of a cracked beam, I don't think it would have reduced much.
Yes.
Yeah. Because tension cracks appear at a very low stress level, right?
Yeah, last question.
Hello, sir. Sir, my question is this: does species and genus of a bacteria play the important role its performance, concrete performance? And if it's play the role, how I can identify that this species or genus should be in our concrete, so that we'll get the better performance or target?
This is a huge topic, and I took all the credit, but it's not my, I have quite a few microbiologists in my group, and you are absolutely right. There are horses for the courses. So a particular strain would be particularly efficient for the purpose. We very frequently isolate it from the site. Like the BHP work that I showed you, the microbe that we are using are already there in that site, so that nobody can say that we are putting the new material, foreign material there. So we keep doing that, and then we figure out which ones of them, because you will have thousands of them, right? Which ones are really good for our purpose, and then use them. Yeah. Very important question. Great question. Thank you.
Thank you.
Okay. Thank you.
Dr. Abhijit, thanks a lot. In fact, he has given us not only just knowledge, but the direction towards lower emissions, resource efficiency, and sustainable thinking. And I was very happy to chair the session. I thank our scientific committee chair, Dr. K.V.L. Subramaniam from IIT Hyderabad, for giving this opportunity for chairing the session, because of Dr. Saraswati, who couldn't come to chair because of our indigo problem. But anyway, thanks a lot, and over to Dr. Girish.
Thank you, Dr. Anchuri Garu, for chairing this session and for that very interesting talks by both the plenary speakers. Now may I request Dr. Shishil Bansalji, Dr. Vishalakshi Garu and Dr. Raju. Sir, can you kindly get Dr. Raju? I think he just walked out. Dr. Raju, your EC member, please. Vishalakshmi ma'am, kindly come over to the dais to do the honors on behalf of ICI Hyderabad. Dr. Shishil Bansal, sir. May I request Dr. S.P. Anchuri Garu to please come over and receive the honors on behalf of ICI Hyderabad as well as ACECON. No, no. It's perfectly balanced. Okay. Now may I request Dr. Manmohan Kalgal sir to please come over and accept our honors. In fact, I wanted to invite Dr. KVL on every session. So I got tired because he said, no, please go ahead. So sorry that I did not insist again. Please come. Thank you. May I request Professor Abhijit Mukherjee, sir, to please come out to the stage as well. Thank you, sir. Sir, I request to be on the stage for the photo op, please. Yeah, I think you just spread out in one line. Yes, excellent. Thank you. Ladies and gentlemen, you can now applaud all the speakers and the session chair and the volunteers. Thank you so much. Thank you, sir. Thank you so much. Now we have a corporate presentation by one MYK Armand Private Limited. Do we have the representative of MYK Armand, please? Do we have the representative of MYK Armand, please? Yeah, please. It's a PPT or a video? Okay, this is forward, this is there, and this is a laser.
Okay, this is forward,
This is forward, this is back.
Okay,
This is laser.
Okay. Good afternoon, good evening, namaste and salam. Aap tak to you have seen all very, very dry presentations. In fact, my presentation will be very interactive, and I will show you certain technologies which you have already covered in the sessions which dignitaries to quality, but the kind of remedies we carry, that makes a difference when you have an issue actually. I think this is not moving actually. The slides are not moving, eh? Not working. It's not going down actually. Yeah. So I basically represent MIK Armament as a national head, based out of Hyderabad. So we are a corporate conglomerate pan-India and exports also. We do more than 1,000 plus products. So there is a brief video which shows what exactly we do today actually. So we can see that we are almost in the rapid development wherever we go around. There are high-rise buildings, there are dams, there are bridges, there are a lot of concrete structures all around us, Not only concrete, there could be sometimes composite structures also. So we do keep specialization of manufacturing products, which goes well in these kind of issues, remedies, or any kind of new product development, tailor-making products. So MIK keeps specialization in 8 to 9 segments. And we are a well-specialized company, which goes from substructure waterproofing, right from the deep basements or small basements, car parks, car park coatings, and anything below grade concrete, and roof gardens, podiums, and even wet areas and wash areas within the structure. Then specialized products on the roof gardens when we are putting them on the specialized ways, wherever we have MLCP car parks, sometimes we have gardens, sometimes we have clubs, sometimes we have gymnasiums, So it requires a lot of complexity in terms of choosing the right product actually. So the company keeps the specialization for developing and make you aware on the all subjects, As I was saying, this is the beautification of the car parks, which we have started a couple of years back in India. It was not well accepted in advance, but with the period of time, the advantages that car park systems carry, it is a boon to the industry actually. So, well, you have seen the video stating itself what exactly we do. Well, now we go exactly to the subject today. All the seniors have already covered majority of the issues, but being a manufacturer, what I can support to the cause actually, that comes as an answer here. So when I talk about an issue, that why basically reason for the distress in concrete actually. So these are the reasons actually, varied reasons where you can see it could be weathering, poor construction practices, use of defective materials, corrosion, seepages, or many other issues actually which are very, very common. So if we are visualizing an issue in a building, this could be one of the causes which we have to derive to in the end actually. So what are the approaches if we talk about? These are the normal tests that we should carry out, or we should guide our team before they reach to a remedy or develop a method statement before they do any kind of repairs. So it is rebound hammer test, ultrasonic pulse velocity. I will not go in detail, just to take the names. Half cell potential, concrete cores, carbonation test, and chloride ion test, which are very commonly used in India to understand the integrity of the structure, what is the extent of the crack, what is the issues in the crack, what are the porosity, what are the other issues, what is the chemical ingression of the concrete. So we should always do in combination of tests, not one test is enough to derive you the results actually. So in my term, there are 3 ways we approach to concrete repair. Is cosmetic repair, general repair, and structural strengthening actually. When we talk about cosmetic repair, more or less it is related to rendering, patch mortars, putties, epoxy putties, polymer-based putties, which goes from 0 to 3 mm, When we come to a subject called general repair, it could be a combination of column, beam, or a slab repair in together, So it could be sometime micro concrete, it could be combination of micro concrete, steel, cement,
and other fiber reinforced products required together. Then comes the third is structural strengthening, which is the interesting part. Today, this building is a banquet hall. Tomorrow, it might be a laboratory. So my load calculation per square meter keep changing actually. If it is 650 today, tomorrow I need around 2,200 Newton per mm square. So what should be the ways we can strengthen the building, not increasing the load density? So this is again one of the ways. So I already covered this. Then these are the products that which we offer to the market for the. These are the products which we goes basically in the rebar treatments. It goes from one component or to two component products. Then comes surface treatments, which goes especially in machineries and bricks. All kind of bonding agents, starting from styrene, butyrene, rubber, or acrylic, or epoxy based. Then polymer modified cementitious mortar bags, which are pre-baggaged bags. I'm not talking about hardcore concrete here. It is a basically pre-baggaged micro concrete and polymer modified materials, which are ready to use at site. You don't require curing, only you need to add 4 to 5 liters of water and mix it and apply it at the site. Then comes free flow micro concretes. It starts from 40 Newton till 100 Newton, different capacity. It can be enhanced as per the tailor making also at the site. Then all epoxy PU mortars, underwater mortars also, which are very high exothermic reactive products, which set within 30 to 45 minutes. Epoxy adhesives, structural strengthening, all kind of wraps, saturants, epoxy primers, and all kind of protective coatings, which could be from coal-tar-based epoxies, it could be anti-carbonation coatings, I will show you some pictures and this thing, it will be more interactive rather than be more descriptive. So this is, I told you already, these are the applications, and these are the applications which one can be do in the underwater. So application can be static crack repair, it could be honeycomb, it could be concrete spalling, jacketing, laminates, and protective and chemical coatings. These are not necessary to be seen in the old structures. Majority of the structures today, they are not integral when in terms of construction in beginning only. Some floors, you will have a diversity of the values of compressive strength. One column will be 20 Newton, another column will be 15 Newton, another column could be 7 Newton also. So there are a lot of cases we have seen that they require early structural strengthening, even the building is under construction only. So today, we are not having issue in the old structures. Old structures, in any case, we have to do rehabilitation, but the issue comes from the new structures actually. So these are basically specialized materials when we have a static crack repair. So we have a low viscous injection quality material, epoxy-based product, which have a viscosity of 1, which can flow itself with the help of the gravity. You don't require a specialized packer or this thing. Any kind of crack fillers, we again have specialized materials which are epoxy-based. And suppose we have any kind of crack which is below the ground and there is water. So we have a high exothermic grout which reacts very well when it comes in contact to the water actually. Then comes any kind of situation which is again a new construction. So we will have products called specialized products which goes well for the honeycombs. It matches the quality of the concrete as well as your strength criteria. Same kind of thing where you have loss of section on the corners. More or less, contractors neglect this, and ultimately the integrity of the structure is at the stake actually. So this is again a case where we have spalling of concrete, and we have a product range from rust removers to again recoating of zinc, basically on rebars, then again rinsed in epoxy bonding agents and polymer modified mortars, So these are very common building issues actually, which you see more or less actually. Then comes jacketing. Jacketing again is a strengthening criteria where we want to enhance the strength of the column or the slab or the beam sometime. But what it brings basically is sometime extra dead load actually. So the load calculations again have to be seen very easily before we are planning anything. So these are some structural RM series motors which goes along with most of the concrete and the parameters that we have for like the RMCs here. So it exceeds that parameters. It is the advantage here you have, it is a pre-baggage material. You don't need to mix anything extra, only water. And straight away you can apply the material. So this is again, that's it. And these are some glass fibers. Again, we are fixing one of the glass fibers for one of the bridge actually. These are anti-carbonation coatings, very well known in international market. Still it is coming in India. Very less people are aware. Specialized coal tar-based epoxy coatings, acid coatings, which is called Novolec coating sometime, where you have high density of acids in the water, sludge sewage treatment. Then underwater sacrificial anodes, which is a very new subject, not very well known in India, but still we as a company are working in many underwater structures, where zinc sacrifices and takes the cover on the steel actually back. So I will not go in deep detail. These are the areas where we normally the grouts. These are the application areas. These are some live pictures, one of the steel plants. So this is a range of grouts we have. It is a big range of grouts. Apart from cementitious to epoxy to the polyurethane, all kind of grouts are there. This is one of the job we have done in Jamshedpur. It was a full scale work for a STP plant, again for cooling plants. This is a underwater jetty repair. We are working in Odisha now. These are some carbon wraps, combination works. Railway bridge MP we already finished. It is a full structural strengthening as well as micro concrete and reinstained mortar methodology. This is one video where we have worked in. It is for me, I think. Just only 30 seconds more, nothing more than that. So there we have done a structural strengthening of the structure, which was existing building, was commercial building, and it was moved to a laboratory where they wanted a load density to be increased from 640 Newton to 1000, 2000 something. So these are some bridges we have done. Pan India, almost 80 bridges we have done anti-carbonation. So these are some blast furnaces. These are existing plants. These are ongoing projects we have. This is all CPWD, PWD, NHAI, MORTH-based projects. So thank you very much. It was short and sweet. I could not get much time, but thank you for the patience. Yeah. Thank you.
Request you to be here. Excuse me, sir. Please. Thanks to MYK Armament for supporting us. Mr. Arvind Kaju for supporting us, and may I request now the Honorary Secretary of ICI Hyderabad Center, Dr. Niharika, Dr. Raju, and Mr. Maulu Rao to please come over and convey our token of gratitude and thanks. Gangaram Raju Garu, please come join them, sir, because you're part of EC. So there is one opportunity to convey our gratitude to the sponsors. Ladies and gentlemen, please give a big hand to our sponsors, MYK Armament, please. Thank you, Andy. Do we have anyone from Red Warp Chemicals Private Limited? Yeah, please come over. Please come over, sir, quickly. This is a brief presentation by Red Warp Chemicals Private Limited, one of our sponsors for ACECON 2025.
This is forward, this is backward, and this is video just. Okay.
Hello. Good afternoon. Myself Deepak Atkare, ASM Projects for Vidarbha region in Maharashtra in Red Oak Chemicals Company. Red Oak Company founded by Mr. Manish Nagrani in 2010 in Rajkot, Gujarat. We are a manufacturer and exporter of construction chemicals and paints, industrial paints. We have a huge product range of construction chemicals, industrial paints, cleaners, specialty chemicals. We are certified of ISO 9001 and ISI. We have 1000 plus wholesalers 22,000 plus retailers, clients, including major infrastructure entities. Our corporate value is quality, innovations, integrity, transparency, and customer satisfaction. Thanking you. Maybe.
From the ancient wonders of the world to the modern marvels of engineering, construction has always been the foundation of human progress. It shapes skylines, connects cities, and builds the future we live in. Every brick laid, every beam placed, and every structure standing tall, all are testaments to human ambition, innovation, and the materials that make it all possible. Established with a vision to revolutionize the construction chemical industry, Redwap Chemicals is a trusted partner in building durable, reliable, and future-ready structures. Driven by innovation and backed by science, we deliver high-performance construction solutions that meet global standards and withstand the test of time. At Redwap, we provide an extensive portfolio of over 250 products, offering a complete range of construction chemical solutions for every phase of building from foundation to finishing touches, which includes admixtures, waterproofing solutions, tile adhesives, tile and industrial grouts, repair and rehabilitation products, wall putty and paints, sealants and joint fillers, flooring solutions, protective coatings, and many more. From massive infrastructure developments to iconic residential and commercial projects, our presence is deeply rooted in the heart of India's construction story. With a strong supply chain, reliable service, and committed partners, Redwap is built on relationships as strong as the structures we support. At Redwap, quality isn't just a promise, it's a process. A discipline we follow at every step, from raw material selection to final delivery. Our state-of-the-art quality control lab ensures every product meets the highest standards of performance, safety, and durability. Over the years, Redwap Chemicals has earned something more valuable than profits: trust. The trust of thousands of customers, partners, and professionals who rely on our quality, consistency, and commitment every single day. This unwavering trust has also been recognized by the industry. Redwap is proud to be honored with the prestigious Movement Award, a testament to our excellence and growing impact. And making history, Redwap Chemicals is the first company in India to receive the BIS license for IS 14948 for our coal tar epoxy coating product. Redwap Chemicals isn't just transforming the construction sector. We are expanding our expertise into new dimensions. Driven by technology, inspired by sustainability, and powered by passion, we are shaping the future, one solution at a time. Redwap Chemicals, innovating for a better world.
Thank you very much.
Please more to us.
Yeah, thank you.
Also good name?
Deepak. Okay. Deepak Katkar.
Thanks, Deepak ji, for supporting us through Redwap Chemicals. Kindly move on to the stage. May I request Professor Niraka ma'am, Maulu Rao Garu, and Kanta Rao Garu to please come over to the stage to do the honors on behalf of the Indian Concrete Institute, Hyderabad Center, as well as Indian Concrete Institute headquarters. Redwap. Thanks to Redwap and our audience for applauding Redwap for their support. Thank you so very much. Do you have anyone from the Dhirendra group of companies, please? Do you have the representative of Vishwa Samudra Engineering Private Limited? Okay. We will break for tea, and after tea, we have yet another very interesting session before the mega plenary session, which will be back in this hall. The next interesting session where the speakers will present. It will be chaired by Dr. R. Durga Prasad Garu, and the speakers or presenters are Mr. Mude, Mr. Dabi, Mr. Vilas Shankar, Mr. Kumar, Mr. Kannan Rajkumar, Mr. Malikarjun Rao, Mr. Samantullah, and Mr. Balagam Vidya, Ms. Balagam Vidya. So I request all these presenters to please give your PPT presentation onto the AV desk so that we can prepare the deck and be ready as and when you present. Thank you so very much. We'll break for tea and we'll reassemble back in the next 10 minutes at the same hall, please. Thank you. May I request the presenters at Synergy Hall to kindly go to the Synergy Hall, which is in the E floor. I request Dr. Sri Kalyana Rama Joysulu, Mr. Mohiddin, Mr. Yogender, Mr. Aslam M, Mr. Chaitanya, Ms. Florence, Mr. Haveri, and Mr. Varun. I request all of you to please proceed to the E floor, Synergy Hall, so that you can begin your session there. Thank you. Do we have Dr. Jagannath Rao Garu? Professor Dr. Niharika Madam, do you have Dr. Jagannath Rao here? Okay. I'll just stand up. I request Dr. Jagannath Rao to please take over the sessions henceforth, and I thank you all once again for a wonderful audience, and the show will continue on till the valedictory today. Thank you.
Thank you very much, Mr. Girish, for your wonderful support.
Thank you. You can announce Bureau of Indian Standards. We would like to do the honors.
I now request Representatives from Bureau of Indian Standards to come on to the dais, please. Yeah, Dr. Anchuri also please come on to the dais to felicitate BA's representatives. I now request Girish ji to be on the stage. We want to felicitate you because your services are great. You are part of the team, yes. Yes, I now request representatives from First Rock Chemicals. Yes, please come on to the dais. Yes, delegates from First Rock Chemicals, please come on to the stage. Girish ji, you also. I request Dr. Anchuri and Mr. Girish to felicitate the representatives from First Rock. టీ బ్రేక్ కదా స్టార్ట్ చేద్దాం వెళ్ళి తీసుకుని వద్దాం A very good afternoon to all of you, and I welcome you all to the last technical session of ACECON 2025. The session chair for this is Dr. R. Durga Prasad. Before handing over the mic to him, I'll just introduce the session chair. Dr. R. Durga Prasad is an associate professor of civil engineering at CBIT, specializing in structural engineering, materials in marine environments, concrete technology, and repair and rehabilitation. He holds a PhD in ocean engineering from IIT Madras, an ME in offshore structures, and a BE in civil engineering. With academic experience at BNR, VJIT, and CBIT, he has contributed significantly to teaching, research, and departmental administration, handling key NBA accreditation, and infrastructural responsibilities. His research focuses on sustainable and innovative concrete materials, including fly ash, e-waste, and graphene oxide, with publications in reputed international journals. He has guided several UG and PG projects in structural and materials engineering. I now request Dr. R. Durga Prasad to take over the session.
Thank you very much, sir, for the brief introduction. And now it's my pleasure to chair this session. And in this particular session, we have 8 papers which are to be presented. So I request everybody to limit yourself to a timing of 8 minutes, followed by 2 minutes of question and answer session. So the first paper is Mixed Design Optimization of 3D Printable Concrete under High Altitude Low Oxygen Conditions by Mr. H. Mude Singh, Gandhi, and KVL Subramanian, sir.
Thank you, sir. Thank you for the introduction. Yeah, good afternoon all. So myself, Dr. Hanuman Naik, I am working as a R&D head at Simpliforge 3D Creation Private Limited. So today I'll be talking a live case study of a mixed design optimization for 3D concrete printing under halo conditions. This project especially we have executed at Ladakh in Leh, which is almost 11,000 feet height from mean sea level. So in this presentation, I'll be talking what are the challenges we have faced while designing the mix, and apart from the mix, what are the challenges we have faced at Ladakh, then how did we overcome all those challenges, and how we successfully executed the printing. And also during this presentation, I'll also show a live video where we have printed at Ladakh. So I think I have already introduced our core team. As a managing team, we have our MD sir, Hari Krishna sir, and Dhruv Gandhi as a CEO. And then I am the material specialist. I'm taking care of the design of materials. And then we have robotic expert, Mr. Wasim, who is sitting in the audience. And as a structural designer expert, we have Dr. Rangarao sir, who is having more than 20 years of experience in the industry. And also as in field operations, Mr. Faizan Chowdhury is taking care of the field operations. And I support him in terms of quality control. And as an institute partner, we are collaborating with Professor KVL Subramaniam as a technical advisor. He does all the technical advising to us. So now, what is 3D concrete printing? We all have been listening from past 2 days. So I'll just briefly touch it. It's a layer by layer structure. So with 3D concrete printing, we can eliminate the traditional formwork, as well as it enables the fast construction, and complex geometries also can be easily constructed. With this technology, we can build houses, bridges, defense structures, and architectural elements. Now, we all know that how important the 3D concrete motor is. As a company, we have developed our own motor, and we named it as a Simplicrete. And this material is entirely developed using indigenous materials. And the main IP of the Simpliforge itself is we use locally available raw materials at site. So we don't carry any material to the site and execute the project. So whatever the sand, whatever the cement, whatever the other additives available at site, we will use and execute it. And also the compressive strength of the mix, we'll make sure that it comes 40 to 60 MPa. And the mixing time also, as we will restrict it to 5 minutes, we'll design in such a way we mix only for 5 minutes. Now with this introduction to the materials, I'd like to highlight what are the challenges we face at Halo. When I say halo, it is high altitude, low oxygen environmental conditions. So these are the few comparisons when compared to Hyderabad to Leh, which is almost around 11,000 feet height from the mean sea level of Hyderabad. So there, the low atmospheric pressure or low temperatures at Ladakh, low atmospheric pressure can accelerate the evaporation and reduces the pore saturation. And also at halo conditions, we'll have a very low relative humidity. Because of that, the surface will dry so quickly, and we'll see a lot of early edge shrinkage which happens at Ladakh or halo conditions. And also the low temperature, we all know that the decrease in temperature will affect the hydration of the cement, and it slows down the hydration. The moment the hydration is slowed down, I am limited to certain number of layers per day. I cannot go for more layers. And also wind exposure. So we all know the wind at Ladakh are so huge, and because of the wind also we'll see a lot of evaporation from the fresh concrete itself. If we don't arrest it, there are n number of issues which we'll face. So, and also all these parameters will also influences the rheology properties of the material. So if I want to print at halo conditions, I should really reconsider on my mix design itself and rework on the mix. So this is my main objective of the study, is to evaluate how halo condition influences the rheology and the printability of 3D concrete printing. And I have taken two conditions, Hyderabad and Leh, which is Leh is almost 11,000 feet height, and which I have considered it as a halo, and Hyderabad as a lowland condition. And in this case, majorly we have worked on identifying the optimal admixture doses for printable workability at high altitudes. And also we have proposed curing strategies to mitigate the shrinkage at halo conditions. And we have followed these curing conditions to mitigate the shrinkage. And these are the raw materials which we use. At Hyderabad, we used the robo sand, which is locally available again. And we used OPC 53 grade cement, which is locally available in Hyderabad market. When we went to the Ladakh, we found a natural sand. Wherever we go, we see a lot of sand there. So we used that sand, and OPC 43 grade cement was available there. We used that. And of course, the common material for both Ladakh and Hyderabad are PCE and VMA, and 6mm PPE fibers we used. And the printer properties are, we used robotic arm printing with a nozzle diameter of 20 mm and a layer height of 15 mm. Now coming to the workability conditions, so from these plots we can clearly see that the blue line is for Hyderabad and the orange line is Leh. At a given admixture dosage, the Leh or halo condition has lower workability. So which means at halo conditions, my superplasticizer dosage for the mix to make it workable will increase by 18 to 32%. That we can see from these results. And also, now I would like to talk once the mix is optimized. So in the previous slide, we can see that the mix for Leh condition, we optimized it as 0.5% as the admixture dosage for the material to be printable. Now after optimizing the mix design, the main challenge comes now. What happens to the other parameters? So now I am able to extrude the material. Then comes the early age properties like the shrinkage or strength gain, all these properties comes. So so for that, we have came up with this curing strategies. So which are like in Ladakh condition. If I take Ladakh condition, we observed shrinkage cracks within 2 to 4 hours after printing, which we didn't observe at Hyderabad in the same period. And in halo conditions or at Ladakh, the main driven factors for shrinkage are high evaporation rate because of the low humidity and very high winds, and also the low humidity and insufficient early hydration. Because of the low temperatures, the hydration will be insufficient. So that's why we see a lot of shrinkage cracks within first few hours. And now we have to find a solution. If we don't find a solution, then the project we cannot execute. Even though if we see cracks, then it's a failure project, what I would say. So we found an effective solution to mitigate the shrinkage or early age hydration. So the best thing is to do the proper curing. So immediately after printing, we have initiated the mist curing process, where we'll just spray the water on the fresh layers itself to prevent the plastic shrinkage cracks early ages. And then we immediately after printing, immediately after spraying the water, we wrapped the printed layers with polyethylene plus wet cloth. so which will prevent the further moisture loss. And then we used material, maintain saturated microenvironment to prevent the cracks, so which we did using the polyethylene covering. And after doing all these things, so this is how we have successfully printed. And I'd just like to show a small video how we did printing. So you can see the land, it's completely a barren land. There are not even single plant in the land. Yeah, the team Prabal, the Prabal name itself is for Indian Army, so that's why I was not using the name Prabal earlier. And after successfully printing all these things, this is how the structure looks, and that is a small sentry post again we made for Indian Army. And I am proud to say that SimplyForge is the one and only company in India and across the world who could do the on-site printing at such an conditions, such an halo conditions, and I am proud to say that. And I would like to thank the entire IIT Hyderabad team for that, in supporting all the technical aspects for that. And now the conclusions of the studies are, so at high altitude conditions, the superplasizer dosage increases by 18 to 32%, and also the printable windows remain same for both lowland and high altitude conditions, but the high altitude conditions require higher superplasizer dosage. And there are high chances of early age shrinkage if you don't properly follow the curing protocol at high altitude conditions. And the curing is very important when we go for the high altitude conditions. And halo deployment requires environmental response mixed design and the curing protocol. We cannot use directly whatever we follow the mix protocol or curing protocol, whatever we follow at lowland, we cannot use that. And with that, I'd like to thank you all for listening to the presentation.
Thank you, Mr. Hanuman Nayak, and indeed it's a very proud project for your company and the nation too. Yeah. So now the floor is open for discussion. Any questions? We'll take one or two.
Sir, you have used different types of fine aggregate. One is the robust sand and the other is the locally available sand.
Yes.
And you have compared the climatic conditions variations of the concrete properties. Why you have changed the fine aggregate in both the cases? It becomes a problem of bivariant case, where you are changing the datum value with respect to the comparison with the other parameters.
Yeah,
what
the
is the necessity of that?
Yes. As I explained earlier, the main concept for us is we use locally available sand. So at Ladakh, the robo sand is not available. So that's the reason we use that sand there.
Generally, in the case of research, we take the datum as one common platform and we compare the other variables.
Yes.
Once you are treating both other variables, it is difficult to conclude the results.
Yeah, okay.
Any other questions?
Here, sir.
Nice presentation.
Thank you, sir.
What is low oxygen got to do with it? Because you have said everywhere halo, but did that low oxygen have any effect on your work? That is question number one. Second, the slab.
Yeah. Sir, slab we did, I'll answer the second question first. Slab we did using precast method, like using the conventional method. We casted the slab next to the site and then we'll erect it. And coming to the first question, is when the oxygen levels are low at Ladakh, especially at Leh, the oxygen levels are around 65%. And yes, the efficiency comes down of the thing. Both manpower as well as the robo efficiency comes down a bit. Because the power consumption will increase a bit when the oxygen levels are low. And also the mixing and And also even the diesel, we use DG, there even the DG consumes a lot of diesel to give the same output.
Yes, thank you, sir. Yeah, so now we'll proceed to the next presentation, which is behavior of geopolymer concrete subjected to temperatures up to 500 degrees Celsius by Sesh Kumari. Yes, please go ahead.
Good evening, everyone. Myself, Sesh Kumari, research scholar from Andhra University. I am working under the guidance of Professor K. Srinivas Rao Garu. Today I am here to present my work on behavior of geopolymer concrete subjected to temperatures up to 500 degrees centigrade. So what is the need of the geopolymer concrete? The global impact, what we see is, like we have listened, almost all the lectures were on it, like the global concrete is the most widely used material. So we use OPC cement in the concrete. So where in the production of OPC, CO2 emissions are almost about 7 to 8%. So for that, the sustainable solution is geopolymer concrete. So geopolymer concrete is a low carbon alternative to the OPC cement, conventional concrete. And how it is made is, it is made out of aluminum silicate rich materials such as fly ash, GGBS, which are industrial byproducts, and they are activated with the alkaline solutions. And the strength, it gains the strength by the gels, sodium aluminum silicate hydrate and calcium aluminum hydrate gels. So in my work, I have created the GPC using Alcofine 1203. Why? Because fly ash based GPC requires heat curing to attain earlier strengths, but whereas your Alcofine 1203 based geopolymer concrete, here without the heat curing at ambient temperatures you are able to achieve the target strength. So need for the study is like growing emphasis on the sustainable material, and GPC is the solution for it. And actually why I have used Alcofine in my research is, there are limited research which is conducted on influence of fly ash and Alcofine in the GPC, and temperature studies also. So the present research addresses the gaps by providing the comparative performance of GPC and conventional concrete. So my research objectives are, we have developed a conventional concrete mix design and adopted the same mix design to geopolymer concrete, and we have evaluated mechanical properties such as compressive strength, split tensile strength and flexural strength, and also we have studied the thermal behavior when exposed to temperatures from 100 to 500 degrees centigrade for the different exposure durations 1, 2 and 3 hours. We have adopted the cooling method as water quenching to replicate the real time conditions. The materials used and the mix design is like this. So different specimens were used, and whereas your CC was cured water, conventional concrete is cured in water curing, and GPC is cured in ambient conditions. Yeah. So results and discussions. So here when we compare conventional concrete with geopolymer concrete, in compressive strength, we have observed that GPC is approximately 20% higher strength is exhibited by GPC. Same as in split tensile strength, we have observed that it is GPC has exhibited 39% higher strength than the conventional concrete. When we come to flexural strength also, here we have observed 32% of higher strength when we compare to conventional concrete. So here we can observe the graphs where blue represents conventional concrete and the green represents the GPC concrete. So this enhancement we have observed due to the high reactivity of Alcofine and which led to the effective geopolymerization of fly ash and yields a denser and stronger mix. These are the results of thermal behavior. We have tested for from 100 to 500 degrees for different exposure durations. The red line represents the target strength. The mix design was for M30, so the target strength is 38.25. So almost up to 300 degrees centigrade, GPC almost it is giving the value, like it retained the values above 38.25. So after the 500 degrees exposed to 500 degrees for 3 hours, conventional concrete retained only 26 MPa, whereas GPC retained the 34 MPa of strength. So the conclusions are, alkofine blend geopolymer concrete exhibited superior and sustained strength development under ambient conditions, outperforming the conventional concrete. The inclusion of alkofine created a high reactivity binder system, improving the strength without heat curing. And GPC M30 demonstrated approximately, as I mentioned earlier, 20% higher compressive strength when compared to CC, and 39% higher split tensile strength, and 32% higher flexural strength when we compare to CC. So GPC exhibited greater strength retention, approximately 34 MPa, when compared to conventional concrete, which retained about 26 MPa after 3 hours of exposure to 500 degrees centigrade. So these results indicate that fly ash alkofine blend geopolymer concrete demonstrates superior mechanical strength and thermal stability when compared to conventional concrete. The performance may be attributed to the stable cross-linked aluminosilicate gel matrix in GPC, which reduces micro-cracking, spalling, and chemical degradation, thereby enhancing the preservation of structural integration at elevated temperatures. Ambient cured GPC with fly ash and alkofine is suitable for reducing dependence on the conventional concrete and promoting sustainable construction in structural applications. So these are few references. Thank you.
Thank you, ma'am. Now the floor is open for discussion. You can take 1 or 2 questions.
Madam, you have studied the temperature effect on the
Yes.
geopolymer concrete.
Yes.
Na? Have you observed any breakage of the polymerization during the elevated temperatures?
Sir, actually here I have presented only few results of mine. Even I'm working on the structural members, I am extending the research. Actually that part I have to do it now. Sir.
Yeah, the entire scope should be towards the focusing the
Yes, sir.
what is the polymerization
Sure.
elevated temperature. That should be
Yes, sir.
concentrated.
Yes, sir.
Thank you.
Any other questions? There are no questions. We'll go to the next presentation. Thank you, ma'am.
Thank you.
So just a small announcement from the organizing team. Out of 8 presentations, only 4 have been uploaded till now. So if any other participant is present here, I request them immediately. So the next topic of presentation would be incremental dynamic analysis of G+2 RCC structure with and without wall loads using SAP by Mr. A. Kumar.
Good evening, everyone. My name is Anish, and today I'm going to present on the topic incremental dynamic analysis for a G+2 RCC structure while considering the effects of wall loads using SAP 2000. This is the outline of the presentation that I'm going to present for the next few minutes. Introduction. India experiences a rapid urbanization, and most of the structures that are being built are low-rise structures, mainly consisting of G+2, G+3 and G+4 as such structures. And while modeling and analysis of these structures, we do not usually consider the wall loads. We just consider the wall loads as a uniform load and do not actually model the wall. And this can lead to problems such as underestimating the initial rigidity of the structure, and this can lead to inaccurate seismic performances. And the solution is performance-based seismic engineering. In the traditional design and analysis, we usually design a building or a structure for if it's safe or not. But in performance-based design, we usually consider three performance levels, such as immediate occupancy. In immediate occupancy, we measure the damage. The structure sustains minor damages which are repairable, and it is also operational. Life safety. In this, the structure sustains moderate damages, but these are also repairable, and it is safe for evacuation. Collapse prevention. And this is the limit where the structure collapses. This is the limit where after this limit the structure collapses. And I have performed this PBS approach using incremental dynamic analysis. In this analysis, we take a ground motion and then we scale it to the desired limit and calculate our response. This is the literature review I have used for this study. Objectives. From this literature, we can tell that majorly the literature is skewed towards medium-rise buildings and high-rise buildings. The quantitative data on low-rise buildings is very less, and so this becomes the objective of my study, evaluating the seismic performance of G+2 RCC structure. And in this we considered two models, a bayframe model and an infill model. This is the typical, this is the structural plan I have considered. It is a typical building of 16 by 10 meters, and it consists of 3 stories, a total length of 9 meters. And I have used M30 grade and FE 550 grade of steel. The column size is 450 by 450, and the compressive strength I have considered for the masonry is 4.6 Newton per mm square. And this is the model that I have structure I have modeled in SAP 2000. Model A is bayframe structure and model B is infilled structure. I have modeled the infill structure as a diagonal equivalent diagonal structures using IS code 1893. And the dimensions are also calculated using the IS code, and I have also assigned the linear hinges for both the models. In model A, the wall load is distributed as gravity load, and in model B, it is modeled as equivalent diagonal struct. This is the analysis methodology. First, we model the structures in SAP 2000, and then we select a ground motion. I have selected a Altadena ground motion, and then we scale it from 0.1 G to 2 G, and then we simulate it using nonlinear time history analysis, and from that we take out the output as damage measures. We take the interstory drift and model period. Results. After doing the analysis, we can observe that there is a 50% reduction in time period of the infill structure, this model B. There is a significant increase in the stiffness of the structure, which implies that the stiffness has doubled, which also attracts higher acceleration forces and drift profiles. The drift profiles are calculated using relative drifts for each scaling ground motion. At low intensities, we can observe that infill reduces the drift slightly, but at medium and large intensities, we can observe that the infill reduces the drift significantly. And at medium intensities, we can see that while the bare frame model approaches surpasses life safety, the infill wall just approaches is well within the life safety limitations. The major limitation is that I have only used one single ground motion record for this, which leads to a deterministic study rather than a probabilistic study. And the micro modeling is done as equivalent diagonal struct, which only considers the global stiffness and not the local stiffness, such as openings. Conclusion. And from this, we can conclude that modeling these infill walls significantly increases the stiffness and also controls the drift for medium to high intensities. And for the design implications are that infill walls are very unconservative for shear demand, but very over conservative for drift. These are the references. Thank you.
Thank you, Mr. Anish. So now we can take one or two.
My first question is, have you used the static Young's modulus or the dynamics Young's modulus in the analysis? Which modulus you have used? Young's modulus of the material?
Young's modulus, I have used the static Young modulus.
Once you are doing with the nonlinear analysis, you have to switch out to the dynamic Young's modulus. That's the first question. You have selected the two different time periods for the infill wall configuration and the non-infill wall configuration. The difference what you are showing is 50%. Is it the SAP generated one, or you have calculated it manually?
Sorry.
Why you have shown the fundamental time period for the two types of buildings.
Yes.
One is for the infill and second one is for the
Base
non-infill buildings. You are showing that 50% difference is there. Is it the SAP generated one, or you have calculated the time periods?
It is a SAP generated one, sir.
For each individual case, you have analyzed it?
Yes, yes, sir. And this is also consistent with the literature, previous literature also. So these are validated well.
And one more is a suggestive point of view. Once you are comparing the drift, the reactions in the system is also to be compared, like bending moments, shear forces, and axial forces also to be compared.
Okay, I'll add it in the future scopes. Thank you.
Thank you, Mr. Anish. So now we will take one last presentation by Dr. G. Mallikarjun Rao on a study on strength and durability characteristics of ternary blended geopolymer mortars. Yeah, sorry. One second. Yeah, Mr. Anish.
I was trying to wave out to you, but... Oh.
Yeah.
No, sorry to bring you back. My question is that, have you compared the time period of the building? There is something given in IS 1893 part 1. How does this time period compare with that? After doing all your analysis by this software. See, there is a time period of a building. Yes. So the 1893 part 1, which is based for earthquake analysis, it gives you the recommended time period that you should take. Yes, there is a formula for it. Yes, empirical, yes, whatever you have used, yes, how does it compare?
Yes, sir. I have compared both. And
you compared that?
Yes, sir. I have compared that. There is just about 10% difference. So it is very consistent.
That is something which is a major contribution which you have not mentioned.
Thank you, sir.
Thank you.
Yeah, good evening, sir. My presentation is on strength and durability characteristics of ternary blended geopolymer motors. And these are my contents, introduction, literature review. So there is a global demand increasing day by day because of the means a lot of pollution that is going to be generated because of the production of cement. 1 ton produces approximately 0.9 tons of the carbon dioxide in the atmosphere. So in order to reduce that demand or due to the urbanization and globalization, we want to go for the alternative materials or substantial cementitious materials. So these we are categorized into 3 different types. One is moderately calcium rich cement, low calcium cement and hybrid cements. So for this one we had source materials like which are rich in silica as well as calcium. I had considered these fly ash, GGBS, silica fume, rice husk ash. Like that we had the many alternative materials, and alkaline activators like sodium hydroxide or sodium silicate or potassium hydroxide or potassium silicate. These can be considered as an activator in order to produce that geopolymer. Geo is nothing but earth. Polymer is because of the polymerization process, it is entirely different from your hydration process, where it is going to contribute a certain amount of the strength. So this is the basic concept related to this geopolymer. I need not to go much about this introduction part. So the materials which are rich in silica means a dominating material. It is going to produce sodium aluminosilicate hydrate gel. The calcium based rich materials, it is going to contribute certain amount of calcium aluminosilicate hydrate gel. So these are the phases where first after adding your alkaline activator, the materials is going to be get dissoluted. After that it is going to form rich alumina gel. Later it is going to get compensated with silica alumina gel. Later it is going to have this polymerization process and it is going to contribute the strength. And here this is my basic literature review. So till the studies, a lot of studies are done on this geopolymer. They are done with fly ash based geopolymer, where they are going to take high molarity and they are going to go for the heat curing up to 60 to 90 degrees centigrade for 24 hours. But here we are blended with fly ash plus GGBS. Up to GGBS, if it is very rich, there is a problem that it is going to have the more amount of the alumina content, which is going to contribute the more amount of the strength, but the durability characteristics are getting reduced. So in order to overcome these 2 problems, we had went for these ternary blended geopolymers, and this is the literature I had collected for this geopolymer. And the scope of this investigation, most of the studies are went with heat cured geopolymer, but if you go for the practical or the precast applications, it is possible. But if you want to produce in the in situ condition, it is practically difficult for us. So that's why we want to go with the ambient condition. So entirely our studies are focusing on the lower molarity, and we want to produce this required amount of the strength under ambient condition there. So in order to get that, we have taken this fly ash, GGBS and these bagasse ash geopolymer motors. So these are my objectives, where I fixed this. I had compared both cement motors along with this geopolymer motors. There I had replaced this cement with this bagasse ash with 0%, 25, 50, 75. And later we went for this geopolymer, we investigated. See, up to 30% we had replaced this bagasse ash. So we got the very good results up to that extent. We had compared with both mechanical and durability characteristics. This is the methodology where we have taken our silica based materials and alkaline activator like fly ash and GGBS. We had mixed both the ingredients before 24 hours. After that, next day we started our mixing with these motors of 1:3 ratio. There we had taken this fly ash, GGBS bagasse ash, and we had compared with this prepared the geopolymer motors. And for durability studies, we had done acid mass loss factor and acid strength loss factor, how they are reacting toward that durability characteristics there. And for the experimental investigation, we had collected this fly ash from NTPC and ground granulated blast furnace slag from local Hyderabad. And this we had collected this sugarcane bagasse ash from Tamil Nadu, and we had taken fine aggregate conforming to zone 2 and other acids for this means a durability study. We had used this alkaline activator, the combination of the sodium silicate and sodium hydroxide. See, for these we had fixed it for 2.5, where means sodium silicate to sodium hydroxide ratio we maintained 2.5 constant throughout the study. We had not varied anything, but molarity also we fixed for 8 molar because of the combination of this fly ash and GGBS. But here the main problem with the workability, where we had gone for numerous trials from 0.45 to 0.6. So we got means very good workability at 0.55. So we fixed that one, and later we started casting this. And first we done with the cement plus sugarcane bagasse ash mortars for 1:3 ratio. Later we had gone for this ternary blending in only for the geopolymer. So these are the studies where we had increased our sugarcane bagasse ash for 5%, 10%, 15, 20 and 25. So up to this extent, and 1:3 ratio. And these are the laboratory studies where we had conducted, and these are kept under acidic condition. We are tested for 7 and 28 days, and these are the mixed proportion for 1:3 ratio, and this is the effect of sugarcane bagasse ash with the cement. So approximately we got a very good strength at 100% of cement. Obviously, while we are replacing, we are getting very lower amount of the strength with the replacement of this sugarcane bagasse ash. Later we had gone for the ternary blended with 70% GGBS, 25% fly ash and 5% sugarcane bagasse ash. Like that we had gone for the number of trials where we had got the optimal strength at 70% GGBS, 20% fly ash and 10% sugarcane bagasse ash. Later if we had replaced or we are going for the additional composition also, we are not getting any effect on the strength properties for both 7 and 28 days there. So this is nothing but the means where we kept for the sulfuric acid for 28 days, means 28 days we kept for the outdoor condition. After 28 days, again in 28 days for the acidic environment we had immersed that. But if you go for the means replacement of cement, obviously we got the mass loss like this. If you go for this sulfuric acid immersion with sugarcane bagasse ash individually means with the cement, obviously there was a trend that lot of amount of the reduction of that compressive strength there. But here if you go for the mass loss for replacement of the 70% GGBS, 10% fly ash or 20% sugarcane bagasse ash, the values are trend we had observed that very low means a change in the mass or the strength there. And these are the some of the strength loss after 28 days. If you observe that the strength loss, obviously we got the means highest strength loss in 10%. And these are the conclusions that means we got the optimum strength at 70% GGBS, 20% fly ash and 10% sugarcane bagasse ash. Because of its pozzolanic reactivity up to certain extent, if means it is going to react and it is going to produce certain amount of the strength. Why we obtained the more amount of the strength, where we had fixed our GGBS content, we had varied only, and fly ash content also we fixed. We replaced this sugarcane bagasse ash with the fly ash, and we fixed the GGBS. Because of the reduction or the availability of this calcium content, we got the good amount of the strength. And this is about the ternary blended. Significantly it had the more amount of the acid resistance compared to that of the regular cement mixes there. So these are the references we had gone through, and this is the
Thank you, sir.
Thank you.
Now we can take 1 or 2 questions.
As a variable point of view, you have selected the 3 variables like GGBS,
Yes,
fly ash and what the bagasse ash. And once we are treating this GGBS is the limiting content, then the code specified will be 50% or 55%. The maximum practically that what IIT Madras has suggested for the annual port is 70 to 75%. GGBS is not a highly, in terms of the consistency of the quality is considered, it is not a reliable product. Why can't you have the lesser percentage of GGBS, and why can't you have the higher percentage of fly ash?
Sir, actually, if we go for that's why if we go for the high extent, more amount of the fly ash, initially we done some studies there, but actually if we go for the fly ash based mixes, we are observing very less amount of the strength under ambient condition, and we have to go for a certain amount of the heat curing up to 60 to 90 degrees centigrade. Then only we are obtaining certain strength up to 20 Newton per 20 MPa. But because of only with the fly ash, or we have to go for the high molar concentration like 12 molar, 16 molar. But here the idea is that we want to reduce our molar concentration. Means obviously we want to go with certain amount of the calcium based materials. So that's why I fixed that GGBS content for in order to contribute good amount of the strength there. But yes sir. That's why I fixed that GGBS content. Already means so many studies they done solely with the fly ash, and they have done the combination of fly ash plus GGBS up to 50%. It is very viable to contribute the good amount of the strength. Beyond 50%, what happens because of the presence of this alumina and calcium content, the setting time was very low, sir. Means in the miller only it is going to set very fast because of these molar concentrations. If you go for the higher concentration, the dissolution was very fast, and the setting also going to be fast setting was done. And the means if you go for this acid mass loss factor or this strength is very good, but compared to durability we are observing the low results there. So in the ternary blending also, sir, the both the materials, in order to change that, it is very difficult. That's why we had fixed that one variable, and remaining two we had modified that.
My intention is to minimize the GGBS content.
Yes sir.
It's not a reliable product. You increase other.
Yes sir, definitely sir.
With use of 70% of GGBS in your polymer concrete, once you mix it, what would be the heat of hydration, and what it would affect the durability of your structure? This is my question.
Means in the terms of geopolymer, sir?
Yes.
Means he... Yes, sir.
See the heat of hydration, how much it would impact the durability of...
Means it's a completely different process, sir. Here we are using not the heat of hydration, it was entirely polymerization process. Here the means the production of the gel obviously means if you take this and when we are adding the water for the cement, we had certain restricted compounds are there. It is going to contribute certain amount of the strength at the initial stage we are going to get.
Okay, sir.
But
we'll take the discussion to the later stage, because now we are running out of time for the valedictory. Yeah, so now we have one last presentation. The potential use of glass textile reinforced concrete for wastewater treatment units by Mr. Samantula.
Hello. Yeah. Hello everyone. Good evening. This is Dr. Ramakrishna. I did my PhD from IIT Madras with Professor Ravindra Gettu. Today I'll talk about potential of glass textile reinforced concrete systems for wastewater treatments, particularly in developing economies like India. How to do this? Primary motivation for this study stems from the current wastewater problems in India, for instance. So, in India we generate about 72,000 million liters per day of wastewater every day. So, out of which we have the capacity to treat 20% of wastewater, and the remaining the wastewater is disposed into the lakes, groundwater and agricultural lands as well. So this can cause potential problems to the environment and public health. So that and this particular problem is more dominant in rural Indias and peri-urban areas, because the conventional infrastructure is constrained by several factors. The conventional systems are not easily to be implemented. For instance, we have limited access, transportation access. We cannot easily transport the bulk materials to the rural India. And also inadequate power supply. To operate the conventional sewage treatment plants in rural India, we do not have sufficient power supply. And also we need more skilled labor to operate the plants. So what do we need now? So beyond the conventional systems, we need something that is lightweight, which can be easily transported to the remote parts of India, and which is corrosion resistant. That way we will have less maintenance. And further, the system has to be compact so that we can ensure efficient transport of the systems, which can be easily installed in the space constrained regions of India. So to address that issue, we have a new material technology which Professor Getto had talked in the morning, called textile reinforced concrete, which is basically made of fine-grained cementitious matrix reinforced with textiles, usually glass, to form a stable composite with enhanced engineering properties that could result in thinner sections and lightweight elements, which can also improve the corrosion resistance and eventually reduce the maintenance of the structure, particularly in regions where all these are constrained by access and the power supply. So these promising characteristics of textile reinforced concrete could promote durable sewage treatment plant units in rural India. So anyhow, but what is stopping us? What is stopping us to implement TRC systems in rural India? The main problem is we do not have standard guidelines. To have the standard guidelines, we should have the proper and appropriate experimental design inputs. So this particular work focuses on developing experimental insights for developing the load-bearing TRC elements. For this study, we had used a fine-grained concrete matrix consisting OPC fly ash silica fume combined with the quartz sand, which is reinforced with the e-glass textiles for the economical composite development. And the panels were fabricated using these two materials and then were studied for different parameters. The first objective is to obtain a proper stress strain response, which is used in the design. As we see here, we have adopted two different boundary conditions to obtain the stress strain response of textile reinforced concrete. One is completely fixed and one is a completely rotating type. So as we see here, the stress strain evaluation across the section is quite different, or it is variable in case of fixed end conditions. When we use rotating boundaries, the stress strain is more uniform across the cross section, giving us more appropriate input for the design, as we see here. So this could be because due to non-asymmetric growth of cracking that was again confirmed with digital image correlation that we see in the next slide. As we see here, on the left side, we see the crack growth across the width of the panel using fixed end conditions. As we see, the crack growth is non-uniform. With the, whereas in the right side, we see the crack growth across the panel using the rotating end conditions. So indicating there is more uniform crack growth across the cross section of the TRC panel. So for designing, we need more unambiguous or more clear stress strain response to be used in the design. Otherwise, it's very difficult to choose what input that can be used in the design. So we propose that rotating boundary conditions are the most suitable for obtaining appropriate design inputs for testing TRC panels. This has also been submitted as the standard testing method to Bureau of Indian Standards for the future studies on the TRC. And also for designing load-bearing TRC elements, we need to understand the effect of panel thickness, because we test smaller panels in the laboratory, but when we go to field, we increase the thickness. When we change the thickness, will the behavior be same or will it be changed? That is the question. To study that, we call it as size effect. We had considered the TRC panels ranging from 10 mm to 40 mm by maintaining the same volume fraction of reinforcement and understand both cracking and the strength of composite. As we see here, as we see here on the left, there is a marginal effect on the strength of composite. There is not much effect on the strength of the composite when we increase the panel thickness. However, we had seen a significant effect on the cracking. So as we move from a thinner panel to thicker panel, the number of cracks are reducing. Even the volume fraction of reinforcement is same. And the crack width is increasing. So this is something new that we had figured out in textile reinforced concrete, where we worry about the cracking in composites. For example, water permeability is the problem. So we cannot say that as long as we maintain the volume fraction of reinforcement, we can increase the panel thickness. If you are worried about the cracking, the panel thickness has to be taken into account while we design the TRC elements. So not only the short-term data, we also need long-term data for designing structural elements. Something like tensile creep, which is very important for designing the TRC elements. So to contribute to that, we had pre-cracked the panels. As everybody says, the TRC can be cracked under service and it can be used under service and in cracked state. So we had pre-cracked the panels, TRC panels, up to 0.2% strain and up to 0.4% strain, as we see here on the left side. Then they were subjected to constant pre-cracking stresses for a long time, and to understand how long these panels can sustain the sustained loading. As we see here on the left side, the panels that were pre-cracked up to 0.4% strain could not sustain the load, not even for 1 year. As we see here, most of the panels failed within 180 days, indicating the stresses that are corresponding to 0.4% strain are very critical, can cause catastrophic failure in the panels. This has to be taken care while we design TRC elements for structures. On the left side, what we see is the panels that were pre-cracked up to 0.2% strain. It's been more than 2 years now, the panels are still taking the load without much strains, as we see in the case of the other one. So from this, what we understand is, if we pre-crack the panels, even the TRC at lower stresses, the creep stress is almost at 40% of the composite strength, we can have the stable creep. So these creep parameters can be used in the design.
Sir, please wind up. We are running out of time.
Okay, anyhow. So STP also require a little bit of studies on biogenic acid attack, because the concrete is susceptible to acid attack. So we had studied both matrix and composites using different surface coatings. As MYK presented, coal tar epoxy was found to be the most effective against the biogenic acid attack. And using surface coating, this TRC can be used as the potential material for developing STP units in rural India. So using all the experimental insights, we developed a complete TRC STP at IIT Madras using glass textile reinforced concrete. So as we see here, these are the cylindrical units, and we also have developed the base and cover slabs using the glass textile reinforced concrete. And this is the assembling of the TRC systems. At the end, we see that is the complete setup of TRC STP. It's been commenced. It's been more than 2 years now. The plant is operating well, and the efficiency is found to be satisfactory. So the major conclusions of the study are: e-glass textiles, which are cheaper compared to alkali resistant glass and carbon glass, could be an alternative reinforcement for cementitious composites like TRC. And rotating end conditions can be used as suitable testing methodology for obtaining the tensile response that can be used in the design of TRC elements. And size effect. So even though we maintain the volume fraction of reinforcement, the size effect or the panel thickness should be taken into account during the design of TRC elements. And the creep models or the creep parameters that we obtain can be appropriately used to estimate the long-term creep behavior and the time-dependent strength of the composites. And finally, we say that TRC could be a potential construction material which can be used in the wastewater treatment infrastructure.
Thank you, sir. So now we can take 1 or 2 questions.
Regarding the reinforcing textiles are considered, the strain curve shows the much improved ductility and the higher the strains with respect to the corresponding stresses. But in terms of the creep behavior is considered, you are limiting the creep strains to 0.2% or 0.4%, similar to a normal concrete. In the event of so, what is the basic advantage of using the textile as a reinforcement? We are limiting the strains to a normal concrete strains. That governs the design as per your stress relation, what you are showing. Then what is the basic advantage of getting the textiles as an application point of view?
Correct. So let us talk in terms of strain. If you look at the elastic strain of concrete, it is less than 0.02%. But now we are talking almost 20 times of that, 0.2% and 0.4% strain. So generally we do not allow cracking while designing. What we say is we can crack the concrete and the textiles will take care. So even though, as you say,
my simple question is, this TRC composite technology that you explained, how can it be compared with the ferrocement concrete structures?
so you want me to compare ferrocement and textile reinforced concrete. Obviously we can talk about corrosion.
Here corrosion will be less. In your TRC composite,
Yeah.
corrosion effect will be
So
less there.
since glass textiles are non-metallic, we will not have metallic corrosion. Yeah.
Thank you, sir. So finally, we come to the end of this session. Thank you very much. So we had 5 presentations, and one focusing on 3D printable concrete at high altitude, low oxygen conditions, and 2 papers were specifically on geopolymer mortars and concrete, focusing on high temperature exposure, followed by one on ternary blended geopolymer concrete, and the final one is the glass textile reinforced concrete. So with this, we conclude.
For chairing the session. I now request Engineer Maul Rao to felicitate the session chair, Dr. Durga Prasad. Now it's time for the concluding plenary session before the valedictory function. So the concluding plenary session is Professor Mahesh Tandonji on resilience of bridge construction in climate change scenario. And I take this opportunity to introduce Professor Mahesh Tandon. He doesn't require introduction, but still a few lines, sir. Professor Mahesh Tandon, Managing Director, Tandon Consultants Private Limited, is an international expert in the field of structural engineering. Many of the structures designed by Professor Tandon and Tandon Consultants have been widely acclaimed and have received recognition in India as well as internationally. He has accreditation of International PE India, Professional Engineer India, and is a fellow of the Indian National Academy of Engineers, INAE. He has been appointed as Chairman of Research Council of Central Road Research Institute. He is the recipient of the Distinguished Alumnus Award of IIT Roorkee in the year 2018. He has received the Lifetime Achievement Award of Indian Roads Congress IRC in 2022 in recognition of his outstanding contribution to the highway engineering profession.